And we're back. Welcome to the server virtualization with System Center and Hyper-V Jumpstart. Here with Corey Hines and System Center Simon Perryman. For those of you that are joining us from yesterday, welcome back. And for those that are here today, welcome to the event. Certainly got a full action-packed day today. We're going to be getting into a lot of different things. But first of all, for those of you that weren't here yesterday was a pretty good day. A lot of foundation work on Hyper-V and Microsoft's core virtualization infrastructure. So to give you a sense of what we covered, so that if you weren't here, you can go back and look at those videos and the recordings eventually. We began with a look at how we evaluate an environment for virtualization. So things like the map toolkit and all the different components and tools that go with it. We then moved into installing, configuring Hyper-V. So how we add the role, how we manage Hyper-V, things like the PowerShell providers, things like the MMC consoles, then moving into things like virtual hard disks, virtual machines, and checkpoints. And so some good information there on things like V1 virtual machines versus V2 virtual machines, or I should say Generation 1 versus Generation 2. Gen 1 versus Gen 2 virtual machines. What the differences are, why they're important, VHD versus VHDX, and then how we work with checkpoints, which is the new term that's been adopted for snapshots to make it more consistent. Module 4 covered virtual machine networks. So looking at things like switches, private switches, internal switches, external switches, and also a bit of an intro to network virtualization. Pretty big topic, pretty complex topic. Going to spend some time on it today as well.
That's right.
Moving into Module 5, we covered Hyper-V replica and things like shared nothing live migration, quick migration, replica, extended replica, and also storage live migration. So moving VMs around essentially from anywhere to anywhere with no downtime, and then end of the day with a pretty good discussion on failover clustering. Saw some demos on how to build a cluster, how to configure a cluster, and also move into things like scale-out file servers, which are a huge new capability that was introduced in Windows Server 2012. Today, we're focusing on the next level up in the stack, which is the System Center components. So with Hyper-V, obviously, you get the core hypervisor, you get all the functionality, but from an enterprise management viewpoint, it's challenging to manage a lot of Hyper-V servers unless you have some broad framework that's going to, both automate and administer everything. So, management, monitoring, automation, deployment, all these different tasks. And so to that end, we've got a pretty full day today that focuses on primarily Virtual Machine Manager, but also other components of System Center. So we're going to begin today installing Virtual Machine Manager, looking at how it's installed, the core components, things like the agents, how they're deployed, and how you get an SCVMM infrastructure up and running. We're then going to move into basic System Center management. So how we navigate the UI, how we deploy the most common tasks, like, for example, adding Hyper-V hosts, adding clusters, adding file servers, all those different components and tools. Module 9 is managing the library. Now, what makes VMM great is you can basically deploy services, virtual machines, operating systems with the single click of a button. And this is all done through the library. The library is a collection of objects, things like profiles, operating systems, templates that represent business objects that we can deploy through Virtual Machine Manager. We then move into creating and managing individual virtual machines. So once we've defined the library, actually deploying VMs through Virtual Machine Manager. Once that's done, look at clouds, right? When we think about cloud, we think about the idea of tenants. Tenants are delegated roles that allow you to take logical groups of resources and split them up and keep them isolated. VMM introduces this concept of cloud. So how we define a cloud, build a cloud, and administer a cloud. And then finally, moving into managing collections of VMs that represent services, right? Maybe a service is an application that consists of both a front end and a back end. Maybe there's a data layer, a business layer, and perhaps a web application layer. So how we define services and then scale out services, scale them back, add elasticity, and then finally protection and monitoring. And so at that point, we'll get into things like System Center Data Protection Manager, System Center Operations Manager, and some of the other components of the all-up System Center suite. So, without further ado, let's meet our presenters for the day. So with me we have System Center Simon Perryman.
Thanks, Corey. Hi, everybody. I'm Simon. I am a Microsoft technical evangelist based out of headquarters in Redmond. I've been at Microsoft about 6.5 years now, coming up close to 7. I spent 4 years of that on the high availability engineering team. So hopefully you guys got a lot of good insights about clustering yesterday. And now my focus is all on System Center Private Cloud as a technical evangelist. I have several patents. I'm a Microsoft Certified Trainer, VMware Certified Professional, MCSE, so great certification, the Microsoft Private Cloud one, and this will actually give you some good training and best practices for this private cloud certification as well. And delighted to come and present. This is maybe my 8th, 10th Jumpstart. I've even done a few with Corey, so I'll hand it back over to Corey to introduce himself.
Absolutely. So my name's Corey Hines. I'm a technical old guy.
Okay, technical old guy.
I've been around quite a while, doing everything from began my career doing database development, eventually moved into virtualization, and spent the last 10 to 15 years focusing on core infrastructure, virtualization solutions, primarily on the Microsoft stack, but also on other, comparable sort of products as well. Did some work with VMware, some work with Citrix over the years. Presently own a hosting company, and we do hosting for a very specific scenario, labs, demos, things of that nature. So we run that out of our own data center. We have our own software that does it. And so my life every day is file servers, clusters, Hyper-V, System Center, these things we're talking about here is what I do on a daily basis, getting into some pretty interesting and sometimes crazy scenarios. So today we'll be doing a lot of work with System Center. Simon, you're going to be leading a lot of the discussion today.
Yep.
I'll be helping out and adding in some stuff when I can and where I can. So let's take a look at what our next step is here.
Thanks. So just to kind of set some expectations about the course, this is really designed for IT professionals that are focused on virtualization. Now, even if you're brand new to System Center and System Center Virtual Machine Manager, we'll make sure that we cover the basics today. So on our first module, we're actually going to do a very, very quick overview of all the different System Center components that may get asked about on the exam. Just kind of a quick introduction to the UI. And the reason for that is we look at a lot of integration points throughout the rest of the day, looking at how Virtual Machine Manager can do backup, how it can be monitored by Operations Manager, how it can be automated through Orchestrator. So we kind of want to level set, and this first module will really kind of build a foundation for the rest of the day. Then we're going to focus almost exclusively on VMM, and again, we'll cover the basics, going through all the different features. So if you've done VMM in the past, you'll learn about the new stuff. If you're brand new to VMM, you'll learn about the full product as well. Now, we have some additional training that's available as well. We have a 5-day version of this course that's a mock course, Microsoft Official Curriculum. And then, of course, this is all to prepare you for the exam, 74409. And we had a few questions yesterday. Will just taking this course give you enough information to prepare you for the exam? Maybe not, right? It's tough to say based on your own skills. So what we really encourage you to do is, take this training or take some other official Microsoft training. But that doesn't replace real hands-on experience. That's where you're really going to understand the features, how they work. And rather than just being able to answer questions from the book, you'll be able to logically work out how to actually fix that yourself.
It's pretty important to spend the time actually doing this stuff. I mean, a lot of the things that are in here are conceptual, granted, and knowing what the capabilities are is pretty important. But at the end of the day, unless you go out and actually do this, you have no way of actually making it all click in your head. I spent a number of years teaching and doing teaching Microsoft courses as an MCT myself. Mm-hmm. And the thing that I always stressed to my students was, look, it's fine for me to explain it to you, and you can put the facts back to me. But there's two things. Number one is, if you see anything that's outside of what we've talked about, you're not going to understand it. Yep. And two, when the time comes to actually do this in the real world, you're going to get yourself in trouble. So you've got to take the time just to go do it. And even if you don't fully understand what you're doing, it will all eventually click over time.
Great point, great point. Now, one resource that we have made available that I encourage you to check out if you do want some hands-on experience is the TechNet Virtual Labs. And you can go directly to the link by visiting aka.ms/sclabs. If we could jump to the screen here. And this will take you to our TechNet Virtual Lab Center. And this gives you dozens and dozens of labs covering System Center 2012 R2 and Windows Server 2012 R2. And how are these actually hosted? Could you just give us a quick overview of what actually happens if I go launch one of these labs?
Well, at the moment, I'm terrified that everyone on the chat's going to go try to launch something. And there isn't that much capacity allocated.
Got limited capacity, so don't everyone jump at once. This is to kind of save for your training later.
Say this is for later, not for now. We host these through a platform that's similar in concept to System Center, using a model similar to the idea of service templates that you're going to talk about to deploy these on demand. And they're provisioned out based on average utilizations over a long period of time. And yes, that's kind of where they come from.
Great. And one more time, that address for the short link is aka.ms/SC Labs for System Center Labs. That will again take you to this page, so a great hands-on resource. Don't everyone go at once, though. We don't want to take down any more websites this week.
Yeah, we already took down one yesterday. So.
All right, well, we'll now get started and kind of go through this content here. So what we're going to be covering specifically within this first module here is really just kind of look at the foundations of System Center. Within the first module, how we set it up, and take a quick look at some of these other different System Center components. Now, one thing that's kind of an important change with the release of System Center 2012 is the fact that everything now comes under a single license. So if you've ever done System Center in the past, you would actually purchase VMM as one product, Config Manager as a product, Operations Manager as a product, and they were actual individual technologies. What we've done with System Center 2012 is now integrate them and release them as a single product. And now Operations Manager, or VMM, is considered a component within the System Center product. So perhaps a better way to draw a parallel to this is like System Center is now like Windows Server. Windows Server has Hyper-V, file services, clustering, Active Directory. System Center is now a single product that has VMM, Operations Manager, Configuration Manager. So you kind of got to make a mental shift. And what's been really great about this new change in licensing is you now get all of these tools that you otherwise would have to buy separately. So even if you maybe aren't sure that you want to do self-service, or you're not sure about automation right now, if you get System Center 2012, we're giving you those tools. So it's a good way to kind of feel out these new technologies and start to kind of move towards this private cloud model.
Absolutely. And it's one of those things where when you have everything, why not deploy it?
Right.
Why not put it in production? Even maybe it's not your primary thing. Maybe you've got a monitoring solution already, but if you have System Center, you have Operations Manager, why not put it out there and start getting that additional information back?
That's right, and you'll see throughout the day, one of our big investments as well is multi-platform management. So we're not just managing Microsoft products. You're going to see us convert some VMware virtual machines, manage ESXi infrastructure, manage Linux VMs. And our goal really is to support these heterogeneous environments. And so if you are considering a move over to System Center 2012 R2, you don't want to think of it as, I need to go and replace what I have. What we can do is layer System Center on top, use that as the management platform for your existing investments, and then as you start to make new investments in the Microsoft stack, you can continue to use System Center. So you really want to think of it being able to manage a diverse infrastructure, and it's not a flip over entirely to the Microsoft stack. Now, the reason why we bring that up is you're going to notice this isn't just an exam on VMM. Now, as we look at the System Center components, I'd say probably 80% is focused on VMM, but you're still going to need to know about backup, Operations Manager, Configuration Manager. And if you take any of the other Microsoft exams, such as the MCSE Private Cloud, that's going to actually ask you about all the different components as well. You do need to know Service Manager, Ops Manager. So really the message here is this is now a full suite of products, and we really want you to try to explore all of them. And as you go take these labs, go through the training, you're really going to start to see a lot of strong integration across these products. So let's now go and look at our first round, our first module, into some of our VMM deployment. And we're going to do a quick overview of these different System Center components as well. So first of all, what is VMM? I mean, I think we've hit this pretty well here. It's what we use to go and manage our fabric. And as we alluded to before, Virtual Machine Manager may be somewhat of a deceptive name now, because it really does a lot more. It manages your infrastructure, related services, as well as, of course, your virtual machines.
Now, not only that, it does deployment as well, right?
It does deployment, yep. It does monitoring. It can send alerts.
Absolutely.
It can load balance different hosts.
It does patching.
Does patching as well.
So as an example, we recently took an order of servers in that we worked with our OEM, so we knew what the bare metal management IP addresses were when we got them as the kind of group, a cube of 10 servers. And because we knew all this stuff in advance, we were able to tell Virtual Machine Manager, hey, this is what we're expecting. So when those servers came in, plugged a few power cables in, plugged a few network cables in, turned them on. We didn't turn them on. We used VMM to power them on.
Nice.
VMM told them to Pixie boot, dropped an operating system on there, and with essentially one click of a predefined PowerShell script, we had 10 servers installed, domain joined, Hyper-V, ready for production. VMM did all of that. power, like manages the power. I mean, that's just fantastic.
Very cool. So don't get misled by the name. Think of VMM as Virtual Data Center Manager.
Yeah.
I don't want to mislead people here too much. The branding police will get on me. So that's kind of a brief overview of VMM. You know, we've covered everything here. A lot of enhancements as well. A lot of big investment area. And we'll spend a lot of time going through VMM. Now, App Controller is the self-service portal for VMM. Think of it as a website that has a scope-down interface for end users. And basically, it gives you some of the controls that VMM has, but does not expose you to the underlying fabric and infrastructure. So you can deploy VMs, you can deploy services, both on-premise and up into Azure, but you can't go and actually look at the underlying clusters, the underlying virtual networks or hosts. And the intention of this is just to provide an end-user experience for customers to kind of just, you know, be able to go create VMs, deploy VMs, but not have to really worry about the underlying fabric. And we'll actually go over to our demo system and just quickly show you the interface here. Now, the demos that we're going to be using actually for the rest of the day are all built on the System Center 2012 R2 labs that I'm showing you. Now, I'm pretty fortunate in that I got a pretty powerful host here running 512 gigabytes of RAM. And so with that, I've bumped up all of my VMs to 16 gigs of RAM. So way above recommended value here.
One question for you, Simon, and this is interesting little segue, okay? Because we talk about, you know, people say, you know, all this System Center stuff, and I want to go look at it, but, you know, if you've ever installed System Center, there's a lot of stuff you got to do.
A lot of steps.
Is there a relatively easy way to go install every single System Center component in a couple of hours with almost no work?
Ooh, good question. There is actually. There's a feature. I don't know. Feature's maybe not the correct term. There's a technology called the PowerShell Deployment Toolkit. By the way, this will not be on the exam. It's just a great tip for you if you really want to kind of build your own environment. Check out this technology called the PowerShell Deployment Toolkit, or PDT. And basically, PDT is a set of scripts that you download, you run on your own server, and what it will actually do is go build out a full System Center environment for you. I actually built this System Center environment using it. And basically, you go through a XML file, replace some variables with local addresses in your own file system. So, you know, C, my virtual machines is where you want to store your VMs. Click Run. It will go actually download all of the binaries from Microsoft.com. It will install it. It will create security permissions, connect the products, do things like add management packs, and basically give you a fully functioning System Center environment with pretty minimal effort. I mean, we've actually been building with this, the base build, for about a month now.
Yep, absolutely. So, you know, and the coolest thing is you don't get it'll download everything for you. So you just go, hey, PDT, build me an entire network full of System Center stuff that's running and working, and I know it works. And the service accounts are done, the management packs are installed, the consoles are done, the websites are configured, the right SQL databases are configured, everything's connected the right way, and everything just works.
That's true. It includes the SQL installation as well, and that can be tricky if you're not a DBA.
Yeah, that's one of the more painfully annoying parts of setting up System Center, as someone that's installed it a bunch of times, is getting, you know, the right version of SQL Server for all the different System Center products, because they do vary a little bit. They're not all 100%. It's getting better, but they're not all 100% consistent yet.
Yeah.
And so this will go out and go, okay, here's the versions of SQL you need. Here's the coalitions you need, for example. Here's the update packs you need. Download everything, and, you know, if you've got a really fast internet connection, a couple hours. If you don't, a couple of years. And put everything on a drive, and then just start making VMs for you. It's fantastic.
It's really cool. Corey, would you actually mind posting the link in the chat for the PDT?
Absolutely.
And again, not on the exam, but just a great way to really get some hands-on experience and be able to play around with a similar environment to what I have. Now, going back to the demo system here, what I've actually done now is open up App Controller and open it up inside Internet Explorer. App Controller basically gives you kind of a scoped-down version of Virtual Machine Manager. You see what you're connected to. You can see if you're part of any clouds, if you've deployed any services, if you've deployed any virtual machines. You'll have access to your library, including all types of templates, and you get to configure settings. So again, App Controller is our self-service portal for our virtualization infrastructure. Next thing is Operations Manager, and we use Operations Manager to monitor our infrastructure, and it does diverse monitoring as well throughout the stack. So it monitors the hardware and even different hardware components like fans, network cards. It'll manage your virtualization infrastructure, whether that's Citrix, Hyper-V, VMware. It'll manage your operating systems, your guest operating systems, your clusters, and then even those applications and services running within the VMs. So you've got pretty broad monitoring throughout the stack. And we'll switch over to our Operations Manager console. Take a quick look at that. Here we see System Center 2012 R2 Operations Manager. First thing you're going to notice here is the monitoring workspace, and this kind of gives you an overview of everything that's happening in your environment. We injected a whole bunch of errors here, so we'll get some interesting information to review later. Now, Operations Manager has a concept called management packs. And management pack is essentially a collection of activities for a specific product. And it's going to look for different metrics, different errors, different events. Based on what it sees, it will then go and raise those particular events. So for example, here is a management pack I have for VMware. It's produced by one of our partners called Veeam, and it will specifically go and monitor your VMware ESXi infrastructure, showing you things about failed deployments, different data, show you different topologies, and actually build up a topology map for you. So you really want to continue to think about Operations Manager as an extremely diverse monitoring tool.
One of the great things about Ops Manager, from someone that, we've deployed it, obviously, it will find things you didn't know were wrong.
That's true.
It's terrifying. The first time you deploy it and you go, all right, go look at it. You come back the next day and you look and there's just this litany of red X's, and it's like,
oh boy.
Yeah, like,
I got some work to do.
I thought this stuff was all correct, and it's just, and you look at it and you go, wow, I didn't even know those errors were important, and because I've not gone through the event logs in that level of detail. So it's, the first time you do it, it gives you back a lot of really good information, and just be prepared.
Nice, nice.
It looks at stuff you would have never thought to look at that is actually worth looking at. So
definitely some good best practices. And we're not going to be covering System Center Advisor today, but System Center Advisor is actually a free product which goes and complements Operations Manager. Essentially, Operations Manager does real-time monitoring. It goes and tells you when there's an active problem. System Center Advisor will do proactive monitoring, and it's basically going to go and scan your data center, looking for best practices that are not being followed. And again, I'm going to emphasize this, it is completely free. You do not need System Center 2012 or a System Center 2012 license. The advantage of having that is that you can go and integrate the Advisor data within Operations Manager. But again, it's standalone. So
one of the questions that's come up here a bunch of times is, System Center, are they licensed separately, or is it just one license for System Center?
Single license. So let me quickly cover the different System Center licenses. You're not going to be asked I'm pretty sure you're not going to be asked licensing questions on the exam. We try to keep them technical. But with the System Center license, you have the Data Center Edition. And that's the big one, and that's what we encourage people that are going to be highly virtualized to use, because it gives you some, as far as the number of VMs you can manage, the number of hosts you can manage, it's unlimited, similar to the Data Center license for Windows Server, where you can deploy an unlimited number of guest VMs on that single license. So if you're going to be highly virtualized, you want a Data Center license. Now, there's also the Standard Edition license of System Center, and that gives you all the different components as well, so you still get VMM, all those other things, but it's more limited in the number of VMs and hosts you can manage. So if you're not highly virtualized, yet you still want Operations Manager, DPM, all those components, you can get the Standard Edition. Now, there are also a few different client editions, and those only sell Configuration Manager, or only include Configuration Manager and Endpoint Protection. So if you're only doing client management, you would go for that. But I'm assuming everyone here, since this is a server virtualization course, we want to think about VMs, and so we're going to be doing everything with our data center license. And you can generally assume if there's a question about licensing lots of VMs, the answer is going to be data center.
Absolutely.
Good point, Corey, there. So next component that we're going to quickly talk about is System Center Service Manager. System Center Service Manager really serves kind of two core functions. First of all, it provides a help desk. So you do incident tracking, incident reporting, and it's built using the ITSM, IT Service Management principles, built on top of ITIL, IT Infrastructure Library, built with MOF, Microsoft Operations Framework. Now, I just threw out a lot of acronyms for you. Bottom line is it uses industry standards to actually go and manage your help desk. So you have things such as problems, incidents, work items, configuration items, and it uses a configuration management database as well.
Interesting, you can use Service Manager for a lot more than just help desk.
That's right.
It's an extremely extensible product. There's tools that let you design forms, for example, so that when an incident occurs, maybe it's not just help desk, maybe it's an alert on a storage array on your SAN, and so it can pop up for example a form that allows you to justify why this is full, submit it to somebody for approval to expand the SAN to spend money or something. So you can take it as is, which is very useful. Do very little and you still get a lot of value, or you can go to an incredibly detailed level of customization with form design, with logic, with code to really build custom solutions that address anything that you want.
Absolutely. Those are what we consider the self-service capabilities of Service Manager as well. So let's quickly switch over to the demo here. And this is the System Center Service Manager interface. Now, administration, kind of covers the basics. Library allows you to reuse objects. But what we're interested in here for our help desk, our IT service management, is what we call our work items. And as you look at the interface here, pretty standard ITIL interface. You have incidents, problems, release management. Now, as Corey was mentioning here, it also provides you with self-service capabilities. As I go to my library, we have this concept of a service catalog, which contains requests and services. And essentially, these are different offerings from the IT department that we can go and publish through a self-service portal. So what I've actually switched over to here is a different virtual machine showing our self-service portal for Service Manager. And from here, you can see we have a lot of different things, and they're not just virtualization related here. So, we can create a VM, but we can submit generic incidents. We can add tenants. And so essentially, this is a highly extensible self-service portal that is not dependent on VMM. So we often get a lot of questions. You have App Controller for self-service. You have the Service Manager portal for self-service. Which do I use? Is there some overlap? And the answer to that is yes, there is overlap. Both of them can make requests for your virtualization infrastructure. Now, the difference here is App Controller is much easier to set up. However, it's much more limited because it only works with VMM. It only allows you to go and interact with VMM to provision private cloud, or to go interact with Azure to go and provision to public cloud. The Service Manager Service Portal can interface with anything. So any other System Center component, any other data center component. And what it can actually do is once you go and create a request, it will then go publish this request inside Service Manager, and this can go even trigger automated activities. And these automated activities will do things such as add somebody to Active Directory. It could go provision a new VM.
Yep.
It could go open a new service request, close a service request, go trigger anything else. So long as there's a programmatic interface, meaning some type of script or function, we can go integrate with these different components.
At the end of the day, it's IT lifecycle management, which includes virtual machine management, right? So virtual machine management would be one facet of IT lifecycle management, but that includes things like, hardware, things like user counts, permissions, databases, stuff HR might do. It can address all of that.
Absolutely.
One of the common things I often get asked when we talk about System Center to people is, should I become an expert in System Center or an expert in a particular product? And the answer is you can kind of do both. Every single one of these products that's in here has enough functionality in it that you could spend an entire career on Ops Manager, on VMM, on Service Manager, on Orchestrator. If you really wanted to become an expert in that product, and depending on the level of complexity that and the size of your organization, that may be necessary. So certainly there's enough there that you could spend an entire career being an expert in Service Manager and still not reach the bottom in terms of what all the capabilities and the things you could possibly do are. There's a lot in there.
It is, and you actually bring up a good point here about, a lot of the overlap, a lot of the interconnectedness between these products. Now, I'll give you a little bit of insight onto the engineering side of System Center. Now, in the past, System Center had individual engineering teams for each of the products. So, Operations Manager had its own team, kind of siloed. VMM had its own team. We acquired a company called Opalis, which became Orchestrator, so its own engineering team. And with our older releases, you notice the products were somewhat staggered, right? You had VMM 2008 R2, Service Manager 2010, Configuration Manager 2007. And so they kind of came at separate intervals. And integration between those pieces worked not necessarily great. Now, that was the older version, and since 2012 came out, we've realigned with this goal of making it a single product. Our engineering teams have consolidated, so we have single management. Our release cycles and our development cycles have consolidated. Everything's being built on a single framework using PowerShell. So our APIs are consolidated, our scripting is consolidated. And at the end of the day, this is going to give a more integrated, better functioning product. And we're seeing some of our competitors in the cloud management space. Now they're really trying to catch up with us. They're acquiring these individual components, things similar to Orchestrator or similar to Operations Manager, but they're still being run by different teams, different organizations, and these parts don't really fit together as well yet. So this is something that is a big competitive advantage of System Center, and you're going to see throughout future releases as well, even tighter integration across these products. Now, next component we're going to cover here is System Center Orchestrator. My favorite new product. It is love it. Amazing.
Absolutely,
it's like one of the best things we've added in years, at least on the data center.
No, absolutely, because one of the biggest challenges that has always been there is how do you automate the data center?
These diverse systems as well, right?
Knowing the individual automation capabilities of everything from each individual product that's involved, VMM, Service Manager, Operations Manager, all these different pieces. And then if you take the average, guy that needs to automate the data center, they're not coding experts, right? They're, for them, it's download a PowerShell script, edit it, and then wonder why it didn't run properly.
Right.
That's reality. I'm not, I'll respect everybody, but that's what typically happens. Give me a nod in the chat if you agree with me. What Orchestrator does is it makes scripting graphical. So you can now do flowchart style design,
like Visio.
Yeah, Visio, exactly. So I want to go from a user account into a database. You can draw it and draw arrows, and it worries about the code for you. Now, certainly understanding conditional logic, looping, things of that nature helps as you build these things and make them more complex. But simply taking a user account, provisioning it to Active Directory, making a new VM and assigning it permission, they become graphical steps where you just click them, draw arrows, configure properties, and worry about it to actually do all the work on automation. Failing, it'll take care of the failback if something goes wrong, does all that for you.
Yeah, it's great. I mean, really, best way I describe it is integrated graphical scripting, tying together all of these diverse systems. And that's a big advantage Orchestrator has, giving you the ability to pass parameters from one set of activities to another set of activities, even if they're completely independent functioning systems. So let's take a quick look at our demo here.
Before you do that,
yeah,
integrated graphical scripting, I think my head just exploded.
That's the easy way to describe it. So what you're going to see here with Orchestrator, we're actually showing what we call the runbook designer here. And this is what we use to go and actually build our different workflows. Now, to give you a quick view of the interface here, we have some organizational navigation panes on the left. On the right, we have what we call our integration packs. And within an integration pack, we have what we call activities. Now, an integration pack is basically a collection of different actions for a specific system. So we can take a quick look at some of the ones we've added here. We have some system variables. We can do some monitoring, file management, email. Well, then you can see integration with third parties like Cisco UCS, F5 load balancers, Team Foundation Server, SQL, Exchange, Azure. Going down the list here as well, we have we have all the other System Center components. We have third-party management systems, so HP ILO, Active Directory, DPM, VMware vSphere, Exchange, SharePoint. So pretty rich set of components here.
And so when you select one of those components, it's going to let you configure properties specific to that product. So, for example, you don't need to know what all the information is you would need to supply to make a user, for example. It presents you, just type stuff in here that you need.
Absolutely. So, let's take a VMware vSphere activity. We'll go drop it into this new runbook. It's loaded. We can go say, I don't know, add a new disk, clone a VM. I'm just kind of making one up on the fly here. Connect the dots. go configure some properties for this disk. So what's going to be the name of this disk? What's going to be the path of the disk? What is going to be the size of the disk? Then we could go and trigger this. And so every time a specific set of metrics are met that goes and triggers this workflow will run. So, and again, you can pass these parameters between all of these diverse systems. So, here's a quick sample run book that I built that looks at checkpoint management. Some things that are interesting to note here are you have conditional statements. If it passes, do this. If it fails, do this. You could go split activities based on variables. You can go right to event logs. So if one of these workflows fails, Operations Manager can go detect the error. So a very rich set of tools here. And then Data Protection Manager. Data Protection Manager is basically our backup solution, protecting our hosts, our virtual machines, and our other infrastructure. And as we go take a quick look at our DPM environment, say a relatively simple interface here. You get monitoring information. You could go protect disks, go recover disks, or services or VMs. There's some reporting capabilities with pre-created reports. Then you could go add new disks that you want to use for protection.
I'm actually a real big fan of DPM. I think as a backup product, quite thorough, quite good. Now, certainly not as robust as some of the partner products that are out there. You mentioned some of the stuff that Veeam does, for example.
Yep.
But as a product you get with System Center, very, 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 very powerful. And I think a lot of people just kind of write it off and assume it's not good enough. We use DPM for our primary backup solution, and it's fantastic. I mean, we run it against SharePoint servers, against SQL databases, everything, and that very easy self-service granular restore. Upload the wrong file to SharePoint. Give me the version from a couple of hours ago. Just DPM just has it. It's awesome.
Nice. And it, of course, supports backup for all the other System Center products. So I guess something else that we have not mentioned yet is that all of the System Center products are run using a SQL database. There's no local database, JetDB database. Everything uses SQL Server Full Edition. Now, in the previous releases of System Center, it actually used SQL Server Express. With this release, we're using SQL Server Regular Edition, Enterprise Edition, Standard Edition. And when you get a System Center license, you also get that SQL Server license. So you don't have to worry about any additional acquisition costs to actually go and be able to run System Center. That license is included in the suite. Now, the final component that we're going to cover here is the Windows Azure Pack. We talked about this briefly yesterday. Windows Azure Pack is essentially Azure services that run in your own data center. So if you like the familiar look and feel of the Azure web portal with a gallery of images, easy to set up virtual machines or websites, you can do that yourself now using your own on-premise resource with the additional control that you have of the fact that you're running it yourself. So you can get past some of the limitations or restrictions around running a VM or a service up in Azure. Now that wraps up the first lesson. Now we're going to start to focus a little more on VMM.
Okay. So our next module here, our next lesson deals with specifically, man, I'm having a hard time with that this morning, Virtual Machine Manager. Start by taking a look at what it is, what it does, where it comes from, and then the concept of fabric management. This is a new concept for VMM that started with, I think, 2 versions ago. And if you start thinking about Virtual Machine Manager, what you've got to remember is that it's not about just virtual machines. It's about all the supporting data center infrastructure that allows virtual machines to be possible. So this includes everything. This includes switches. It includes load balancers. It includes storage, file servers, fiber channel arrays, and the individual hosts and host clusters themselves. So all these things together make up what's referred to as the fabric for Virtual Machine Manager. We'll then start to look at the architecture so you kind of understand the idea of, most System Center products use this central management service and agent model, as VMM does. We'll take a look at how that works, and then take a look at some topology options. Do you have one VMM server? Do you have a cluster of VMM servers? And how does that all kind of work together?
So with VMM 2012 R2, some of the biggest enhancements we made in this release are around performance. We're seeing huge uptake in VMM adoption, and so we want to make sure that we can scale and support some of the largest data centers. And so for each VMM management server, it supports up to 1,000 hosts and 25,000 virtual machines. Now, of course, you could have multiple servers as well. So if you have more than 1,000 hosts or more than 25 virtual machines, good for you. You can go and actually still have multiple sets, multiple instances of this. Now, under fabric management, what we're really focusing on here is looking at kind of the core features. So managing our network, storage, power, updates, different virtualization platforms, and then some of our bare metal deployment, which we're going to show shortly. Here's a diagram of the core VMM architecture. And in the very middle, you see what we call our management server. This is essentially the brains of Virtual Machine Manager. And through a management console, you will go and connect to this management server. Now, you can have multiple management consoles running on lots of different computers, and they can still connect to a single management server. Now, the management server stores all of its information about the different users, VMs, roles, state, all of that data that it's going to refer to inside a SQL database here. VMM connects to our different hosts, so managing up to 1,000 hosts per server, 25,000 VMs, and then it goes and pulls additional resources from the library. We'll spend some time talking about the library later. App Controller is this enhanced add-on, our self-service portal. Allows you to go and manage it through a website. And now if you want to look at the high availability architecture, you can note that VMM can be made fully redundant. Now, what we actually do with our management server itself is we can go and deploy that directly on top of a failover cluster. So not within a virtual machine running on a cluster, but directly on the failover cluster itself. It now has its own resource DLL, which means the failover cluster is aware of the different actions VMM needs to be started, to be stopped, to detect the health, detect when it's failed, and to be able to fail it over between different cluster nodes. The SQL database can be made highly available using SQL clustering. So SQL Always On or earlier versions of SQL. You know, you can still you can back up all of these different components as well using Data Protection Manager. And if you have redundant SQL databases as well, you can even do disaster recovery using them, backing up the databases, doing things such as database mirroring.
So I know this has been a particularly important point for folks that are looking at this from a very large scale, because if you're looking at investing in VMM as something that's going to manage a very large implementation, you want to know that it's going to be highly available and be redundant. And
it's important.
This capability, which is new, is fairly important in that sense. So.
Yep. And for our library servers, a library server is a file server. That can also be made highly available using file server failover clustering. So you can have multiple instances. Now, question. Can we use a scale-out file server to go and manage these library shares and all these different components within our library?
For VMM, I don't know, actually.
We're going to say the answer to that one is actually no. You don't want to use a scale-out file server, and the reason for that is it's not designed to go and handle all these individual types of files. So when you build this scale-out file server, it's really optimized to run virtual machines or to run virtual machine files, the VHD file. So you don't want to go use a scale-out file server for this. You want to go use a traditional clustered file server for this, as we're just managing regular files as in their regular objects. Now within network load balancing, within App Controller, which is our web interface, we can use NLB, network load balancer, to distribute the traffic. Going back to our discussion yesterday, when do I use clustering? When do I use network load balancing? Again, you use clustering anytime you need consistent central source of information. So we use clustering for our SQL database. SQL database is on shared storage, consistent source of information. We use failover clustering for our library server as well. So we have a single source of information. All of that data is stored on the shared storage. However, for our websites, we're not actually storing data on those individual website VMs. They're still connected to Virtual Machine Manager, which is connected to SQL. So those actual websites, the App Controller web portal, that can use network load balancing. All it is an access point. It's not actually sharing data within that particular server. So we just can go deploy multiple instances for redundancy and to help distribute clients as they go and access these different app controller servers. So this kind of puts together this different topology here, right? We've got our different servers, got our different hosts, but then we can also think about extending up to the public cloud. Now, we support Windows Azure through App Controller, and so using the same web interface, we could go and deploy our virtual machines on-premise and up to Azure. And a little later today, we're even going to talk about a third option for App Controller, which is deploying it to a service provider's data center. So if I run out of capacity in my own data center, I want to start using whole systems to go and scale out. I can actually manage my own VMs, get reporting data, operate them even though they're running in someone else's data center. It's basically hosting as a service this enables.
Absolutely.
While still getting, their own rich monitoring capabilities.
So moving on to our next lesson here, take a look at how we add this concept of hosts and host groups. Host groups are a particularly important concept to understand within Virtual Machine Manager, because the temptation for a lot of people would be to just have one host group and dump all their hosts in there. But the way you organize your hosts into groups comes into play down the road as you begin to define clouds, policies for power management, policies for dynamic optimization, and things of that nature. And then look at deploying Hyper-V to a bare metal computer.
Yeah, you've been mentioning that a few times. I've actually got a demo to show people as well.
Absolutely.
So first of all, what are host groups? Host groups are essentially a management unit within Virtual Machine Manager. It allows you to organize your different infrastructure servers. So how do people organize them? Some people do them based on geography. So I have one data center, that's host group 1. Second data center, host group 2. Now this allows me to delegate, do things such as, provide specific admins access to only one data center or only the other data center. Another way we see people organize host groups are things such as clustering, and so they can organize them based on the actual function for that particular group of servers. Another way people do it is based on the actual hardware, the different types of systems. So maybe high performance using fiber channel is one host group. That's where we're going to put our production systems. Maybe we then have a second host group that uses some older servers and iSCSI. Maybe that's a testing environment. So we have a lot of different organizational ways to go and plan these host groups.
Yeah, there is no right or wrong way to do it, quite frankly. It's whatever works for you. However you think about logically managing all your hosts, the host group model allows you to mirror that.
Now, what do you do when you go organize host groups? What's kind of some ways that you've gone and planned
The
that?
most common way is by technology. So it's based on hardware, performance, capability. That's typically how I see it done. I don't see geography that often, although sometimes, and you can actually nest host groups as well. So you can have geography, then group, then function. But typically it's based on the capability of the host group is most commonly what I see done.
Great. Now, final topic before we jump to some demos here is looking at doing bare metal deployment. Now, key thing here with bare metal deployment, as Corey mentioned earlier, is you could really provision things end-to-end, from literally having a brand new server dropped off in your data center, plug in those redundant power supplies, redundant internet connections, and then you can go and provision this, add it to your infrastructure, and then even do, once you've provisioned a host, even make it highly available by adding it to a cluster. Now, rather than kind of walk through the steps, let's actually show them. We'll jump over to our first, or our next demo here. And what we are doing here is taking a look at the Virtual Machine Manager interface. Now, what we're going to do here under our Fabric, and again, as we kind of look at the different workspaces, we're going to spend quite a lot of time in VMM. Fabric is our infrastructure. So think of Fabric as core infrastructure, storage, network, virtual machine hosts and clusters, and then those supporting components. So you may get some questions on the exam. Which workspace would you navigate to do this particular task? If it's anything related to the infrastructure, the answer is going to be Fabric. If it's related to virtual machines or services, basically things that run on top of the infrastructure, that's going to be in your VMs. And if it's anything related to a template or building some type of standardized practice that will be reused in the future, that's going to be under library. So in this case, we're going to go and provision some bare metal clusters. So where would that be stored under? That's going to be done under the Fabric workspace because we're touching our infrastructure. So let's go ahead and say we want to go and add some resources here. We're going to go add some Hyper-V hosts. Now again, this is a server that I've just plugged in. I actually think there's about 30 in this array here that are plugged in. So we're going to say I want a physical computer to be provisioned as a virtual machine host. Now, next thing it asks me to do is provide a run as account. So this is pretty standard. But what I want to really highlight here is this concept of a baseboard management controller, or a BMC. Basically, a BMC is kind of like a lightweight operating system that's installed by the OEM that allows you to do some basic functionality. So once you connect it to a network, it can get an IP address. You could go and send commands to it. It could go and actually monitor some of the hardware, such as the memory, the networks, the hosts. And using that interface, this BMC, we can then go and make it Pixie boot, go add an image. So we're basically almost interacting with this as kind of a pre-operating system before we actually add our own operating system on top.
So, you know, in reality, in the Dell world, that's iDRAC, and in the HP world, that's ILO.
Thanks. Yep.
I don't know what Cisco or IBM call it, because I don't own any of their gear, but that's for those of you that actually have that gear. Dell's iDRAC is what does this, and HP's ILO is what does this.
Right. So what we're basically doing here is we're going to go speak to this BMC, and we'll select what protocol we want to use. It uses the standards IPMI and SMASH. That could be a question here. You know, occasionally we do get questions around protocols, what protocol to use. So it is a good best practice here to understand the different BMC protocols we support, the different networking protocols we support, as well as the different storage protocols.
At the end of the day, the protocol you choose is going to be what the hardware vendor tells you to choose. For example, the Dell iDRACs do IPMI quite well.
Thanks. So after we've gone and said how we're going to go communicate with this bare metal server, we then get to go provide either that specific IP address that baseball management controller got, and this it received it from a DHCP server that was on the network. And then I get to go and paste in some IP address ranges if I want. And what this means is the particular server I'm looking for is somewhere within this range. So it's going to go scan, and here's the 30 or so servers that I have available for deployment based on that IP address. And I could go and deploy multiple servers at once. So if I wanted to go provision 30 servers at the same time, easy to do. Just do select all. But we'll keep it simple here and just select the first one. Now it then asks me what host group we're going to go and put this in. We'll go back to our host group demo shortly. Then it goes and asks us for customized information for this particular server. Now remember, up to this point, we've basically been assigned a random IP address, and there's no Windows management system on top of this bare metal host. So what we are now able to do is provide that Windows-related information so that it can be up and running in our infrastructure. So I'm going to go type in the computer name here, call this Contoso HV01. We could go use a default MAC address, or let me go paste in this predefined one. And then we can continue using the existing IP address, or we can go and add a new one. And in this case, I'm going to go and paste in our existing one. So no changes there. But we have gone and provided it with a name, so that once this joins our infrastructure, we can start actually interacting with it. Click Finish to confirm the settings. And we can now see that this host has been added, and we're starting to go and provision it. So that gives us kind of our introduction to the steps to go and provision a bare metal server. But before we wrap up this module, I'm going to go and create a host group and go and add an existing server that's already provisioned. And we'll go and switch back to VMM here. Minimize app controller. Maximize Virtual Machine Manager. All right, back to our interface here. And we'll now go ahead and start to create our host groups. Now, remember, when we're doing a host group here, we're really thinking about this as an infrastructure supporting role. So we're going to go and add this under our Fabric workspace. I'm going to say create a host group. And this is optional, not required. We'll call this Contoso. So that's simple. We now have a logical management unit. Go create a second one, and we'll call this our DR site. so that we'll go and manage our second set of resources in a disaster recovery location. So this kind of allows me to split my data center between my resources. Now, if I go take a look at all of the hosts, we see that there actually aren't any hosts that I've added to VMM now. We have our second infrastructure that's going and added that bare metal host, but we're going to go cooking show style and add one that's already been baked. So we're going to go here and say add a new Hyper-V host. We're going to this time say that this is a Windows server in a trusted AD domain. So previously we selected this physical computer deployment. Again, this is inside AD. Now, some of the other options you have here are to go and add a Windows Server computer in an untrusted Active Directory domain or in a perimeter network. Now, when you go and work with a untrusted domain, you have to go and configure some additional security and firewall settings so that we can go do that initial provisioning of our agent and start communicating with it. If you have VMM agent inside a perimeter network, you actually have to go and install the agent locally, meaning that you would go take the VMM setup component, log onto that computer locally, and install the agent manually. Now, let me take a step back here. The VMM agent. Essentially, the VMM agent is a component that gets installed inside managed computers and allows Virtual Machine Manager to go and manage it. Basically, this agent collects data from the local host, interesting data that the VMM management server cares about, such as what's the memory, what VMs are running on it, and it will go and push that information back to the central VMM server. The central VMM server goes and aggregates this information across all of the hosts that it supports, and then goes and presents it through the single interface. Now, you're going to notice that all the different system center components, for the most part, they do have agents that go and collect this data, report it back. There's a few exceptions, but those are going to be out of scope for this virtualization exam. All right, back to adding a host here. We're going to go specify the credentials that we want to use for this host. So I'm going to go select an account. Click Next. So they're going to give me the option to specify my computer by name, or to just go and scan and just go scan Active Directory. So I could go generate a search query here. So, you might get asked, hey, if you need to go find all of the different hosts in your Hyper-V or in your VMM infrastructure, how would you do that? You could go to the Find Computers option by generating an Active Directory query. Go search for all workstations and servers, because this is going to go and skip your domain controllers, things like that. Now go create an Active Directory query for you, and it'll go list all of the different servers in your environment. So you have several different options of how to actually go create and go and view this information. And so this has basically gone and providing me with all of the different hosts I have in my infrastructure. And it even shows me different clusters as well. So you're going to see us do some cluster management a little later. If there's a Hyper-V hypervisor already installed, it'll let us know about that as well.
One of the questions that's come up here a couple of times now is, can you add hosts that don't have Hyper-V?
Yes, you can. Great question. We're not going to demo that because that just kind of takes a little longer. But if you added a host that did not have Hyper-V, so let's say I selected, I don't know, this host here, we can see there's no hypervisor. So we actually go through the wizard, might even be the next screen, it's going to prompt me and say, hey, Hyper-V role may not be enabled. As part of this process, we're going to automatically install it. Please know that it's going to require a restart. Is that okay? And if we wanted to continue with this VM, we would actually go into it and it would go and add that Hyper-V role for us. Now, to save the time and to skip the reboot, we're just going to go manage one of these existing servers. And in fact, the server that we're going to go and add right now is the same server that I'm running VMM on. Now, yes, what you're saying is, wait, are you actually running Virtual Machine Manager and virtual machines on that same host? In this demo environment, I am, but this is not a best practice.
No.
Definitely not. We really want to separate our hosts and have virtualization hosts only running VMs, have management systems only running those management systems.
Now, can you run all these System Center components as VMs?
Yes, you can. And in fact, that's actually what we have here. If we go back to the interface here, you'll see that I have this single Hyper-V host. Every single System Center component is running as a VM. And there's actually some benefits to this as well, because it gives you some high availability.
Absolutely.
You can live migrate the VMs while the components continue to run. If the actual VM crashes, we can restart it. The System Center service will start within it. So if you're trying to build additional high availability through the rest of your System Center infrastructure, placing them VMs is actually recommended. The only component that will run bare metal on top of a failover cluster, Virtual Machine Manager. So again, VMM, best practice, run it directly on a failover cluster. Everything else, run them inside VMs. But you can run Virtual Machine Manager inside a VM as well if you want, fully supported,
Absolutely.
and that's actually what I have in my lab here. Good questions coming through. Keep them going, guys. So here we've gone and we've selected our host that we're going to add. Click Next. Get the same warning. You're actually going to see this warning every time, regardless of whether Hyper-V is already enabled or not. So don't let that trick you there. Now it asks me which host group I want to go and put this under. So we'll put this under the newly created Contoso group. It also gives me the option to go and change the default path that I want to store my virtual machines. So they're going to use the C program files, Hyper-V, as the kind of the default, unless you want to go change that. And we'll actually go configure that a little later. Skip this for now. Now, one of my favorite things about Virtual Machine Manager is that everything is built on top of PowerShell. And so as you get to the end of any wizard screen, you're going to see this option here for View Script. You click that, it will show you all of the PowerShell commandlets that have been used to go and generate this particular set of activities.
That's one of the most useful things about it because, a lot of people ask, well, I want to automate it. I want to do it a bunch of times. This is a big script wizard.
So you said if you wanted to go and add, let's say you wanted to go deploy 30 bare metal servers.
Yeah. Why click through the entire wizard 30 times when you can do it once and then with a little bit of scripting knowledge, create a loop? And just run the script a bunch of times. Completely supported.
And we'll actually do that a little later with creating some VMs that we do based on PowerShell. So we're going to show you how to do that, how to even integrate and launch PowerShell scripts through VMM. So some really powerful capabilities here. Another thing I find people use this for is to actually start to learn PowerShell. Right? If you're brand new to PowerShell, like any kind of scripting language, it can be a little overwhelming to get started. If you're kind of doing these operations in your head, you understand the wizard flow, what you start with and what the end result will be. By actually understanding that PowerShell commandlet that can be used to build it, it's a pretty good education tool to figure out, to do anything first I need to load credentials, then I need to create a new object. This is how variables work. So a great way to kind of ramp up with that as well. If you do want to look for additional training on PowerShell, Microsoft Virtual Academy has several PowerShell courses that are a great way to get started as well. So now we're going to go click Finish. What we're going to see now is what we call our jobs library appear. So anytime we perform a task, you're going to see this window pop up. It just gives you the status of the task. We click on the task, it breaks it down to the individual pieces of that task that are being executed. So we can click on the details and see what's happening. Now there's also a tab down here called Change Tracking. Change tracking will be used if properties or variables have actually been changed on an existing system here. Now in this case, we're just going and adding a new host, so we're not actually changing any properties on that SCVMM host itself. We're just changing the configuration within System Center. Now this is saying my host has been successfully added. It's giving me some warnings for best practice. It's been added successfully. If you want to go and now enable MPIO, go to a restart. In this case, we're not going to worry too much about MPIO. Best practice would be to use that, have that configured. So I'm going to go close the jobs window. And anytime we want to go and view the historical jobs, those get tracked down in the jobs workspace. So I can click down here, see any running jobs, see my historical jobs. And one of my favorite features as well here as well is the restart button. If any job failed, at any point, you can actually go and restart that entire job, and it will go and rerun that underlying script.
So yeah, the idea is you don't need to run through the wizard again. This just takes the PowerShell that the wizard produced and just says, okay, try again.
So a good example might be you're going to try to deploy a VM or deploy a cluster. It goes through step 1 through 20, and then as you're trying to create this new cluster, one particular piece fails. Maybe cluster validation fails because you're missing a particular required patch or something like that. Well, you don't want to go through that whole wizard again, go through the 20 steps. Go make that fix, and then just click restart, and it'll rerun all of that script again without having to go through that entire wizard again. All right, let's go back to our fabric. we now see under all hosts that our SCVMM server has been added. So it's online, it's healthy, and we are now stable. We've gone and added our first server to VMM. So that wraps up the first module we have here. To kind of summarize what we've done, we've basically done a quick introduction to the System Center components. We started to understand some of the interconnectedness and capabilities between them. Then we've looked at some of our core virtualization infrastructure deployment using Virtual Machine Manager.
All right, so we'll take a little break here now. When we come back, we'll take a look at managing with Virtual Machine Manager and get into actually configuring different elements of the infrastructure, different types of servers and roles. So we'll see everyone back in about 10 minutes. Hi, welcome back to Microsoft Virtualization with Hyper-V and System Center. Corey Hines, Simon Perriman, here to look at Module 8, which is Managing Infrastructure with System Center Virtual Machine Manager 2012 R2. This particular module deals with a lot of topics, primarily focused on how we manage the elements that make up our virtualization infrastructure. So that includes things like networking, it includes things like storage, how we deploy and manage updates, and also how we work with clusters in Virtual Machine Manager.
Excellent. So we're going to start by looking at our networking infrastructure. Now, yesterday, Corey and I, we spent some while talking about the basics of network virtualization.
Absolutely.
We're not necessarily going to repeat that. We'll just kind of give the quick overview in case there are some people that weren't able to attend yesterday. But this whole module, we're going to go demo heavy. Rather than really talk about how it works, let's just show you. Let's go create all these different networking components. So first of all, let's go through a summary. What can we do within our networking? Well, as we've talked about with infrastructure, we're kind of covering everything throughout the stack. And you'll see here on the right, under networking, we have quite a range of different networking components that are managed. Now, as we start to think about what is a private cloud, one of the key tenets is pooled resources. And what that essentially means is you're able to aggregate and manage all of your resources from a centralized location. Now, generally, storage is kind of the most commonly used example here, right? It's easier to kind of logically or conceptually understand pooled storage. You need storage. There's this big cloud of storage. You take some. But networking has a very similar concept. With our networking, we pool our networking resources as well. So if you have a variety of load balancers through the environment, we can go interact with them and go use them as we create new services, new applications. And we're also going to be creating a lot of network type templates that we can go deploy on our hosts that configures the networking on that host. Templates that we could use for VMs, templates that we can use for ports and different types of port classifications. So you're going to see us use these consistent private cloud best practices, concepts throughout all of our infrastructure. So not just our servers with memory and CPU, not just storage, but also networking. So what is our networking infrastructure here? It consists of a few components. We have our basic management systems, we have logical networks, IP address pools, load balancers, network virtualization. We're not going to go define all of these yet. We'll do that as we go through our demos. We also have the ability to go and configure different ports and different switches within VMM.
So one thing I just want to really quickly interject here. You're going to see a lot of these terms like logical switches, port profiles, uplink profiles, virtual switches. It's important that if you're going to work with VMM, you understand what these are. So take the time to learn what the definitions of these objects are. Otherwise, you're going to find yourself pretty confused down the road. So for example, know what a port profile is as opposed to an uplink profile. Know what the different types are. Know what a logical switch versus a virtual switch is. Again, it will help you to take the time to just understand the definitions that are used in the product.
Absolutely, and we're going to be going through these individually as well in a second. The next concept we want to bring up again is this concept of using virtual networks, network virtualization. Now, with virtual machine networks, these are built on top of our physical networks, our logical networks, and it essentially just abstracts and simplifies our networking. And what we're going to do is we basically go and define what a network is. So you say we're going to create a logical network, and underneath that it's going to actually have your real subnets, your real sites, your real IP address pools. But the conceptual concept here with network virtualization is simplifying it. And basically what this means is when you've gone and created your new logical network, let's say it's called Contoso network, when you now go and deploy a new virtual machine, you just say, I want to go deploy it to Contoso network. And we actually figure out what that really means, where that VM should live, what it should be connected to, what virtual networks, what network adapters, what type of privileges, permissions it has, if there's any associated VLANs, and also what IP address it can use. That's part of that network.
You know, as you stop and start to plan an implementation of a network with Virtual Machine Manager, one of the most important steps that you can actually take is to diagram everything. To sit down and go, okay, here's the data center that I'm going to work in, here's all the subnets and here's the routers, and you draw a diagram. You see, okay, this my data center, which is a big 10.xx subnet, that's going to be my data center subnet. And then I can use that to begin, as I build this diagram, defining the objects that are going to get created later. If you just jump into VMM and start creating stuff, you're going to get in trouble. You've got to take the time up front to diagram everything, draw it out, and sit down and plan it before you begin actually creating the objects in there. And where that starts to help you down the road is, you know, as you define a new VM, as you were saying, as you define a new VM, when you create this network object called data center that represents, let's say, your core LAN in your data center, you call it, you know, data center. You then go through all your hosts, and based on the IP addresses the host has, so you say, you know, data center 10x subnet, every host that has a 10x IP address will associate itself with that object. So when you go to deploy a new VM later and you say this VM needs to talk to data center, it's going to look at all the hosts and it's going to say, okay, which hosts have associated themselves with data center, so they become candidates to host that VM. And the same is true for when you go to the next level of abstraction, virtual networks, right? And then as you take that even a step further, you say deploy to data center where there's a fast connection. And maybe you define fast connection as a 10 gigabit connection. So now all the hosts understand the definition of fast, understand it requires 10 gig, and if they have an adapter that's 10 gig on data center, they label it and they tag it that way. So you never have to worry about where something physically is. All you've got to do is define the properties of it, and VMM, by nature of looking at all the different physical elements, determines where things can live.
Great point. Now we're going to switch over to our demo and actually show this in action. So this is our VMM server. Now we're going to be working within the Fabric workspace once again, because networking is considered part of our Fabric. If we minimize our servers, go and expand our networking, we can go see all of these different networking components. So let's actually spend a minute and quickly kind of talk through what each of these items are. First thing we have is a logical network here. And a logical network, it's essentially a definition of the underlying physical networks. It kind of gives us an easy to use name so that when we say deploy to my network, we know that underlying topology. Next thing we have is what we call a MAC address pool. Now, MAC addresses are, you know, what we can use to specifically identify virtual machines. As you remember from the lesson yesterday, Hyper-V virtual machines always start with a predefined prefix. VMware virtual machines always start with a predefined prefix. And so we could go, these are already built into Virtual Machine Manager, so you don't need to think about it. But if you want to go create a different MAC address pool, use your own, you have the ability to do that as well. Now under load balancers, this gives us the ability to integrate either software-based load balancers or hardware-based load balancers. Now, out of the box, we support network load balancing. Network load balancing is a System Center Windows Server feature that provides a software-based load balancer. Though its features are somewhat limited, it has pretty limited load balancing capabilities. But if you have a third-party load balancer, you can go and add this, integrate this. And so we already have pre-built integration with F5, Citrix NetScaler, Big IP, so kind of a lot of the most commonly used ones in the industry. We can go add, start using
And
them.
certainly there's a provider model within VMM where if it's not there by default, but you work with a vendor that makes one, and they support VMM, it can be added in.
Absolutely. And one thing that we're seeing a lot of is network component virtualization as well. So in the past, where you might actually have to buy a physical device for your load balancer, we're now seeing these companies produce a software version that runs inside a VM. And the advantage of this is you can clone it, you can scale it, and there's no physical network cables that you're actually plugging into this load balancer. So what we would actually do if we wanted to go deploy NLB, it would go spin itself up inside a VM and configure those properties so that VM is basically the brain that does our load balancing mapping. If you want to go get, let's say, F5, you can have their physical device or go get their software-based one. If you get their software-based one, it still has all those features, all those logic, but you could go deploy multiple instances of this. Now, I'm not going to talk about licensing, that's a whole different story, but this gives you more flexibility if you're running with virtualized load balancers as well. The next component we have is what we call VIP templates or virtual IP address template. This is used whenever you have a load balancer because a load balancer uses what we call a virtual IP address as a single entry point, which will then go and fan out and connect to all the different nodes within that load balancing cluster. So let's say I want to go connect to App Controller. App Controller is behind NLB. I have multiple different servers because it's highly available through redundancy. That single virtual IP address is what I connect to. And what that will do is then route me to node 1, node 8, node 16, whichever backend node it is. But this virtual IP address is kind of our single entity that we can use to go and connect to. Now, the next component we have here is a logical switch. A logical switch is essentially a template for a switch, for a physical switch. And you can go apply this template on a host. So let's say you do some advanced configuration of a switch, want to go and push that onto a host, and then go copy that on 20, 50, 100 different hosts. You could essentially use this as a switch template to go deploy on top of a host. We then have port profiles. Port profiles are essentially ways that you can go and define and manage ports here. And we have a bunch of them that are kind of pre-configured, pre-built in. So you can see ports for your clusters, for SO, IOV, for your iSCSI traffic, for your live migration traffic.
The important thing to understand about these port profiles is they do nothing until you assign them to ports on hosts. So think of these as classifications, right? You don't want to, if you have 20 hosts that have 14 different brands of NICs, you don't want to have to worry about, finding hosts that have particular brands or link speeds. You could simply say, you know what, fast. And you go through and you tag every network adapter you want as fast. I think it's, what's it called in there, high performance? I can't quite read it from here. It's high performance, right? So you tag it high performance. And then any VM that you deploy to a high performance NIC or a high bandwidth adapter is going to look for one that's equally tagged. So this is just a starting point. You can delete them all and define your own. So it's just a good sort of reasonable starting point as to how you would tag different network adapters.
How about port classifications?
So port classifications kind of work the same way. When you tag, you can tag a couple of different things. You can tag network adapters and you can also tag switch ports. Port classifications are associated more with switch ports. If you open up the properties of one of those for a second, again, they're nothing but tags. They don't govern or control anything. They're just ways of identifying different objects in the infrastructure. And then as you deploy VMs and services, it essentially does a form of tag matching to make sure things land where they're supposed to. Now, the one thing that the port profiles do that the classifications don't, the profiles actually can govern elements of the VMs themselves. So the port profiles represent, kind of configurations of virtual machine network adapters. So they do a little bit more than just the port classifications. If you open up the properties of one of the port profiles in there, so that you can see you can actually govern things like bandwidth control, which is what you would find on a Hyper-V switch or Hyper-V network interface card. So when you assign one of these port profiles to say a VM, it can control elements of the VM, and then it'll look for the associated classification on the switch when deploying the VM to make sure the VM lands where it's allowed to land.
Great point. Now I'm going to show everybody a little trick here as well. This won't be on the exam, just a nice little trick. If you want to go and view the properties of something you've already created, you're actually going to notice that the View Script button is not available. And that's because you haven't made a change to it. So it's not actually viewing the underlying pieces. If you want to go and actually view that underlying script, just make a change like add a space, delete it. You can go back to View Script, and then you can actually go back and see the full script again. So even though this has been pre-created, if I wanted to go and clone this particular profile, use scripts disabled, just go make a change and it will re-enable it so you can go and view that.
Now, not for nothing, but if I were studying for an exam on this, I'd want to know the difference between classifications of profiles and when I'd use each.
Do you mind going into that?
I thought we just did all.
Oh, okay. I thought you wanted to add on
No.
add something.
That's
more.
what we just did.
Great point. So final thing we're going to look at here is network services. Network service is essentially one of these third-party providers that we want to go and connect to. So this can be adding a new gateway, switch extension, top-of-rack switch, load balancer. So basically any of these additional modules that can plug in to VMM, we could go use by adding this network service. So let's actually go and now start to go build up our fabric. We are going to go and create a few logical networks. Now, what I'm going to show you under the covers is what our physical network infrastructure is. And throughout the day, I'm going to go and show you kind of what is happening within Hyper-V after we make changes within Virtual Machine Manager, so that you can logically understand what is happening under the covers. That will help make learning about this a little easier. So in this case, we're going to go and create some of our networks, and let's just take a quick look at the settings for these virtual machines. We can currently see that we have two network adapters. One is CorpNet 01, one is our storage network. And so basically all of this infrastructure, all these system center components have a single kind of a corporate network and then a separate storage network that they're using.
Now, the reason that they're using a storage network is because for the purpose of storage topology, they're using iSCSI. And so you've got a separate, TCP/IP segment representing iSCSI traffic so that you can have some shared storage elements in there.
That's right, yep. So here we go, and we're going to say we want to go create a new logical network. So we'll call this our Contoso network for Corp. And we have a few different ways that we want to go and implement this. Go create it with VLANs, private VLANs, or just a standard network. And we want to go and enable this checkbox here, which says allow new virtual machines to be created on this network to go use network virtualization. Here's where we'll actually go and add the underlying network sites. Now again, remember this logical network is essentially a template or a blueprint for what our underlying physical network looks like. So we could say which servers are going to be able to use this new network, and what are the associated or the underlying IP addresses or VLANs with this. So in this Corp network, everything is built on my 10 subnet. So I define that under the covers, it's going to run on my 10 subnet.
Now you're using CIDR notation for the subnet, correct? So
Yes.
instead of typing a subnet mask, you're typing the number of bits that are
That's
involved
correct.
in the subnet. So that 24 would be your traditional Class C 255, 255, 255, 0 subnet mask.
Yep.
So helps to know your subnetting, old school subnetting. If you don't know it, you're not an IT guy.
Good thing is, this is pretty much the only place you need to think about it. You go at it the first time, from now on you say deploy to this network, we go and find you an IP address with
Yeah, I'm sorry, if you don't know how to subnet something by hand, I'm never buying you a beer.
So we'll click finish. We now have a job that runs. Everything looks good. We can close our job window. And now we see our first net. It looks like it's fully compliant. So now let's go create our second logical network for storage. Going through the same wizard, Contoso storage. Now in this case, this is a storage network, so we don't want to use this network for network virtualization. And the reason why we're trying to isolate our storage network from our main corporate network is just to make sure that storage traffic stays as storage traffic. It doesn't go and interfere with our general networking. We then go and add our site, select all host groups, and in this case we're going to enter our 20 subnet. Click finish. Our second logical network is created. So we basically now have these two networks that we've defined, and now we don't need to think about those underlying IP addresses again.
So so how do those networks get associated then with hosts? Because I know for a lot of people the conceptual stuff's fine, but at the end of the day, that represents something. I can go touch a cable. So how does that get associated with that cable I can go touch?
Great question. Let's actually go do that now.
Okay, absolutely.
Now we're going to just go do this on the single server, but we're going to have to go do this again a little later when we go create a cluster. But essentially what we've done now is we have these two logical networks. We have our host that we've added. What we are now able to do is actually go and connect this host to these new logical networks. So I'm here looking at the properties of this particular host. I see Ethernet adapter 1, which is my storage network. Look at that. We could say this host is now going to be connected, or this network adapter is going to be connected to this logical network.
So now when I define a new VM and I say this VM is on Contoso Corp, it's going to go look for hosts that have an adapter that has this association.
Absolutely.
What if I've got 650 billion hosts? Is there a way that VMM can do this kind of automatically for me at all?
With a script?
With a script, but there's also, if you get down to the settings, there's an auto-detect option in there. So as you add hosts,
I did not know that one.
auto-associate. If you hit the settings down there, and then go under networking. Hit cancel on that.
So let me just add my storage
go ahead and
network
finish your stuff there.
Second storage network added. So we're going to connect storage to storage. Click OK. So now that host is connected to these two logical networks.
Absolutely. So you go under settings and then under, I'm trying to see your screen right there, under systems, new, up under general, I think. There, general network settings. You can actually tell it to auto-create logical networks and associate hosts.
Very nice.
So as you add them, it'll actually create logical network objects representing the subnets it finds and give them some generic names you can go rename and auto-associate the adapters. So.
Very cool. I'm learning stuff as well.
That's
awesome. Right. So now we've gone and defined these logical networks here. We want to go and create what we call an IP address pool. Now, IP address pool is essentially a collection of IP addresses that will go and run on that particular network. And what this means is each time we go and provision a new virtual machine on that network, it will take a free IP address that's within that pool. So we're going to say this is a corp IP pool, part of this logical network. We'll use this existing network site. So this was the underlying definition I made, saying it's going to be within this range of IP addresses. And then I get to actually specify this range. Now our .1 is that's reserved for some of our servers and our DNS infrastructure. So we're going to start from 100 and let's just go to 125, and this will provide us with 26 free IP addresses that any new VM we deploy will go take one.
So this is like DHCP but not DHCP.
Exactly, yeah.
So it's, when you go to define a new VM, you can say give this VM a static IP address, and it will actually assign it a static IP address from this pool of static IP addresses. And it's symbol. It's not DHCP, but conceptually it's kind of like that. VMM reserves a pool of static IPs and then assigns static IPs based on that pool so that you can map things to it and things remain consistent. And then as that VM is retired, the static IP goes back in the pool again.
And can be reused, absolutely. You get to also reserve IP addresses for load balancers or other infrastructure servers. So you don't want to give it the IP address of like your DNS server, for example. We can specify default gateway here. So in this case, for our default gateway, we're going to go and do this for our corp network. We could go and add DNS server addresses. So this means that any VM, these are pre-configuring the network properties for any VM that's going to be deployed on this.
A lot like making a DHCP scope, really.
Kinda. Add our DNS suffix.
It isn't DHCP.
We can add a Win server if we wanted to, confirm the settings. Take a look at our script here. So it goes and gets new logical networks, creates them, deploys them, finally sets our new IP address pool. So the subnet, the IP address start, IP address end, information about our default gateways. Click Finish. Job is created successfully. And now we can see that we have our IP address pool. I'm going to quickly do that again for storage so that when a VM needs an IP address on the storage network, we can get one.
So while you're kind of creating that, one of the questions that comes in is, why do we need a logical network? And the answer to that is when you need a logical network because when you start to define and deploy VMs, you don't pick the host. You don't pick the cluster necessarily. VMM incorporates intelligent placement, right? Intelligent placement looks at everything in the infrastructure, looks at what the VM or service requires, and is going to give you a recommendation on which host this will best run on. Which host, or for example, which cluster. Now, one of the things it needs to know is where those hosts and clusters are plugged in. Because if you deploy a service that needs to be able to talk to your internal SQL server, well, that's got to be on CorpNet. So it needs to know which servers are plugged into CorpNet and which are not. And the logical network is the link that provides that association. So you don't have to worry about, deploy to this host on the 3rd NIC or the 4th NIC, because that's where it's plugged in. The NICs are associated with this logical network. The VM requires the logical network. It's the thing that binds them together that allows that intelligent placement algorithm to work out where it can possibly work and where it can't.
Yeah, really the key point here when you're managing with VMM is you don't need to think about what server it runs on anymore. We want to do that logic for you. You just say, I need this VM that should run within these parameters. We will pick the best host for you. So don't really think about this VM has to live on this host anymore. Want it to be fluid, dynamic in this private cloud environment. So we've gone ahead and we've now created our logical networks. And you saw we assigned the logical network to our first server already. Yep. Next thing we're going to do here is we are going to go down and we'll take a quick look at creating a logical switch. Now again, our logical switch is essentially the template of a switch that we could go and apply to a different host here. So we're going to say this is vSwitch, Contoso vSwitch. We have the option of enabling SRIOV, single root IO virtualization. We also have some built-in extensions that we can go and add as part of this. So if we want to go and add our Microsoft Windows filtering platform or the NDIS capture extension, those come built in. If we had third-party extensions as well, so if you have like some type of packet sniffer, forwarding, other type of network component, you can go and add it as an extension. And essentially this means that the virtual switch we create on the host will go be connected to that other networking component. We could go create uplinks.
Now, I was just kind of holding this page for just one second here. When you create a switch, now, first of all, the whole idea of the virtual switch is, if you watched me yesterday, I went through all my Hyper-V servers and I created switches and I picked network adapters. So I had to go through, and if you're watching real close, on one of them I had to do an IP config to see which actual physical adapter had the IP address I was looking for. So when I made the switch, I associated it with the right adapter. When you create a logical switch, you're using these characteristics, these port profiles, port classifications, so that you don't ever have to worry about having to pick the adapter. The underlying hosts, just like with the VMs, when you go create the logical switch, the underlying host, because we've associated certain network cards with certain logical networks and certain classifications, it's going to associate with the right physical adapter so the VMs can actually communicate. What you're picking here with the uplink mode is whether you need one network card or two. So if you choose that this is teamed, you can't create the switch unless there's two network cards that meet the requirements. And it'll fail otherwise. If you choose not teamed, you only need one.
Great point.
Right? So pretty important to make the right choice here.
Great point. Now, as we kind of go through here, one other consideration or one other ask that we get a lot is, why do we build templates for everything? Like, if you're going to deploy 50 hosts, what is the advantage of having some type of template, some standardization?
Well, the idea is you don't make mistakes, right? I'm not perfect, you're not perfect, everybody makes mistakes. The idea of having a template is that you have a point to start where you don't have to recreate everything from scratch all over again. And what they provide in VMM are merely suggestions. There's like, okay, we've talked to 50 bazillion customers and they've all done these things kind of the same way, so this is the stuff they all kind of have. Yep. Big, small, medium, large, doesn't matter. This is all the kind of stuff they all sort of have. So it gives you a really good starting point.
We all make mistakes, right? This helps eliminate that human error by build it once correctly, use standardization. Now here's an option where we can go and add port classifications. And so essentially what this means is this will only get added to a host if this host has support for, let's say, live migration workload.
Right. And so this live migration workload is something you would tag a physical adapter on a host as.
That's right.
So when this switch goes out to be created, it's going to look for an adapter with that tag. And if it can't find one, it's going to throw an error and you say, hey, I couldn't create it because the tags don't match. At which point you can then reevaluate whether you want to change the tagging or you need to tag an adapter, or maybe you thought it had an adapter but it didn't.
Absolutely. So we are even building these best practices into our templates. So we'll throw errors if, we have a problem with this template. So let me go back. I've got it did not create the virtual port, so it just did not allow me to create that error as you were mentioning. So we now created our virtual switches, our ports, and then the final thing we're going to do is go and create a virtual network. Now, this is where we are actually going to be moving into our VMs and services workspace. Our virtual network is not considered part of the fabric. It's considered part of our virtual machine and service management components. So doing a quick look of the VMs and services workspace. First of all, we have what we call tenants, a concept of a tenant. And you can kind of think of these as particular user roles. So we'll call this our end user role. Profile, they're going to be an application administrator. Now, we'll go through these different user roles a little later, spend a little time on that.
So again, just like sort of maybe another way of thinking about this as well is if you look at a tenant, if I have multiple people that need to use VMM but only need to use a subset of the resources that VMM manages, the tenant is the object you can use to essentially assign permissions to subsets of resources.
That's right. Different actions, different resources, different...
So for those of you that do Active Directory, like an Active Directory group is an object that allows you to assign someone to a subset of resources. A tenant, conceptually, you can kind of think of it that way as well.
A cloud is going to be something we spend more time later as well, but this is a logical collection of resources, a collection of pooled resources. But here's where we're interested, our VM networks. And so these are going to be networks that our VMs can use to communicate with each other or with outside world. So let's go create our Contoso VMnet. And what we're going to do here is assign it to a logical network. So where is this virtual network going to live on? It's going to go live on our CorpNet, not live on our storage network.
Now, one thing that's just sort of very important for as he's doing this level of isolation, we talked about network virtualization yesterday. And so we talked about the concept that, you create a bubble of connectivity within your physical fabric, right? And so what you're doing here is creating this bubble of connectivity that's going to have its own IP ranges, its own isolation, and it's going to be routed using GRE across all the hosts. But it still has to be connected to some sort of physical cable somewhere to actually get the data back and forth. And so when you're associating with the other logical network, you're associating that bubble of connectivity with some physical cabling infrastructure. So there's a physical layer, and then there's this logical bubble of connectivity that can span multiple hosts, but still needs cables to route around, and that's how you indicate the cable system it's going to live on.
Great point, great point. Now, next thing that we are looking at, so after our isolation, we're going to say we want to use network virtualization. Go add a subnet. Click Next. Connectivity. It's saying that, hey, you've done network isolation, but you're missing a gateway. That might cause some problems so they can't connect. Confirm the settings. And we've gone and created our subnet. Now, what you may have noticed here is that my logical network is on the 10.10 range, and also the subnet's on the 10.10 range. So we're actually able to create subnets on top of logical networks with that kind of isolated set of network addresses.
That's where network virtualization comes in. It's the 10.10 subnet living within the 10.10 subnet.
Right. And we can have a 20.20 living within our 20.20 as well.
We can have 4 10.10 subnets living on the same 10.10 subnet because they're logically isolated with GRE.
All right. So this is our basic introduction to network virtualization and virtual machine networks. We're now going to switch back to our presentation and take a look at some of our storage capabilities.
So next lesson in this particular module deals with managing storage infrastructure. When we think of Virtual Machine Manager, VMs obviously come to mind. Hopefully at this stage, networking comes to mind. But in addition to that, it has rich storage management capabilities. And it can manage a lot of different storage devices. You can use it to manage scale-out file servers and scale-out file server clusters. So if you were watching yesterday and you saw me configure a scale-out file server using cluster tools, I had to manually assign permissions. If Virtual Machine Manager does that, it does all the work for you. You simply point and click and drag. It can also manage iSCSI SANs. It can manage Fiber Channel, because Hyper-V has support for Fiber Channel now. So it can actually take care of activities on SANs that you would normally go into the SAN console to do, like creating LUNs, zoning, mapping LUNs to individual hosts, and doing all the work so that you plug in a raw SAN, it'll do all the work on the SAN, connect it to a host, and present a disk. And it'll do that over industry standard storage protocols like SMIS, for example. So we've taken a look at some of those elements in this module.
Thanks. So here's some of the best practices or planning considerations you're going to want to think about. First of all, use good storage, right? Kind of intuitive. Make sure that it's redundant. Make sure it's highly available. So make sure that you're using RAID. As far as access to the storage, use MPIO, multipath I/O. If your storage is network-based, meaning that you connect over Ethernet, such as iSCSI or Fiber Channel over Ethernet, make sure you use a NIC teaming on those adapters to have that redundant access to your storage. Because that's the kind of output port as opposed to using an HBA. So block storage. With block storage, we're going to look at Fiber Channel, virtual Fiber Channel, iSCSI adapters. With file-based storage, we can support SMB 3.0. So this is the new Windows file server, file shares, which support Hyper-V. And with this release, the 2012 R2, we can now even create file server clusters, which are going to go and use a scale-out file server and store the disk for our Hyper-V virtual machine on that back-end file server. Additionally, we support NFS within the context of using it for VMware. So VMware supports share-based access to its VHDX files over NFS, whereas we use SMB. And so we support the NFS protocol to ensure that we can go deploy VMs to ESX hosts, which are using NFS storage. So within Virtual Machine Manager, two different methods of creating SANs. We can use snapshot-based methods where we're essentially creating a snapshot within the LUN, or we could go and clone existing LUNs. Now, if you're going to use either of these technologies, still needs to be supported by the SAN vendor. And so let's go over to our demo and actually see all of this in action. So we're going to go back to our Fabric workspace since we're managing our storage. We'll minimize networking, and we'll go and expand our storage node. Now, first thing we're going to look at here is what we call a classification and a pool. So what we're actually doing here is we're going to go and create some different storage classifications. And again, these are just containers. They don't really do anything, but it helps us really logically group these resources. So we're going to create a gold tier. And then we're going to go create a bronze tier. And essentially, as we go and add different types of storage resources, we'll assign it to one tier or to the other tier. Again, this just helps with our logical grouping. Now, next thing we're going to look at here, as we look at our different storage types, is we are going to go and add some different providers. So what is a provider? A provider is essentially something which offers storage. Could be a SAN, it could be a file server if you're using SMB, it could be an iSCSI target if you're using iSCSI. Now for this particular lab, we've set up an iSCSI target and we've set up a file share. So we're going to go and add both of these providers. So we launch our Add Storage Devices wizard, and this gives us the option of adding a Windows-based file server, a SAN or NAS device that uses SMIS, SAN device using SMP, or Fiber Channel. Now, first of all, let's go ahead and add our iSCSI target.
Before you kind of do that, just a little point on that. you have to make sure that the hardware you have supports this stuff, because where there's a lot of consistency in switch management protocols, there's a lot of consistency in baseboard management. The whole idea of SMIS, and these are newer standards and newer technologies. There is not as much consistency across different vendors. So you've really got to kind of make sure that, hey, you're planning on investing in XYZ SAN from some company. Can you manage it with Virtual Machine Manager over SMIS? Now, the sales guy will probably say, of course you can, because he wants to make a sale. Test it. That's my point. Just make sure you don't assume this stuff, get it in and test it.
Great point. What I'm going to show you now is we're going to go and add this iSCSI target. Before we do that, I kind of want to show you what we're looking at behind the scenes so you understand this logical connection. Now, in this particular lab, I have my iSCSI target running on my domain controller. Not a best practice. Definitely don't want to do this one in production. I also have my file server running on this. I see Corey cringing in the horror of doing my enterprise storage on my DC here. It's functional in the lab. We got to be highly scalable here. But what you see here is all of these iSCSI virtual disks. And so these are what I want to go and detect and make sure that I can go and manage from VMM. So I'll go up to VMM. We'll select our SAN, managed by our SMIS provider. And here's the two different protocols that we support, SimXML and WMI. I'll be honest, I'm not really that familiar with SimXML. Are you familiar with that protocol?
With SMIS, SimXML, that's the one. Yes and no. I don't know that I can do a horribly good explanation of it, but essentially they're just two protocols. Right? The WMI protocol is based on the Windows Management Instrumentation framework. The SimXML is more generic.
Okay.
Requires a different. It uses a different port. It's not based on the underlying WebM technologies. It's a matter of when you get something and you want to go manage it, you've just got to choose the protocol that's going to be supported. For the Windows iSCSI server, which is what you're using, you want to use the SMIS WMI because that's how it exposes all its functionality.
Great. So we're going to use it, as Corey mentioned, this is a Windows file server using WMI. We select our account to run it as. We'll click Next. And it's going to go contact DC01, our iSCSI target, and find all storage that can be managed by this SMIS WMI provider. And what we'll get back is that different list of iSCSI targets. So here is it's found the correct server, confirm. And look at this. Here is our list of all of our different iSCSI targets. So let's go ahead and select our 4 large disks here at the end. So FGH and I. And here is where we can go and add them to a classification. Now in this case, this is my iSCSI storage, which isn't particularly fast, so I'm going to go and add all of these to my bronze classification. Take a look at the script. Goes and configures everything for me. Click Finish. Close the jobs, and now we can see under Providers, I have my provider type. And then as I look at my different classifications and pools, once this refreshes, we'll then see all of our iSCSI targets appear under here.
So have you talked about classifications for storage at all, or is that coming down the road?
We talked about it briefly in their templates. Do you want to add to that?
Yeah, much like we did, port classifications for switches, storage classifications work in much the same way. When you deploy a VM, you never pick the specific SAN you want to put it on, or the specific God Almighty, I'm having a hard time today, location where it's going to go. What you do is instead choose the classifications. Now, I have a lot of people that ask, well, I want to be able to target very specific things when I do this, and you can be as granular about classifications as you want. You can go one-to-one with your classifications. You can have every single SAN can be classified as what it is, and let you choose what you want, or you can say, you know what, I'm going to be a little more generic, and I don't care which iSCSI array it goes on, as long as it goes on an iSCSI array, so I have a class for that. Or I just want it on SSD, and I have a class for that. So you can be as granular or as generic as you want with these things. And that's the important bit to remember, that you're not, because you're using gold and bronze, that doesn't mean you're going to use gold and bronze. You can use whatever you want.
Absolutely.
And I have seen people that have done literally, they have a class called, Dell Ecologic, 51.4, Rack 3, Row 2. You can do that. That's fine.
So a lot of flexibility. What we're really trying to show you here are some recommendations for best practices. as well as show you the breadth of features, because, hey, it could be on the exam, right? Now, as we go back to the demo here, you can see that now, as I take a look at my bronze, here we go. Our iSCSI targets are now available. We can see the underlying logical disks, logical units. So this is essentially, giving us access to go and now manage iSCSI targets through VMM. But we're going to go and create add our second provider, which is going to be our SMB file server. So under here, I select a Windows-based file server. We go specify the actual path of this file server. So this is going to be on our domain controller again, not a best practice.
You just love putting stuff on domain controllers, don't you?
I do. Nothing happens on a DC. They're easy to manage. Just let it be fine.
You probably got 40 snapshots on it, don't you?
Yep, I certainly do. Actually, let's see, only like 10.
Simon Perryman, the antidote to data center availability.
Yeah, you can see I got about a dozen snapshots running on my DC now. Don't follow this best practice. So we'll go back to VMM here. Confirm that this is the file server I want to use. And then it will go and list all of the shares that are hosted on it. So in this case, I'm going to go and select this, this cluster share. So I'm going to go deploy some VMs on the CSV disk. We'll make this gold because it's SMB. Should be kind of fast. Click Next. Oh, actually, I didn't classify. Yeah, I did. Okay. Add it under the gold. Click Next. Click Finish. We've set our file server. And now if I go take a look at the provider, we see the same server providing both our iSCSI as well as our Windows file server. I go back to my classifications. Once this refreshes, we'll then see the file server available under gold. So now that we've actually gone and created this storage, we can actually start to provision it. And so what I mean now is we have access to these different providers. We can now start carving out LUNs, carving out storage using these providers. So let's go ahead, excuse me, take a look at our array. This is our iSCSI array. And we get some information at the bottom here saying what disks are part of this array. What's the total capacity? What's the total usage? So some nice information to get us started. So we're going to go back to our storage. And we're now going to go and provision a LUN. So we could do this from our ribbon up at the top. Say create a new LUN. It gives us the option of our different iSCSI targets. So let's go ahead and create this on F. We can see that it's 70% pre-allocated already. And so we'll call this LUN 1. We'll give this, let's say, 20 gigs of RAM. Click OK. Oh, it's that simple. We've gone and provisioned a LUN. Now, the key thing here is that we're really abstracting storage management. That LUN could have been provisioned on Dell, EMC, Fujitsu, HP. It doesn't matter. It's provisioned the exact same way. And this is what's going to simplify our storage management. That consistency. Essentially, Virtual Machine Manager is a layer that sits on top of your storage. You tell VMM to do something, under the covers it will go translate those APIs for Dell, for EMC, for Equalogic, for whoever. Those are built in. And so this is what's going to help simplify management, save costs. And another benefit, it can help avoid vendor lock-in. You know, if you're unfamiliar with these other storage solutions, but you have financial issues, hey, you can go look at other vendors because you get to manage it consistently. You're not learning a brand new vendor management interface for storage.
Yeah, and the good thing is the guys that manage your virtualization infrastructure, they don't got to worry about the hardware now. They can deploy things and let the hardware guys worry about the hardware. Because as you get into these more complex SAN implementations, there's specific training you go take. There's a lot you've got to know to do these things well. These are complex pieces of equipment. So certainly anything you can do to abstract that from the guys that just need to do a job, deploy VMs and storage and whatnot, is absolutely beneficial.
Great point. So we've gone ahead and we just created 3 LUNs that they're going to get provisioned so that we can start to access them shortly. So this gives us all of our LUNs. Now, next thing we're going to do here is go and create some file shares. So we've provisioned iSCSI storage from our iSCSI array. Now let's go take a look at our file server and go and create some file shares. So it's going to give us the option of which file server do you want to use. And so we're going to call this VM Share 1. Put this under gold. It's going to use SMB. Then we could even go create a new local path. So we're going to go create this under C shares VM Share 1. Take a look at the script. Get our storage server information. Add it to the classification. Create this new file share. Click Create. Our first VM file share is being created. Let's do that again for our second one. Add it under gold. C shares VM share 2. Click Create. Now as I go take a look at our classifications under gold, once it refreshes, we'll go see these file shares. So they'll be available very shortly. Now, final thing we're going to do here is we're going to go and take a look at our host reserves. So what we're trying to do here is reserve some fixed properties for all of the hosts within our host group. And so this is essentially saying that we don't want a particular we don't want a particular host, the physical server, to use more than 90% of its CPU. So essentially we're saying we want to reserve 10% of the CPU for that host. And again, this is for the parent partition. This is what actually runs the host operating system, manages the hypervisor, and the interconnection to any VMs. Now in this particular case, I'm running VMs. They have a bit of memory, 16 gigs, but I'm just going to kind of bump down the host reserve a little smaller. This is going to allow us to deploy more VMs on top of it. And we're going to say that we want to make sure we reserve at least 10% of our disk space.
Is there a recommendation for host reserve from memory?
I've heard 10 to 20% is kind of a standard. Do you have a recommendation what you use?
Well, my recommendation is 10%. That's typically what I see and what I try to use. But it depends on what you're doing on the host. For example, if you've got ops manager agents and you've got a config manager agent and you've got a DPM agent, they all consume memory. And that 10% might not be enough if the host only has 64 gigs of RAM. That's only 6 gigs. That might not be enough to do all that. You just kind of got to monitor it. But if your hosts are a terabyte, 10% is 100 gigs. That's probably more than sufficient to run the ops manager agent.
Yep.
One would hope.
Hope so.
So at that point, 1% might be adequate. So, and you've also got to factor in how many VMs you're running on the host. The more VMs you run, every VM's got a little bit of management overhead. So, there is no right or wrong answer, but, my rule of thumb is I start with 10% and I kind of work from there.
Okay, good point, good point. Now, as we continue to look at some of these host properties, next thing we're going to take a look at is networks. And look at this, our IP address pools, they've been assigned to these different networks. Our logical networks assigned to the host group. Our logical networks have been assigned to the host group. And we're going to be continuing to use our default MAC address pools. Now, next thing we want to do, though, is we've just gone and created these LUNs. Let's make sure that these LUNs are going to be available for these hosts as well. So as we kind of take a step back and think about these different pieces, we've gone and created a host group. We've added some servers to that host group. We've gone and created added some storage management servers. We've gone and created storage. Now we're basically going to attach the storage we've created to this host group we've created so that anything that's part of this host group can now go and use these new LUNs. So here I say allocate a LUN. And look at this. It gives me the option of these 3 LUNs that I've just created. We'll go add them to these host groups. And now any server that's part of that host group has access to this shared iSCSI storage. Click OK. And now we've gone and added this to our LUNs. So this is our quick overview of storage management.
And so the next piece that we're going to take a look at here before we move on to clustering is infrastructure updates. And we've actually had a couple of questions that have been coming in over the course of while you were doing that on the chat about how do I patch and how do I do this, and that's what we're going to cover in here. Before we do, there's a couple of quick things from the Q&A chat I thought we'd just quickly bring
Sure.
up. And two of them are people asking how stuff relates back to what VMware does. So, and I thought I'd toss these out, and I don't know if you know the answer or not,
Sure.
but pools and data stores. Are they equivalent or close to it?
They're similar. You know, one of the concepts that we have within Windows Server 2012 and onwards is this concept of storage spaces. And a storage space is essentially a collection of underlying storage. It could be a bunch of individual JBOD disks. It could be iSCSI targets. It's basically a logical container for storage. And we call this storage space. It's conceptually similar to what we have with a storage pool, though.
Okay. How about a logical switch and a VMware distributed switch?
Good question. So what's the difference between our logical switch and the VMware distributed switch? This is it's the functional equivalent. So to clarify here, the VMware distributed switch, the nice thing about this is you could go create it, and as you go add new servers, it's going to automatically scale. And that distributed switch essentially goes and spans your different ESX hosts. What we're doing with the logical switch is it's basically the same concept. It gives you that template that you're going to apply. Kind of the difference is we have to actually go and then apply that template across the different hosts. So conceptually the same. The way you would actually go and deploy it, go and implement it varies slightly.
So same result, different procedure.
Yep.
Okay. And then someone had asked a question about, and I realize we're doing a little bit of switching, but I wanted to, before we get too far ahead of this, logical switches and teaming, and kind of what goes on there. And so what happens there is if you create a logical switch, and you just define that logical switch requires team network adapters, it's going to go into the Windows Server 2012 host running Hyper-V and create the team there with the teaming that's integrated in the operating system. So before it puts the switch, or as part of putting the switch on the host, it'll identify the network adapters based on logical network association, create the team. Once the team is created, create the switch and bind the switch to the teamed interface. So I just kind of wanted to address those before we move forward into infrastructure updates.
Great point. All right, well, let's move on with our infrastructure updates now. So what are infrastructure updates? Basically, Virtual Machine Manager has the capability to do patching on its infrastructure servers. And so going back to our demo system here, what we mean by infrastructure servers is our all hosts group, so the different Hyper-V hosts that we can manage, and then the things which we list under infrastructure, with one exception. So we can patch our library servers. We can patch our Pixie servers. We can patch our update servers. We can patch our VMM server. We cannot patch vCenter servers, okay? VMware, they have a different patching technology. You need to go and patch those hosts through that. So you can't use Virtual Machine Manager, Update Management for vCenter servers, but anything else within the infrastructure, you can patch. So what we actually look at now with infrastructure is we can go and integrate with Windows Server Update services. Now, first question that's going to come out is, what about Configuration Manager? Hold up on that. We'll cover integration with Configuration Manager shortly. What we're essentially doing with Windows Server Update services is using that to go and collect baselines, to go understand what patches we want to go and apply to our infrastructure. And so as we go use this, it goes through the same procedure that cluster-aware updating uses that we discussed yesterday. Once it's turned on and you create what we call a baseline, which is a collection of patches, we go and assign the baseline to a host group or to a cluster or to a specific VM. And it goes and scans that group or that cluster and analyzes what patches are needed, what are missing. It's then going to go pick one server, and it will always do one at a time. And it goes through the same process of, if it's a cluster, it will pause the node. This basically means that nothing can move onto it. And at the same time, it's going to be drained. So all the VMs will live migrate off it. It will patch it. It will go through those same 3 checks. Does the VM get rebooted and come back online? Is the patch installation code successful? And if it's part of a cluster, does it rejoin the cluster? If that's successful, it will then move on, take it out of maintenance. So unpause it. If things are enabled to fail back, they will fail back. If not, they'll stay where they are. Take the next node and kind of repeat and go through this end-to-end cycle here. If it does hit a bad patch, both cluster-aware updating and update management, the process will stop. It will raise an alert and get admin intervention. And the reason for that is we don't want to go and apply a bad patch on every node in a cluster and take down your entire infrastructure. So as soon as we hit an error, we're going to pause and give you kind of a chance to go and figure out what the issue is. Now, as you're thinking about an update baseline, you're essentially thinking of a collection of updates assigned to a specific server. And you might have different patches that you need for different types of servers. Your file server cluster is probably going to need different patches than your Hyper-V cluster. So you can have this granularity to assign different baselines to different host groups, different sets of VMs. So what about Configuration Manager? What about Windows Update? We do have a dependency on Windows Server Update services, but Windows Server Update services itself can be integrated with Windows Update or with Configuration Manager to kind of provide this end-to-end mapping. So if you only have Windows Update and you're interacting with Windows Server Update services, WSUS will pull down the patches and allow you to go and manage that based on how you define the patches in WSUS. If you want to use Configuration Manager instead of Windows Update, you can. Configuration Manager needs to be managing that particular WSUS service, and we still interact with that WSUS service as an intermediary. So one more time, there's no direct connection between VMM and Configuration Manager. It has to use a WSUS server as the intermediary, which is managed by Config Manager. So what you would do is, Config Manager, you would go define your patches, define your baselines, make sure that you have a managed WSUS server that contains those baselines. Then within VMM, you go and speak to that WSUS server, take down the patches, the baselines that you need.
Now, in terms of just kind of following on the patching, there's a couple of quick questions came through. Is what does VMM directly do to make sure that, as you're applying the patches, you only get the patches you want on, for example, your Hyper-V clusters? Because, at the end of the day, what you might approve for all your servers, you might want to be a little more stingy on some of your clusters. I know with our clusters, we're very picky over the patches we put on because we don't want to introduce variable. We know it works. Yep. We don't want, a patch is a change. We want to minimize change. Can you approve things in WSUS and then do a subset in VMM?
So the best way to logically organize that is you would go create these different baselines for those different groups of servers you need. So you create the one baseline for your Hyper-V clusters, one baseline for everything else, or general patches, let's say. When you actually go through the compliance, you actually can do a compliance scan before you actually go and apply those patches. And what that will do is you can pick a particular host group. So maybe you have your host group for the cluster, or pick a particular cluster or a particular server, run the compliance scan, and before you even start a patching cycle, it will tell you what you do need or what you don't need. So in the case of your scenario here, you would probably either pick that particular cluster, or if you have your clusters organized in a host group, you'd pick that host group, you do the compliance scan, figure out what you need, and only apply the patches from that particular baseline.
Absolutely. Excellent. Thank you. Good answer. All right, so we're going to move on to our final lesson of this module, which deals with Hyper-V clustering, and some really, really cool things in here. So we did an entire module on clustering for Hyper-V yesterday at the end of the day.
Yep.
So I don't think we're going to be getting too deep into how you build a cluster, for example, but more how does VMM manage a cluster? And there's two really, really cool things it does. One of them is a dynamic optimization, which allows you to balance load across cluster nodes and allow VMM to, live migrate things back and forth depending on, this one's heavy on CPU and these two are not, and it can balance the VMs around. And then something I really dig, which is power optimization that takes into consideration not only, where things are balanced, but are you using all your available compute power, or do you only need a fraction of it, and can I turn things off? And that goes back to some of the host management stuff you were using earlier with BMCs to enable that scenario to happen.
Yeah, we're going to take a quick look at that. Unfortunately, we don't have a power management demo, but we will kind of discuss how to configure it in the different
Well,
options.
if I pull a plug and kill the lights, well,
that's the demo.
Fair enough. All right.
So quickly reviewing what's been added with failover clustering in 2012 R2 and 2012, support of 64 servers, 8,000 VMs. Shame on us, we didn't update the slide on either day. That should be 8,000 VMs we're supporting here.
We've bumped it 2,000 since yesterday.
Yep. A lot of improvements overnight. And of course, within our cluster nodes, we go and require the shared storage so that we have that single consistent source of our application data. Now, dynamic optimization, this is basically a simple load balancing algorithm. based on a couple different resources that you can set. So this could be based on your memory, your CPU, your network I/O, or your disk I/O. And what dynamic optimization will do is try to constantly load balance your VMs if they pass a particular custom-defined threshold. So let's say this threshold is memory utilization is above 70% on this host. We're going to go detect this as a problem, and we're going to go live migrate to help distribute the load across those different hosts. But now that we've distributed it, we've got a second alert. We passed our optimization threshold again. We're going to go distribute it once again. And hopefully this is going to give us the ability to constantly be moving these virtual machines around using live migration to ensure that we keep our hosts healthy and they have additional reserve capacity. Let's say, for example, in case a cluster node crashes and we need to take on additional VMs. Now, power optimization is a similar concept, and power optimization actually has a dependency on dynamic optimization. You cannot use power optimization without dynamic optimization. So that could be an exam question. Why is power optimization not enabled, not possible? Because you need to turn on dynamic optimization first. Now, with power optimization, we're essentially looking for minimum thresholds. And if a host is going below a minimum amount of required resources, we could go put it to sleep so that we're not actually consuming power. And so we go and interact with this using that baseboard management controller again to basically say, hey, you're going down. This particular host isn't really needed. Let's go and live migrate our VMs off it, and we'll just turn off the host overnight. Now, we are cluster aware. We are quorum aware, so we will maintain your cluster quorum. As soon as we need that host again, because resource utilization starts to peak, maybe 8 a.m. in the morning when people are starting to come back into work, we can turn that host back on and start going and load balancing back to that host. So let's go ahead back to our demo and take a look at our cluster management. Now, first thing I'm going to show you is just a quick under the covers view of what we're actually going to be adding. So here is Failover Cluster Manager. I have a basic cluster, nothing on it, 2 nodes, and no storage. So this is just literally a 2-node cluster. Now, you will also have the option of actually creating a cluster through Hyper-V Manager if you want, if you have 2 or more hosts. Now, just to save time with the demo, I pre-created this cluster, and we're just going to go and add it under management. So we go and add resources, Hyper-V hosts or clusters. They're in our trusted domain. Specify our run as account. And then in this case, we're going to go and actually specify the computers by name. Last time you saw us generate an AD query. And in this case, I don't even need to know the names of the node. I can just go specify the name of my cluster. So we'll say cluster Hyper-V. Oh.
Now, folks, when you do this, it does say on the screen, put them on a separate line if you're doing more than one. I've seen lots of people try to do them all on the same line.
Good point there.
It's a silly thing, but it's one of those things where people just get annoyed and get frustrated. So.
Now here's our computers, or the cluster that it discovered, and shows me the nodes that are part of that cluster. We've already got our hypervisor enabled. We then figure out, where's this going to be running? We'll just put this in our primary site again. We can view the script, add SCVMM cluster, name, etc. Click Finish. And we're now going to go and add this cluster under VMM management. We see us add in the first host. Down here under the details, you can see the specific steps that are going on. And once this has been created, we are then going to go and actually refresh it to make sure that the virtual machine manager host can see it in its current state, that it's online and responsive. Now, while we wait for this to finish, any other questions that have come up here?
There were 2 ones that came in I wanted to get you addressed, which was dynamic optimization versus DRS.
Good question.
And that came up before the slide came up and said, yes, they are roughly equal.
That is correct. So comparing our technologies here. So dynamic optimization from Microsoft, DRS or distributed resource scheduling from VMware. Functionally equivalent, do pretty much the same thing. They're going to do this distribution, load balancing across your different hosts.
And then which resources does it actually monitor to make the decisions?
So I can't give you the correct answer for DRS, but for dynamic optimization, it's going to give you network I/O, storage I/O, CPU, as well as memory.
And then you define thresholds that represent too much.
That's right, yep.
And then once something exceeds too much, it will run a dynamic optimization cycle and rebalance everything.
Absolutely. That goes and creates triggers. So one other consideration or question we get asked a lot is, if you're managing a VMware environment, so you have a vCenter server, you're managing that, and you have DRS turned on, would you also use dynamic optimization or not? So let me actually take a step back. What we are doing within Virtual Machine Manager for VMware management is we are doing day-to-day operations. So some of the initial configuration you might need to do through VMware, like setting up your distributed vSwitches and ports, you actually still need to use vCenter for. But the 90%, 95% of day-to-day operations, you can just use VMM. And that also includes our dynamic optimization. We can go and monitor those ESXi hosts, look at the traffic, and do load balancing by using vMotions through those hosts. Same thing on a Citrix Xen server. We can do dynamic optimization on that. However, if you have DRS turned on, you should use either DRS or you should use dynamic optimization. Don't do both at the same time, or this could cause some conflict because these two systems don't communicate with each other. Now, another question that always comes up since we're spending a minute on VMware is dependency on vCenter server. Now, if you're managing a Citrix environment, you can manage the Xen servers directly. Do a Xen motion, and you don't actually need Xen Center there. You can have it if you want. One challenge with managing a VMware environment is it does have a dependency on a vCenter server. And the reason for this is that individual ESXi hosts, which are the VMware virtualization hosts, they don't have an open API. So this means VMM cannot tell the host, go to a vMotion. What we need to do is use vCenter as an intermediary. So VMM tells vCenter, go do a vMotion. vCenter then tells that individual host or host pair, go do that vMotion. So again, with VMM management, you do require vCenter. With Citrix management, you do not require Xen Center. All right, back to the demo there. That was a very long answer and answered a lot of additional questions, but hopefully that gives a quick overview of that management. Now what we have here is our Hyper-V cluster. It has been successfully added. We can see that we have some available memory, some issues with this one, so we'll just do a quick refresh. Make sure that that guy gets healthy. Now in the meantime, we are going to go and take a look at the properties of this cluster. So here you can go and configure reserves for the cluster. And so this is basically saying how many nodes do you want to guarantee stay online. And this is going to be tied in if you're doing things such as power optimization, making sure you don't turn off too many hosts. You can then take a look at the status of the cluster. We can see that the cluster service is running, the nodes are online, but look at that, my cluster validation has not been run. Not good. Let me go back and we'll go actually validate our cluster, just one button. Now for the sake of time, we're not actually going to go review a new validation report. We did that yesterday, but it goes and triggers that exact same validation test directly on the cluster. Go back to our properties here. Now once that validation test is run, you're actually going to see a direct hyperlink to show that validation test. So let's go and take a look at our our available storage here. Now, again, if we go back to Failover Cluster Manager, remember we don't have any storage assigned to this cluster. But yet, we've provisioned some storage and assigned it to this host group. Remember, we just created those iSCSI LUNs. Let's go and make them part of our cluster. LUN 1, LUN 2, and LUN 3. So now our cluster can actually go and deploy VMs to these different LUNs.
So when you do this, this is going to trigger legitimate actions on those hosts, in that it's going to go touch those hosts in the operating system and map the iSCSI storage for you.
Correct. This does turns on the iSCSI initiator if it's not on already, connects to the iSCSI target, allows the target to accept that initiation request so that they can see each other and start communicating with each other. But you also get some nice some file provisioning features as well here. So remember, this is a brand new LUN using raw storage. Let's go ahead, quick format it. And so we're basically going to say run storage, NTFS, or do not format. give it some labels. These are going to be our cluster shared volume disks, and force the format. Added. That quick. Now we're also going to go and add some file share storage. Actually, first, let's go create some cluster shared volumes. Now, remember, cluster shared volumes are this distributed access file system for Hyper-V, equivalent to VMFS from VMware. Now, remember, we just gone and created these LUNs, but we're going to now take these disks that are available storage and turn them into CSV disks. So we'll refresh the view. This might take a minute to load because we're also running the cluster validation test in the background, so that'll be a little slow, but that'll show up in a minute here. So let's go and add our CSV disks. Go and take this LUN, CSV3, quick format. All right, so we've now gone and taken another LUN, made it into a CSV disk. Now for our existing disk that we've added, so this is available storage, we can see they're managed, and in a minute once they get added to the cluster, we'll convert them to CSV as well. Now final thing here we're going to add is file share storage, and this is going to go and connect to that file server we have. We just created those two file shares, share 1, share 2.
And this will actually add the permissions in the file shares as well.
It will. So we'll go at our cluster share that was pre-created for us, goal classification, SMB share, share 1, and share 2. So now our cluster can use these newly created shares. So as we kind of, go through this, to quickly summarize what we've done with our cluster, we've gone and added it under management, and then we've assigned storage to it, so that as we start to deploy virtual machines or other resources on that cluster, we can actually start to use those different cluster disks. Click OK. We'll save that. Now, final thing we're going to show in this module is the dynamic optimization and the power optimization. Now, these do not require clusters, though there's definitely a lot of benefits if you're using clustering with it, because we maintain quorum, we maintain the state of these different hosts. So as I go take a look at dynamic optimization settings here, first thing that we see is this concept called aggressiveness. Now, the terminology is a little pointed, I think, but basically what this means is frequency to load balance. Now, when you think about what happens when you do a live migration, the system is changing. We're copying memory, we're passing that memory through the network, and so that causes CPU cycles, network traffic, and host to change memory state. So the more live migrations you do, the more network traffic you're going to get. However, the more balanced your individual hosts will be. So if you want all of your hosts running at, let's say, 50% capacity, you'd be highly aggressive. If you're fine with some hosts running at, say, 30% capacity, some hosts running at 70% capacity, still somewhat balanced, you can set it to low, there'll be less migrations. Now with this timing option, you get to do the frequency that you're going to check for compliance and do load balancing. And under here are the 4 different thresholds that you can set. So go set different thresholds for CPU. So set a minimum threshold for how much, what's the maximum memory running on a host before we go and trigger a dynamic optimization. Configure disk I/O. Configure network I/O. Now, as soon as we go and turn on dynamic optimization, you'll notice that this button down here for power optimization gets enabled. Again, power optimization is dependent on using dynamic optimization. As we take a look at our power optimization settings, we get to set these power thresholds. What's the minimum? So if my computer is using, let's say, less than 1 megabyte of memory, we can go turn it off. But it's important to be able to schedule this as well. Maybe your business doesn't really do anything on weekends, so you can power optimization on the weekend is a good time for you. Maybe you're kind of a 9-to-5 business, so you can do it weekdays as well. And, you have this granularity, this flexibility to go and configure these different power schedules.
It kind of looks like an 8-bit coloring book.
Kind of. And so as we go and wrap this up, we've gone through our basic cluster management features. Ha! It told me that this warning level is too low, but I actually set for my dynamic optimization. It can't be less than a megabyte, so we have to go with 1024 here, which is exactly 1 megabyte. 1025, okay. Now, anyway, let's. Why don't we wrap up this module here?
Absolutely. So this has been obviously a pretty in-depth module. We've covered a lot of different things dealing with how we manage the fabric, storage, networking, and in addition to all those different pieces that relate in between, how we do updates, and also how we manage clustering at the end of the day. So a lot of material to cover here, giving you, we haven't even deployed a VM yet, and we spent almost an entire morning in Virtual Machine Manager. So before we wrap up, I wanted to address one kind of minor question that's come up a good 30 times.
Okay.
And that is, can we go to the widescreen shot for a second? People want to know what this is. This is a Surface, okay? You may have heard of them. This is a Surface 2. I can prove it because I can do that.
Nice. Drop it down.
And I'm running Windows 8.1. And there's been an entire litany of questions that's popped up as to, what's the tablet Corey's using? I want one. Can I buy one? Yes, you can. It's a Surface.
I think I may have seen a TV commercial about that once or twice.
This happens to be a Surface Pro 2. My Surface RT is over there on the floor charging. And I happen to like them. I actually quite like my Surface RT. Movies in the airplane, reading books, kids watch stuff on it.
Great dancing on a table, click. Doing that part?
No.
Okay.
I can't believe you just did that. That was the most ungraceful thing I've ever seen. So with that, we'll take a break for lunch. We'll see you. No, not lunch.
No, we're going to do a 10-minute break, and we'll be right back.
10-minute break. All right, welcome back to Managing Microsoft Virtualization with System Center and Hyper-V. Corey Hines and Simon Perryman. Moving into Module 9, Configuring and Managing the VMM Library. Now, before we do, two quick housekeeping items that we want to address. Number one, so a lot of you guys out there, and I know there's a lot of questions coming in, and we're doing our best to answer them. So I've seen people say, hey, hey, how come you're not answering my questions? As we're reading them, we know, a lot of times we know that that's coming up later on. So we're kind of trying to address the things, questions on clarification on what we've already covered to make sure we can get that brought up. And we try to address things, as best we can. And, if we see stuff, I write them down, and we try to address them here. And secondly, if you're asking a question that is very specific to, hey, in my network, this server had this error in it, why is that happening? We don't know. We're not product support, we're training. So, if it's very, very specific on a very specific error, we probably can't address that live in the chat or online. So just kind of bear that in mind and try to focus your questions on, what we've already covered and things you feel that you'd like more clarification on, because that we certainly can do and can address. And if your question isn't being answered, then chances are we just haven't gotten to it, or we feel like it's going to come up later on. It's going to get addressed a little bit later on.
TechNet Forums is a great place if you do have those very specific questions about your particular environment. TechNet Forums get viewed by the product group, by MVPs, and you usually get a pretty quick response on those. And another benefit is you get to share that with the community. You write down your exact question. That's going to get archived so that future people browsing for that problem in the forums will also get to see it. So specific questions, definitely want to encourage you to check out the TechNet Forums.
So moving into Module 9 for today, which is Configuring and Managing the VMM Library. So for this particular module, what we're looking at is the library as the building block for what you work with in Virtual Machine Manager. So when you go to deploy new virtual machines and new VMs, rather than new virtual machines and new VMs, both of those completely different things. when you go to do that, you don't have to answer the same questions over and over and over and over again. You can define templates that represent common configurations, common collections of settings, and deploy those. And you can do this, for operating systems, for hardware, for switches, for all sorts of different elements. So we'll take a look at the library, the objects in the library, the assorted types of profiles, and the assorted types of templates. So.
All right, let's kick it off. Now, firstly, just to clarify in terminology, profile. What is a profile? It's a template. It's that simple. We kind of treat templates in two different ways, whether we store them actually on a disk or whether we treat it as an XML definition file. And basically, profiles are XML definitions. Templates are components we can reuse. Bottom line, it's the same thing. A profile, same thing as a template here. Our first thing we're going to do, our first lesson, is take a look at the actual VMM library itself. So what is the VMM library? So it's basically a file share that stores resources that VMM might want to use. It organizes them, it categorizes them, and it includes a variety of different components like ISO files, VHDs, and we'll go take a look at some of those in a little bit. Now, it also supports data deduplication, and this is one of the best uses of Windows Server 2012, 2012 R2 file server deduplication. If you have a lot of images that are structured the same way, let's say, for example, you have 20 VHDs, they're all different versions of Windows Server. Using data deduplication can save you a ton of space on that library server by simply maintaining a single instance of that. As we look at the different library resources that are included, we have our file-based resources, which are actually the physical components stored on a disk, which can include ANSI files and drivers, hard drives, VHDs, PowerShell and SQL scripts, web deployment packages, and SQL DAC packs, or SQL data availability component files. Additionally, we have different templates and profiles for VMs, and some other types of resources we can manage. And we'll actually walk through each of these individually in a little bit. Now, the way you want to think about logically deploying your library servers are having one at each site. And the reason for this is to minimize traffic over a WAN link. So you have a single data center, you're probably fine having a single library server, because if you're deploying a 20 gigabyte VHD file, it's still staying local within your network. But if you have multiple branch offices, you're probably going to want to have a library server at each of those offices. This way, if you're deploying a 20 gig VM to your office based in London, you're just deploying it from a file server based in London. You're not copying that 20 gigabytes over the public internet. Now, this will not only speed up deployment and reduce network bandwidth time, but you can actually give better control, delegated control to each of the file servers for each of those admins at those different sites or locations. The library servers are built using Windows file servers. And so, actually, one last thing I want to mention regarding having multiple library servers. You can use built-in replication technologies for file servers as well. So if you have a bunch of files stored at your primary data center, you want to make sure those get replicated to the file server located in London or located in the south. You can actually use DFS replication to actually go and replicate those files across these different locations.
Yeah, I can use clusters for this as well, right?
Absolutely.
At the end of the day, it's just a file server.
Absolutely. So how do we use clusters? Well, we use a traditional Windows Server failover cluster with the file server enroll stored. So it can be made highly available as well. And so if you're doing lots of deployments, having high availability for the library server is nice. Production environments, we don't necessarily see it that often. We really see people use high availability on their library servers if they have a truly dynamic environment where they need to dynamically scale up. And so what I mean by that is they're the type of private cloud consumer that's constantly monitoring their VMs. And if one of those VMs starts to reach, high capacity, then it will go and create a new VM from the library, do that kind of scale out operation. Those are the customers that we really see take advantage of the high availability the most, because they're the ones that always need access to that library server. If you just deploy a couple VMs a week or a couple VMs a month, you're kind of doing it manually, probably don't need to make that library server highly available. Our second lesson here is actually taking a look at our different profiles and templates.
So when you start, getting into working in the library in particular, you'll find that there's a lot of objects that you can actually create, right?
Yep.
So just jump back for a second. The list there: hardware profiles, guest profiles, server app v profiles, app profiles, SQL Server. These all represents kind of the most common things that people deploy with VMM, and every one of those is a different object with its own characteristics and properties, and you stitch all these objects together. It's kind of like big old Lego blocks to build, to build services and VMs. So as an example, you take, for example, a high-spec server hardware profile, add the Windows Server 22 operating system profile with SQL Server on top of that, and those three things gives you the full deployment of the VM.
Absolutely, great piece. Great way to look at it. These are the building blocks to go create these larger objects. Now, hardware profiles, guest OS profiles, AppV application profiles, SQL profiles. Rather than go through these slides, let's just show you in our demo exactly what all these different pieces are. Now, back on our demo screen as we switch over here, just to wrap up the last section, our cluster has now been validated. So if I take a look at the status, it'll give me a link to the cluster validation report. I can get more information about it. If I go take a look at my available storage, I see those disks are online. My file shares are now online. And my CSV disk that I've added is now online. Now if I went back and take a look at the actual failover cluster, here you go. You can now see that this has now been mapped. It's been refreshed. We see our different disks and our CSV volume. Final thing I'm going to do is convert these two disks over to CSV. So we've taken disks from available storage and now made them CSV disks. Let's save that. There we go. Now let's move down to our library setting. And again, you're going to be using the library workspace. When you go and actually interact with these resources, you're going to deploy again and again. So before we go through this, what we're actually going to do is go and add a new share. Now I have two library servers. SCVMM will go and install a library server by default and include a few samples for you. And so the default library server is always going to get installed under SCVMM 01, whatever your local server is, and then under the MS SCVMM library. Within this, you get some application frameworks. So these are some resources that you can deploy, a server AppV package and a web package, and then a few sample VHDs as well. So two VHDs, two VHDX files. So this comes as default. You can delete this, never have to worry about it again if you want. Now here's the file server that I actually did add. Now I've gone through this already. I've gone through the add library server, specify the name and the location. And so in this case, we're just going to go and add a new share within this library server. So remember, there's two parts to this. One is adding the library server. One is adding the shares within that library server. So I'm going to go add a new share. And in this case, I'm going to go and add my share for VMware. What I've done is I've stored a couple of VMware objects in here that we're actually going to go and convert to Hyper-V objects a little later in the day. So we're going to say I want access to this VMware share. Take a look at the script, get the credential, add the new library share, click create, and now our library share has been added. So down here we can now see I have this new library share called VMware. And within this library we actually have a VMware virtual machine. So if I take a look at the components of this new VM, you see on the virtualization platform, VMware ESX Server. Now let's just go take a look under the covers what we're actually doing here. So I'm actually going to go navigate to that share itself. And here you have a offline VMware virtual machine with the associated VMDK file, VMSD, VMX, VMXF, and then the .lck. So you can see this is basically an offline virtual machine that we can now, from VMware, that we can now manage using Hyper-V. Sorry, using Virtual Machine Manager. Too many V's in this conversation here. Okay, so we've now got and added this new VM. Next thing we're going to go and take a look at now are the different resources that we can go and manage in our library. So with the existing library share that we've added, first thing we'll take a look at is application frameworks. And so these are these resources that we can go and add as part of application packages. We're going to actually go into a little more detail in a second, so hold on with clarification on that. Second thing we have added to our library share is the configuration for a service that we're going to deploy. This service is going to have a website, so we've actually gone and pre-created some web application packages. And these essentially contain the configuration information needed for our IIS server to go and run this front-end web page.
So service templates, they're a little bit more complex, right? So we're going to be covering those a little bit
We'll
later
be covering them, yep, we're covering them later this afternoon.
So service templates, as a sort of a quick sort of definition, would be multiple VMs grouped together to provide a collective service. So
like an enterprise application.
Exactly. So whereas you would use a hardware profile and an operating system profile and an application profile to build a VM, you could then have 3 or 4 VMs with different combinations of things defined as a service.
That's right. And you can control the startup order, the different tiers, scale out, scale down,
elasticity,
update domains, so a lot of flexibility within the services. Back to our library here, though, other resources that we're now able to manage are these SQL DAC packs. So this is for our data tier application package, and it basically contains pre-configured information for a SQL server that we're going to deploy. Then we have a few scripts that we can run. So we've even added scripts as part of our library. These could be SQL Server scripts, run once scripts, pre-installation, post-installation scripts, kind of whatever you want here. And a little later on today as well, we're going to go and actually add some PowerShell scripts we create and go use them out of this library. So that kind of gives you an overview of the core library resources we can manage. And now we will take a look at the VHDs. Now, what we've done with our VHDs here, these are some VHDs that we've imported. And if you take a look at the file type, they're all VHDX, all on the same library server. But what's interesting here is that these actually cover a variety of different guest operating systems. And so we essentially have this guest operating system pre-installed on this VHD. So here I have my CentOS 6.4 Linux distribution, Oracle Oracle 6.4, Red Hat Enterprise Linux, SUSE, Ubuntu. We have a SQL Server disk, so if I'm going to go deploy a SQL Server, I can get that pre-configured. My Windows 8.1 client, and then 3 different Windows Server VHDs. One for my file role, one for my Active Directory role, and one for my web role. And so these VHDs basically pre-configured, and I can go use them again and again and again. And each time I deploy it, it will go actually take a clone of that VHD. Now, one thing I've actually done here, these are actually empty VHDs, so these don't have the full operating system, and so if you actually look at the size of them, you can see they're very small. And we're just doing this for the purpose of the demo so that we can deploy them, copy them, clone them very quickly. Now, final thing we're going to cover as part of this module is this concept of profiles. Profiles we've alluded to a few times as kind of these predefined templates for configuration. Now, very first profile we're going to take a look at here is what we call a capability profile. Now, there's 3 pre-configured capability profiles which are added within VMM. So these came pre-installed. There's one for ESX, VMware, one for Xen, Citrix, and one for Hyper-V. So if we can take a look at the details of this, essentially, all this is saying is, hey, this particular type of profile must use this target platform. Basically, we're saying if your host is using Hyper-V, we need to make sure we use this profile. But we don't care about the number of processors. We don't care about the amount of memory. Anything with that's flexible. The second type of profile we want to take a look at is our physical computer profile. Now, in Virtual Machine Manager 2012, RTM and Service Pack 1, these were actually called host profiles. They've been renamed in 2012 R2 to physical computer profile, but they're essentially the same thing. So let's go take a look at what a physical computer profile is. Now, this is actually a template that we will go and apply to a physical server that could be a virtualization host, or in this case, one of my SQL hosts, and we predefine how it's going to be connected. So what parent disk is it using? What is it booting from? What type of NICs can it be connected to? Is it going to be using DHCP or static IPs? What's the domain? Password. What are we going to call these? Product key, time zone, and then some scripts that we can run. Finally, under the host settings, we could go and add paths for the actual VMs that are going to be part of this. And so in this case, we're going to actually be deploying this as like a SQL cluster. We're going to go ahead and use cluster shared volume. So we've predefined that path. So one more time, a host profile is a template for a physical server that we're going to configure. So, excuse me. So we've now kind of covered the two profiles which cover the physical components, which is your capability profile for the hypervisor, the physical computer profile. The next four profiles we're going to be covering are for virtual machines. Very first one we're going to take a look at here is the hardware profile of our virtual machine. And so this is essentially defining what the VM's virtual hardware looks like: memory, disks, network connections.
Now, in the hardware profile, as they're kind of going back to some of the things that we were looking at this morning, as you created, is there any association back with objects like storage classifications, network classifications, or does that come later as you deploy the VM?
Yeah, good question. I don't know. Do you know on this part?
I don't know.
I don't know if we could configure it this early. You know what? Let's just answer the question. Yes, we can. So I'll go take a look at my network connection, and sure enough, down here we can go and connect to one of our existing networks. So here's the virtual network we created. So depending on the order that you build this, yes, you can.
Okay.
So let's take a look at this hardware profile here. Now again, this is the hardware for our virtual machine, so this is all virtualized hardware. We're going to say this runs in Hyper-V. This is going to be our SQL VM, so we're going to give it 32 processors, and we've turned on processor compatibility mode. As a reminder, this allows you to do live migration between hosts that have slightly different processor versions still running within the same family. We get to define our memory, and we can define the dynamic memory settings here. So our minimum memory, our startup memory, our maximum memory, and the memory percentage buffer, so how much we're gradually
for those that were tuned in tomorrow, this is the exact same stuff that we did when we created a VM. So when we made the VM, we did all this.
It's, very similar.
Right,
Yep.
and by now creating a hardware profile, we're predefining what we want as different types of settings. If we want certain levels of RAM, and so as we define those, we don't, you don't have to worry about a person, who's going and deploying a VM, creating a VM with 32 gigs of RAM. You don't want that. You just define profiles, big, medium, small. And, much like Azure does, for example, they have certain sizes of VMs, and you just pick the size that you want. Works much the same way as they deploy VMs and you define the profiles. They pick the profile that they want based on what they have permission to, using the delegation and the tenant technology that you talked about earlier.
Yep. And one thing we see a lot of admins do using these predefined hardware profiles is kind of what we call breaking up the hardware into stamps. And really what that means is compact logical units that can scale. So small might be 4 gigs of RAM, medium might be 8 or 16 gigs of RAM, large might be 32 or 64 gigs of RAM. But what you see these admins do as the best practice is make sure that they're divisible. They have, a lowest common denominator. That way you can easily think, hey, if I need a large, that's equivalent to 4 smalls. So that kind of helps you with the scaling and helps you really try to best utilize the space on a particular host.
Really good question came up. When you're defining processors, is that cores or sockets, or what is that? And the answer, I'll go ahead and just answer that one. The processor count is essentially the number of squares you see in Task Manager. Right? So don't even think so much of cores, sockets, processors. You go into Task Manager and it's showing 32 cores. You can go up to 32 processors on the machine.
Thanks. So we get to also define, the standard stuff, floppy drives. I'm sure all our VMs are going to use those. COM ports, network adapters. And then under our actual networks, this is where we can go and connect it to an existing network here. So,
right, and you notice that in doing this, you're connecting it. You have no knowledge of what the underlying physical topology is. You just know that, okay, there's a network for the data center, and I don't need to worry about where it's plugged in. I'm just going to pick the network for the data center.
Absolutely.
And Hyper-V, and VMM will figure out where it can put the VM so it has that connection. So this is a required network connection. It'll find one.
Yep. And so in this case, we're going to just have some flexibility, not require this particular VM template to run on that particular network. So we'll keep that disabled. Now, you get the ability, if you have fiber channel HBAs, you can configure them here. But we also have some advanced features here under availability. So you have this checkbox to make this virtual machine highly available. And what this means is when it's looking at host placement, it's only going to recommend hosts that are part of a cluster. Because if it's not part of a cluster, that VM's not highly available. And here's the same standard VM prioritization features that you would see back in Hyper-V. We then get to enter some additional configurations such as VM priority as compared to other VMs on that host, virtual NUMA, non-uniform memory access, and memory weight, how much memory priority it gets in relation to everything on that host. We could configure dependencies, who can access this particular template, and then it will actually even go and validate errors within this profile. So that's gone and defined the virtual hardware for our VM. Let's actually take a look inside our guest operating system and take a look at the profile of our guest OS. So at a general, this is the guest operating system for SQL. What we can do within our guest OS profile is actually define which operating system it's going to use. You can see quite a lot here, all the different Windows operating systems. Under identity information, this is where you can go and predefine the series of names that will be used by these VMs. And two little tricks here that could come up as exam questions. You want to make sure that you're either using the hashtag symbol or the asterisk wildcard symbol. And these represent different things. Now, if you think that you're going to be deploying multiple VMs, you need to make sure you give them unique names. And so if you just had, a pet shop SQL, you could deploy one. When you tried to deploy the second, you'd get a conflict. If you use the hash, what it will do is increment numbers for you. So this will go from, 1 through 9. If you do 2 hashes, it will go through 1 through 99.
Can you zoom it on that one at all?
Yeah.
Just to see it, so people can just kind of see what it is. There you go.
Now, the other option you have is if you want to use a wildcard character, meaning it's a randomly assigned character, you could go use the asterisk. So again, hashtag is for incremental numbers, asterisk is for wildcard. We can then go configure our admin settings, product keys, time zones. But here's the one that's going to save you a lot of time. This is predefining the features and roles.
This is utterly fantastic.
Well, why don't you explain how you use this while I just kind of browse the interface?
Well, so if you scroll down through, this is everything that's in Server Manager, right? So all the roles that you might want installed on the machine. So rather than you having to install the operating system and then worry about scripting the installation of things like file servers, you just go in here and check the boxes you would check in Server Manager to get the features that you want. For example, you can check Hyper-V. Although if this were a VM, you wouldn't check Hyper-V. But that happened to be one that was on the screen. But for example, the file services or Active Directory services or web server, the most common things you'll typically use this for are file servers and web servers. But it's just a matter of, this is what you would have done in Server Manager. It makes it so easy. You just check the boxes for the features that you want and you're set.
Save you a lot of time, and some of these features require an additional reboot. Skip that additional work. Take a look at our Active Directory credentials. We can join this VM to the domain using our domain join. And then you have the ability to go and run scripts as well. So first time that the VM starts up, first times it runs, go execute a script. So that has gone and defined our guest OS profile. So we've gone and defined the virtual hardware and now the virtual operating system. Next two things we're going to look at is our SQL profile and our application profile, because these are things that we actually go and inject within these VMs. So injecting applications such as websites, injecting SQL configuration information like your SQL servers. So let's start with an application profile here. So as we look at the application configuration, we get to define OS compatibility. So every time I want to deploy this application, what are the requirements for the operating system it runs on? And so in this particular case, this app can go run on Windows Server 2008, 2008 R2, 2012, or 2012 R2. We could then go and add scripts. So you could go and add a custom script. And this will go and actually execute a script in the environment, like clearing DNS as a script. You could go add your SQL SQL Server data tier packages. So you can browse and add SQL DAC packs, and this will actually pull the DAC packs out of your library, make them available with the template. You could go define the SQL instance names, different types of authentications, run as accounts, and even how it's installed, the different types of modes.
Now, if you've ever attempted to do an auto install of SQL Server, it's not a trivial thing. They've got some tools that do it. You can do like a recorded installation wizard, then like a playback with a command, but the reality is it's not an easy thing to do. This makes it easy to do, right? Because SQL is such an integral part of deploying application level services.
Yep.
So making SQL easy to deploy is pretty important to this overall process.
Absolutely, and so as part of this configuration, you can even define the service account. So as this gets installed and configured, what is it running under, what's the agent running under, what's the reporting server running under. Under configuration, who are the admins that can access it? Where is the actual media located? What type of connections are we using? What run as accounts? What security modes? And then finally, or perhaps most importantly, what's the name of the SQL instance, the database, the SQL IDs, and then who's going to run the installation. So this allows you to predefine the SQL configuration steps as well. So as we kind of looked across these different pieces here, you know, we can define our clouds, we can define our physical computers, we can define the hardware for our virtual machines, the operating system for our virtual machines, and then those applications and SQL services running within the VMs. These are our building blocks for actually creating a VM, and this is the next thing that we are going to do.
So one of the questions that's come up now a couple of times in here, and I think you're about to answer it. So if you've asked this, pay attention, frankly. Profile versus template, and what's the difference between a profile object and a template? And so I believe this is what you're getting to now, correct?
It is, yep. So we'll go through this. Profiles are essentially the individual building blocks. Template is a collection of profiles. Essentially, they're the same thing. It's really just kind of looking at
economy of scale.
The economy of scale, yeah, that's a good way to put it. Conceptually, consider them the same things. Profiles make up templates. Now, what we're going to do here is go and create a VM template. And this is basically going to pull together those four virtualized components. So the applications, the guest OS, the hardware profile, and the SQL Server profile. We are not going to go and deploy it, configure a cloud because it's not part of the cloud, though we can say what type of host it should run on, and we're not going to be defining the physical computer profile because we're not actually building a physical computer.
So in terms of the, I believe not the physical computer profile, but the capability profile, one example of where that is quite often used is whether or not the physical machine has a remote FX capable graphics adapter or not. So if you're going to be deploying VMs that are going to need that graphics adapter, or for example, if you're deploying to hosts that need an HBA adapter, you can use that capability profile to limit the host based on the hardware it may or may not have. So just some examples where that's really used.
Great tip there.
And you know, and with the scenario that I just described, which is something to the extent of I need to limit where something is going to go based on a physical characteristic of it. What object should I use? Might be something that you should be able to answer.
Good tip. So with our VM templates, let's go and create a new VM template. So first question is, are we going to go and edit an existing template, or are we going to base things on a VHD stored in our library, or are we just going to go deploy this from scratch? Now in this case, what we're actually going to go and do is we are going to go, let me just double check, make sure I'm creating the right one. We've created our web tier already. We're now going to go and create our SQL tier. So we're going to use basically define all these different pieces that will fit into our SQL VM. So I'm actually going to browse and pick our SQL VHD. And so this is Windows Server 2012 running SQL. So now we defined VHD. Now we get to create our template. So this is pet shop application SQL. We can say whether it's a Generation 1 or Generation 2 VM. We'll stay with Gen 1. And now this is where we go and actually get to inject these different building blocks that we've created. For our hardware profile, we're going to go and add that hardware profile for the SQL VM we just reviewed. And if you take a look at all these parameters, it goes and copies it in. This way, I'm guaranteed that everything is configured correctly. Built the standardization directly in. You know, availability high, CPU priority high, memory weight high. We've reviewed these already. And we'll see that this is going to be deployed onto our Hyper-V host. Now, what's nice about this as well is if I don't ever want to use a profile, I don't have to. I can go create a new one from scratch. Or if I want to tweak an existing profile, I can say, let me use the SQL profile. But you know what? I'm going to go change that maximum memory down to 16. So even though you can start with an existing profile, you can still go and edit it as well. Now, next thing we go and take a look at is the guest OS. So let's go and add our guest OS profile that we've just reviewed.
So this is where these profiles become really, really convenient, right? You're not configuring anything. You're just picking what's pre-configured. And in terms of, you know, when you begin to define self-service, this is what you allow users to do, is you simply say, hey, you're allowed to deploy a VM, but you're only allowed to pick what I already defined for you. You can't get really custom with it. So you can define things that are, you know, essentially safe. One of the questions that popped up here, you know, just kind of a minute ago was, wow, it seems like a lot of work to deploy a VM, creating all these. You don't have to do all of this, right? You can just go make a VM. And if you just
We'll
go
do
make
that soon as
if you
well.
just go make a VM, you can specify everything. So you can just run a wizard and make a VM. You don't have to do all this to make a VM. But if you're deploying this, you know, as a framework to manage everything, to do self-service, then that's where the profiles and the templates become extremely valuable as those basic blocks that you can choose from rather than having to be specific about every single time.
Yeah, you know, think about it this way. Let's say you're deploying 30 VMs, one a week. They're configured similarly. And each time you go through these steps, click here, then click here, then click here. There's like 50 steps here. That's a lot of chance for misconfiguration. Even if you've done it correctly the first 20 times, hey, people get lazy. People make mistakes, right? You're no longer going to read those step-by-steps. And then that causes misconfigurations. That wastes time doing troubleshooting, support, figuring out, why doesn't this VM work anymore? It worked last week. Why is it not working this week? That's the benefit of the standardization in these templates. It's that guaranteed configuration, eliminating the human error. You know that the problem's not in the VM or the template. And so that way, if there's a problem, we can go blame our developers because they've written bad code this time. They're no longer going to be complaining about the infrastructure. So templates, a lot of advantage for troubleshooting. And ultimately, yes, it's an investment up front in your time, but it should pay dividends in the long run if you're doing this again and again.
You go blame the developers and let me know how that works out for you.
I will. I always do.
I never blame the developers. They can do things to you.
So next thing we're going to look at here is our application that's going to be running inside our VM. We're going to go deploy SQL app and got our same settings, our same scripts, and finally our SQL installation. Oops, went to double-click there. SQL installation, SQL configuration, click Next, click Create, and this will now go and create our profile. So we've gone and created this brand new template. Let's go and take a look at our VM templates, and sure enough, here is this brand new template that we've just created. If we take a look at the properties, we can go down, take a look at everything which is pre-configured. Now, if you ever want to go change these templates later, look at that. You can even go and switch them. You can go edit them after they've been created. So trying to keep this flexible.
Can you copy paste templates? I don't know. It just occurred to me. I think you can, can't you?
You can export and import.
Okay.
Them. That's how you do that.
Functionally equivalent.
Export and import.
There you go. Functionally equivalent.
Well, this wraps up our module here. We've now gone and really gone through all of our different templates. Now, last thing that we're going to just mention very briefly is services. We talked about this already, service being this collection of templates. We have a whole module designed on services later. During that module, you'll actually see us deploy these different templates to our infrastructure so that we can start using them, start configuring them. And
just to be clear, this has nothing to do with Service Manager. This is the service concept within Virtual Machine Manager. So I think we're about ready. We're about done here for this module.
Yep, we're going to take a break. It's now lunchtime for us in sunny Redmond, so we're going to be away for approximately an hour, and we'll be starting back up at the next half of the hour. We'll see you again soon.
Got my lunch right here.
Nice.
We're good. And welcome back to Microsoft Virtualization with Hyper-V and System Center. Corey Hines, Simon Perriman, back for the last stretch of our two-day jumpstart.
Getting there, yep.
So this particular module that we're going to start with this afternoon is creating and managing VMs with VMM. So what we've done all morning is lay the foundation for Virtual Machine Manager and all the assorted objects, types of objects you can create, how you connect up the infrastructure, your hosts, your clusters, file servers, storage, networking, switches, all that stuff, leading up to the point where, hey, we're going to go start creating VMs now and looking at the different methods that you can use to create VMs. Things like, just straight VM creation through using intelligent placement, but also cloning and converting. So how we take, VMs, do clones to make copies and then convert VMs from other types and formats, such as from, VMDX files, for example.
That's right, yep.
So without further ado, let's jump in.
All right, so our first lesson, pretty straightforward here. We're going to go deploy some VMs. We're going to go do a standard VM deployment. We are going to do a VM deployment using PowerShell. And then we're going to go create a VM using actually one of the templates that we've just built. So we created virtual machines in VMM. You're going to see this interface shortly. As you go through the wizard, it's going to be pretty similar to the traditional Hyper-V wizard if you haven't pre-configured anything. If you do use templates, the things that we've just built, you'll be able to select the templates as you go through this process. But ultimately, you're going to get a lot of the similar configuration options as you really kind of build that actual virtual machine itself. Where VMM takes you to the next step is managing placement of that VM. So kind of part one is create that VM. Part two is where are we going to make it run? What's the appropriate host? Does that host have the appropriate storage connections, network connections, virtual network connections? And then does it have the same type of capability profile, such as all VMM? Which cloud should it run in? So you're really going to see this as two parts. Part one, create the VM. Part two, optimize the placement. As we go through and look at placement for VM, you're going to start to see this wizard that's called our Intelligent Placement Wizard. Intelligent Placement, or IP, essentially gives you a star rating system for which host is the best host to run this on.
So, all the stuff we talked about this morning, right, through using networks, using, host reserves, the templates that assign permissions, it all accumulates into this right here. Because at the end of the day, when you go to deploy a VM, all that work you've done to lay down that foundation, setting up your virtual networks, setting up your logical networks, associating network adapter cards, associating RAM values, the hardware profiles, the intelligent placement takes all that into consideration when it provides a recommendation for the host that should contain your VM. And you can ignore it, quite frankly. It's a recommendation, but that's ultimately where this all kind of bubbles up to the surface in, everything from performance to capability.
Absolutely, and what you're going to notice as we go through these exercises is if you're not following one of these best practices, it will actually explain what the problem is, why a particular host was not rated for placement. A good example might be that you've said that this particular VM has to be highly available, and you don't have any clusters available. You only have standalone hosts. In that case, you're going to get that 0 stars, not an appropriate host, but we're still going to ultimately let you deploy it if you need.
Where that becomes pretty common as well is when you deal with the network objects. If you've not associated any network interfaces on a host with a particular logical network, and the VM requires the logical network, you're going, well, why can't I put it on host 3? No network adapters on this logical network. Oh, go fix that, test it again, you should be good to go.
Yep, so really the guidance is kind of one of the added bonuses here, making sure that you really are going to follow best practices and the VM will be functional after it's deployed. And so this will take kind of a lot of the configuration considerations out of this for you. Using the star system, you kind of get some good guidance as to where you want to place your VMs. Now let's go ahead and go to our demo. So here we are back inside Virtual Machine Manager on System Center 2012 R2. And we're now going to go over to our VMs and Services workspace. We've already got our virtual network built. We've got our host, but we don't have any VMs running on this host. So again, as we kind of look at the different hosts we have SCVMM01 as a standalone host, and then our cluster Hyper-V. So let's go ahead and create a new virtual machine. Now during this process, when we kick it off, we have two options. Creating a brand new virtual machine with a blank VHD, and if we kind of go down that path, you're going to get kind of the same configuration options you have with Hyper-V.
The generation is there, for example?
Yep. generation, all those profiles. But since we're really focused on using templates, building in that standardization, we're going to go ahead and build a VM from a template. Now, for this first VM we're going to use, we're just going to kind of go through these steps as a proof of concept. So we're not actually going to go and create a full VM template. So we see the full completed VMs up here. We're just going to go ahead and select a brand new VHD disk. So in this case, let's go ahead and select our file server VHD. We're going to say that this VM is going to go serve as a file server. Click Next. So we'll call this VM 01. Again, generation 1, generation 2. Click Next. And then, since this is a brand new VM, none of these profiles are pre-configured for us, but we could go and add them still. So even if it wanted to be a unique VM, we could still go and use one of those other profiles we selected. Now, we can, for the most part, keep the default settings here. But what is different in VMM than what you get using basic Hyper-V Manager is, first of all, the compatibility profile. What type of host should these run on? And since this is going to be a Hyper-V virtual machine, and we're using a VHDX file type, we need to make sure that we place it on a Hyper-V host.
So you could have other host profiles that included specific requirements for the host, right?
That's
so,
right. Maybe you need Hyper-V high speed, something like that.
Something requiring 10 gig, or with a RemoteFX video card, or with a fiber channel adapter. These three built-in profiles are basically platform.
Exactly.
They just say, hey, it's enough to identify the type of platform, but you can take that to another level of detail and go very specific types of hardware on a platform.
That's right. And then the traditional configuration options. Now, for this VM, you know what? Let's make this highly available. And we're also going to go and create this as part of an availability set. I'll cover that in a second. So we'll go and say this is a high priority, high available virtual machine. So let's spend a minute talking about availability sets. We covered this yesterday as we looked at it through Failover Cluster Manager. And within Failover Cluster Manager, this was exposed as what we call an anti-affinity group. Specifically, it used a property of the cluster called anti-affinity class name. Now, very honestly, it's a little tough to configure these private properties, this anti-affinity class name. It's done through PowerShell, so VMM exposes this through the GUI and creates this concept called availability sets. And essentially, if you place two VMs in the same availability set, we're going to use anti-affinity and purposely try to distribute them across different hosts.
You like saying anti-affinity, don't you?
Anti-affinity.
You've said it
off the tongue.
5 times in the last.
Okay, everyone take a shot when I say anti-affinity. So what we're now doing is, with this availability set, and again, some good examples that you'd use this for, identical infrastructure servers, right? You have 2 domain controllers, have them run on separate hosts. A guest cluster, have the different guest cluster nodes run across different hosts. So we're now going to go create our availability set, and we're going to call this our file availability. So this is going to be a file server. Click OK. And right now, this is the only VM that's part of this availability set. So until we have a second VM that's going to be part of this, this property won't really impact anything. So we've configured our hardware settings. We now go and select our destination settings. So we could go store this virtual machine offline inside our library, but we want to go and place this actually on a host. So let's go place this in one of the hosts in the Contoso host group. Click Next. And this is where we're going to start to get our star generation. Okay, so here's a question for you guys. Why do these 2 hosts have 4-star rating, yet this other host has a 0-star rating? Why do these 2 cluster nodes have a 4-star rating and the standalone host does not? Well, let's take a look at the rating explanation tab.
I know.
Okay, you got it. Go for it, Corey.
Oh, I can't actually read the screen. I was just playing into your thing, so.
I
think I know.
Let's zoom in a little here and we'll see why. So as we zoom in, the rating explanation says this virtual machine is configured to be highly available, but this particular host is not part of a cluster. Now again, we could go ahead and proceed and click Next. It's not going to block us, but we're kind of violating one of the goals for this particular VM. Now if I click on Node 1 or Node 2 in the cluster, get a nice rating, everything looks good, it's a Hyper-V host, I'm up to date. Now there's also an option on the top here for expected utilization. This is a feature that isn't used particularly often, but it kind of helps you do some prediction and some planning. And what you can basically say is, how much I/O is this particular VM going to be using? Based on your expectation, right? You know, this is a prediction. It's not an actual test. So is it going to take up 20% of the CPU? How much disk space? How much disk IOPS per second? What type of network utilization? So we're essentially creating a simulated VM load. Once we would do that, it could go and actually change those different settings. So let's say, for example, node 1 had, well, that's not a good case for a cluster because they use shared storage. Let's say, for example, node 1 had some throttled bandwidth on it, node 2 didn't. Well, if this particular VM used a lot of bandwidth, we then might actually recommend one node or the other node. So this can even be granular based on this anticipated load. And this rating system will dynamically update. So an example test question might be, how can you use Virtual Machine Manager to predict the load of a VM before placement? And you do that using this expected utilization button. And let's go ahead and we'll select DPM01 as our cluster node. Click Next. And go configure some additional settings here. So where do I want to go store this VM? Well, since this is a cluster, and I have some CSV disks, I want to go ahead and actually put this on one of my cluster shared volume disks. This is, again, the distributed access file system for Hyper-V. So I've gone and changed the path to cluster shared volumes. So even though our default path was one thing, now that we've made it a cluster, we want to make sure that we are using the cluster path as well. Now, if I had some additional networking or fiber channel options, I can configure these here. Click Next. Now, the next thing it's going to ask us is about what virtual switches should this VM connect to. So this VM, as we defined it back in our hardware profile, had one virtual network adapter. What we can do is we could go create switches, add it to port classifications, add it to VLAN classifications if these are configured. But you know what? We're not going to go and connect this to the network quite yet. Final thing we can do here are the action properties for the virtual machine which is running. So the first choice here is, what is the action to perform when a virtual machine starts? We have three different options here. Always start the VM, don't start it, or turn it on if it was running before the crash. Now, Corey, do you have recommendations as far as if you're doing reboots? What's kind of a good best practice for the automatic restart operation?
Well, it depends on how important the VM is. So, like yesterday, we talked about this notion of doing, in a cluster, VMs that are set to high, medium, and low in terms of priority. If you choose to restart the VM, and you know it can, I guess here's what I kind of do. If you can feel like you can pull the power cord and the VM will come back up in a healthy state, then you're probably okay to do this. If the VM's critical and you want it to reboot and it's okay rebooting on its own, then you can let it go ahead and reboot. But at the end of the day, it depends on what's happening in the VM, how well that VM will survive an actual reboot, as to whether you want it to just auto restart. Most of the production VMs that we put in, we don't necessarily want them to auto restart in the event of a total failure, because we want to be able to go in and make sure that they're coming up healthy, with the exception of things like domain controllers that we know we need to bring up. But for non-supercritical roles, just try and have those come up so we can watch and make sure everything, check service, make sure everything starts properly.
So I think your best practice is it depends, right? What is the application? How does it need to start? What other dependencies are there in the infrastructure?
Yeah, the best practice is think about it and make a smart decision.
Okay, good best practice. So second option that we can see under configuration is a delay timer. How long do we want to delay the startup? So this could be used in a couple of cases. First of all, this could be used to help prevent startup storms. The system is booting, starting up too many VMs at once. Second way this can be used is for dependencies. So let's say you have a series of 3 VMs that need to come up in a certain order. Well, you could configure the first one to have a 15-second delay, the next one a 30-second delay, 1-minute delay, something like that, so you can kind of stagger when each of them are going to start up. Now, the other option we have here is what happens when the virtual server stops. And this is basically saying, if you have a graceful shutdown, as opposed to a hard crash where someone pulls the power, if you have a graceful shutdown, what's the behavior we're going to take here? Do we want to save the running state of the VM to a disk? Do we want to turn off the VM, which is basically equivalent to pulling out the power, it just kills it, or do we want to gracefully shut down the VM? So you've got these three different options here. In this case, we'll go with the save state. And then, which is the OS that's going to be running inside that VM data center? Now, we also have a feature here called Performance and Resource Optimization. We're going to be talking about that a little later when we look at some of our integration between Operations Manager and VMM.
Now, you pick the operating system there. At the end of the day, what is that doing when you select that operating system?
So basically what we're doing when we're specifying the operating system, we're going to go and inject the integration components for that appropriate version of Virtual Machine Manager. Oh, sorry, that appropriate version for the guest operating system. As a refresher, the integration components are what makes the VM know that it's a VM. This includes things such as the ability to start the VM, stop it, pause it, to send commands from the physical server up to the VM, and to do some some security configurations if you're going to cluster it and do that VM health monitoring inside. Again, equivalent to VM tools as far as those pieces. And basically the reason why we selected here is each operating system, not each, but a lot of the operating systems have different integration components, and you can see that we even have all the Linux distributions listed as well. And so it's just going to make sure that we install the correct integration components on those VMs. All right, we can view the script, and this is actually where we're going to go and do some scripting as well. So take a quick look at this create script here.
All right, so what this script is doing, I was looking at some questions, so I didn't quite catch what you were doing. So you're catching me a little bit off guard right here. So I would need to take a look at it.
So basically what this script here is doing is we're going to go ahead and first create our virtual SCSI adapters, so our network, our DVD drives, virtual non-SCSI adapters, so our IDE adapters, COM ports, floppy drives, CPU, capability profiles, and then basically define that into a hardware profile.
So, I mean, this whole process right here is what was created when you ran that create VM wizard, correct?
Correct. Now, this hasn't actually executed until
No.
I hit create the first time, but
Exactly.
it kind of tells me, well, what is going to run.
Right, and so you can actually go through this and see this is, the entire process of making a VM. Now, there's a lot of stuff in here because you specified, a fairly large number of properties when you went through and configured this thing and pulled them all from the template. So certainly a create VM PowerShell command, even in Virtual Machine Manager, doesn't need to be this complicated.
Absolutely.
But if but what you've got here is something that you can very easily, if you know PowerShell, go through and automate to a great degree.
Let's do it.
A lot of people, if you just go back to the script for a second, I've been asking about these ID values that are kind of hiding in there, and the importance of them. Those are actually used for the job tracking. And so the scripting engine injects those in. You don't need to necessarily inject those if you write your own
Correct.
scripts.
It's an optional parameter.
Yeah. And they're used when VMM does run through the wizards. This is how it does the replay component, because it creates this job. It's got an ID value, so when you want to retry a job, it uses the ID to make sure it retries the exact same job again.
Yeah, essentially it's a tag that allows it to group these different activities together so that it knows this is a collection of activities. We want to kind of work these through as a group.
Yeah, but if you're going to write your own scripts, you don't got to worry about it.
Absolutely. So let's go ahead and we're going to go and save this PowerShell script into our library so that we can access it later. So I'm going to go to DC01, VM share. Let's go to DC01. It doesn't really matter. We'll just put it back in our VMM library. That's fine. And we're going to make sure we save this as a PowerShell script. So that's important. And we're going to call this vmcreate.ps1. Save it as our PowerShell script.
So what you're doing is just changing it to all files to
Correct.
actually put the .ps1 extension. If you leave it at the default, it'll be .ps1.txt, which is not recognized as an executable type file, so that run action you're going to show won't turn up.
That's correct. Yep. So we've now saved the script, and in a minute we're going to go and create a second VM using that script. So let's go ahead. We have an option to start the VM after deploying it. That is disabled by default. It's an assumption that other VMs are going to be created. Other configuration steps will be needed. So we click Create. We're creating our VM.
So just click on the Details tab, and this is where you can see all the individual steps that are happening, and that's where the ID value ties all those together.
That's right, yep. So we see everything be created here. And what we're now going to do is actually go into our library, take a look at that script we've just created. One second. Let's just go take a look at our actual VMs now, before we do that. So here we go. Here's the newly created VM. Currently in the stop state. We can see that it's part of the file availability set. Host, CPU average, everything else. Again, it's turned off. So if I go actually look at the cluster, we can see everything broken down. It's currently running on DPM 01. Back to our library. Let's start to take a look at these PowerShell scripts here. So now that I've gone and created a new object in this library, I'm just going to refresh it, make sure that we go and collect it. By default, I believe the refresh is every 5 minutes. So if you've gone and copied something into the library, it could take just a couple minutes for it to appear.
Library, I think, is actually an hour.
Is it an hour?
I think it's an hour. At one point, in one version, it was an hour. At one point, it was an hour. I don't think I've actually looked at that setting in this version.
Okay.
But
Well, you know what? We have an open question. So for our Q&A people that are helping us out, if you could do a quick search on that, what is the frequency that the library
I think
refreshes?
it's configurable in the settings, but we don't need to go there.
So what we now have here is we force the refresh so it appears immediately. And take a look at my VM library, and here's the script. So we can see that this is now a library object that we can manage. So I can say view the file, pulls it out, open the file location, and I even have the option to rerun the script. Now what I'm going to do here is take this script, do some edits inside PowerShell ISC. I just click edit here, that should open ISC. And we're going to go replace some variables in it. Now, the very first thing that I'm going to do is just set my execution policy. And basically, hey Corey, can you actually cover what does setting the execution policy do?
So by default, PowerShell assumes that everything is bad. So all scripts are evil and they're designed to hurt you and they're going to break everything. So the result of that is it will not let you run any script other than something you've written on that machine. So if you want to start running scripts that are, for example, on file shares, which are possibly places where bad things could be, it says no. And so the execution policy is a way of controlling the level of, the requirements for a particular script to be able to run. So as an example, if you set it to local only, it's only local scripts. If you set it to remote, it'll run remote scripts. You can also require that it be a signed script. So the script's actually signed with an Authenticode certificate to verify that it hasn't been modified or altered. So you've got a couple of different levels of execution policy that you can set. For most guys that do this, they set it unrestricted because they go, you know what, I trust my scripts.
I trust myself, yep. So in this case, we're just going to go ahead, set this as unrestricted, make sure that we eliminate any variables there. And then to go edit the script, PowerShell has this nice editing function called replace in script. Okay, you guys know it as just replace. But what we're going to do here is say we want to find VM1. And now we're going to start calling it VM2. And so this will go through the whole script and it will replace every instance of VM01 with VM02. Now this will make sure that we have a unique name in the script. Okay, we've done that. Click close. We'll save the script again and let's execute it. Run the script. We will wait about 30 seconds and we'll get the output. Everything's being created down here. Script is done. So now let's go back inside VMM, take a look at our VMs and services, and look at that. Our second virtual machine is now being created from that exact same script.
Now, if you wanted to do, 5 VMs in that script, do you know how you would go about doing that, or is that?
Well, I'm not a great scripting guy, so I would go and edit that variable 5 times and hit run 5 times. How would you go pull in that batch file? I know you can inject batch files, nested loop in. How do you recommend we do it?
Well, so with PowerShell, it supports loops. So you could literally do what they call a for next loop within PowerShell, and just go on the top, literally go 1 dot 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 or 1 dot dot 5. You pipe that into a for next loop, and run the script, and it'll just make 5 VMs right in a row.
Awesome.
So that's the power of PowerShell. It's nothing to do with VMM. It's just the power of PowerShell. And if you're good with PowerShell, the world is your oyster.
Very nice. So we've now gone and showed you how we create a VM from a script. Let's go and show you a third way. Let's actually go and create a VM from the template that we built in our earlier exercise. And by the way, another feature within this as well is you can run the actual scripts directly from the library as well if you wanted to. So let's go into our VM template. Here's the VM template which we created in our last module. We can select this and we can say create a VM. And what it's telling me here is some of the features that you've enabled are going to be part of a actual service on a particular VM. So not all the features are going to be added, but we're still going to let you continue. So in this case, we're going to call this VM03. Configure the hardware. Go configure our hardware settings. Operating system. We'll go and configure our operating system settings. You can actually see that we're using the template, of course. Destination, pick a host which it is going to run on. It's going to go take a look at our utilization, and it looks like it's going to flag some things. So let's investigate the challenges that we're seeing here. The number of processes on VM3, 32, is actually greater than the number of processes that our host has. Now remember, I'm just running these as VMs. These VMs have 2 processors, so it's actually going to prevent me from overcommitting an individual host. So this is one of the nice ways that you can ensure that as you're deploying something, you're not going to go get yourself into trouble. All right, that is our VM creation. Let's switch back to our demos, and now we're going to talk a little bit more about cloning and creating VMs.
This is just another way to go about creating VMs from a VM that you already have.
That's right.
You know, maybe you've deployed a file server and you just want 4 more file servers, and you know the file server you got deployed is the way you want it, so you can do these cloning operations. And then also, as part of this, we'll look at how we go about creating new virtual machines by importing other types of VMs from other platforms like VMware, for example.
That's right. Now, virtual machine cloning, one of the new features in Windows Server 2012 R2 Hyper-V is called live cloning. It allows you to actually take a clone of a running virtual machine with no downtime to that VM. So how do you use this? Well, we're thinking that people are going to be able to use this to do some troubleshooting of production systems. Now, a few considerations to keep in mind. If you take an exact clone of a running virtual machine, you're also cloning its domain name, its FQDN, and all those unique identifying properties.
Those are really bad things to clone.
Exactly. So when we do the clone, what we want to make sure we do is, with that clone, not actually start it up so we don't do any conflict. We want to go isolate it, and then we can start it up and troubleshooting. But we want to make sure it's not going to be on the exact same network as the real one, the original one.
Absolutely.
Now, what this means you can do as a troubleshooting mechanism is you can keep your slowly performing production system running, isolate a copy of that production system, figure out what you need to fix, take it down, add patches, whatever you need to do. Once you've figured out the fix, then you could go back to your original, go make the changes there. Alternatively, you could go and export the fixed one, keep it back onto your main network, but keep it offline, power down the bad one, power on the good one, assuming it has the same names and credentials, and clients can then start connecting to the good one. So you can kind of do almost like a hot swap, replace the good one with the bad one. So what happens with the VM cloning? Well, essentially, this is a way you can do to do this rapid deployment as well as, isolated and troubleshooted. And it's going to make copies of all of those different components within a VM. So the VHD or VHDX file, the configuration files, which is the XML that defines the structure of that VM, and then the contents of its memory. Now, if you are using 2012 R2, the new version of Virtual Machine Manager, it supports live clones. If you're using 2012 RTM or Hyper-V 2012 RTM, you will not be able to do the live cloning. You have to actually take the VM offline. So some considerations around cloning. First of all, keep in mind that it contains those same unique identifiers, such as the security ID. And so if you are going to take a clone and redeploy it on the same network, same environment, you want to run syspar, or you want to go and manually change those variables. And then, of course, you want to make sure that you have enough disk space around. Let's move on and talk about converting a virtual machine as well. Now, what we want to do here, as we're looking at actually converting VMs, is going through and essentially copying, first of all, the VHD file, whatever their format is, to our VHD file. Secondly, the configuration information. So what's the physical layout in the XML? Map that back to our XML. Now, with our V2V migrations, there are a few limitations on this as well. One thing that it will do is if you're going from VMware over to Hyper-V, it will remove VM tools, it will add the integration components. But the big catch with that is the boot drive. VMware virtual machines boot from SCSI, Hyper-V virtual machines boot from IDE.
Or SCSI.
Or SCSI.
Depending on the generation.
Depending on the generation, good catch. So if you're converted to a Generation 1 virtual machine, you do need to go and switch it and change it from a SCSI boot to an IDE boot. If you're converting it to a Gen 2 virtual machine, you don't have to do that step. Now, conversion supports all of our ESX versions here. So let's go over to our demo and actually take a look at this. So a little earlier in our modules, we went and added a offline virtual machine as a VMDK file. And if we go take a look at it in the library, so that's under VMware. This is essentially the offline file that we are going to copy, our VMware file.
So how did you get this? Is this the equivalent of like an export in VMware?
Yeah, it's basically an exported VM from VMware that goes and basically gives you a copy of the virtual machine and its associated file pieces that then get recomposed as the VM. And so you can see here we have the VMDK file. VMDK file is the equivalent of our VHD or our VHDX file. Now, what we've done to date is we just imported the full VM. But what if we wanted to just import that VMDK file? Let's take a look at that. Import a physical resource. And what this will do is it will take just that VMDK file and then make that as a reusable object in our templates. So I'm going to say add a resource. I'm going to go and navigate to my share, so DC01, VMware, and actually select this VMDK file. Where do we want to go and place it? Let's go place it in the VMware folder. View our script, import the resource, click import, and now this is going to go and import and make this VMDK file available for use. Now, very, very important clarification here. This does not convert the VMDK file. It is still a VMDK file. It does not make this able to run on Hyper-V. It is still a VMDK file. This means that this file can only be used when creating a new VMware virtual machine and placing it on an ESX host. But it's still an object in our library that we can manage. So as I go take a look at my VMware folder, we can now see this as a VMDK file type. So we've imported our VM, and we've also imported this VMDK file. Now, if I wanted to go and create a new virtual machine using this VMDK file, we'll call this VMware. We're going to go and hit an error because I just don't have any ESX servers that I can go and place this on. So this has to be placed on an ESX server because it's a VMDK file. Keep all the default settings. Try to place it on a host, and we're going to get error. Unsupported on this host virtualization software, unsupported, unsupported. And again, that's because we're trying to place a VMware VM on a Hyper-V system.
And it was primarily that compatibility profile that drove that decision-making process.
Yep, that's right. So let's now go and actually convert a VM. So we're going to take a full virtual machine, again, based on VMware virtual machine, and now we're going to go do a conversion. So this is actually going to go and convert the VMDK file to a VHD file, and then also copy the metadata from the configuration. Now, the way you need to remember that a virtual machine is composed is that it has an XML file that contains its configuration data. Again, the configuration data is things such as what's the name of the VM, what networks is it connected to, what is the memory, that type of thing. And a lot of those hardware components are standardized. So regardless of if you run a VM on VMware, you run a VM on Hyper-V, you still need to define the memory, the virtual networks, the boot, the disks, things like that. And so that is essentially what we are mapping. We're reading the VMware XML file, and we're remapping that to a Hyper-V XML file. That way Hyper-V can then understand how to use that VM. So under our Hyper-V manager, we're going to go to this option of convert a virtual machine. we then get asked to specify what is the original VM. And so here we go. We'll select this VM that's available in our library. We see it's an ESX server. Click Next. We then get to specify a new name for it. So we'll kill this Windows Server 2012 HV for Hyper-V. Get to specify some hardware and some placement. I'm going to kick this down a little because my VMs are kind of small. Our simulated hosts are kind of small. Then it's going to go and search these hosts. Now you're still going to see that, hey, none of these hosts are going to work. Why is that? Well, we will take a look here and take a look at this. So the disk is IDE. We have SCSI. This is going to cause a warning. Second thing we have is this particular host does not have the storage classification for this type of disk. Now if we go back and we actually take a look at the disk, we'll have to do that back in the wizard, we'll see that it uses, we're using iSCSI disk and this is not able to support iSCSI. Nevertheless, let's go ahead and add this anyway, since we're not going to go bring it online. We'll click Next, where we want to store it, keep our default location. Configure it to virtual networks if we wish. What actions do we want to take? Oh, let's turn on the VM. We can view our script, and we see a new SCV to V, a virtual to virtual conversion. Click Create, and it's going to go through this process of converting the VMDK to a VHD, and then extracting the VM tools, adding the integration components, and then remapping the metadata to ensure that this VM maps up with the same hardware profiles.
Now, from experience, once you've done this conversion, you bring the VM online, you need to take the time to go through to make sure everything works properly. Because what you've basically done is, taken the operating system, ripped all the hardware out of it, put a whole bunch of new hardware in and booted it up. And so there's, especially if you've got a lot of applications in there and things that, use the different types of virtual hardware, you just want to go through, don't assume that everything's going to work perfectly because you've made such a drastic change. You just got to kind of make the time to go through the VM, make sure the VM is healthy. This isn't a magic button that makes everything work perfectly all the time. It will do the conversion, but there may be dependencies in the VM you've got to go resolve outside this process.
Absolutely, and actually we have one of them highlighted here. So as we've done the V2V conversion, the conversion was successful. As we go zoom in here, take a look, it's saying, hey, we cannot locate the boot volume. Hence, there's going to be a problem when you try to start it up. And again, that's because of this IDE SCSI conflict. So I'll close my jobs window. I'll go down to this standalone host that I deployed it on. We can now see this VM that was created running on the host. And we have all this information that we injected. So we changed the memory, changed these other parameters, and then we would be able to go and start this VM once we went and reconfigured the operating system. So let's take a quick look at that. We can go down to our properties, and to general. We're going to now go and define our operating system. Go to our data center. We can add additional information, cost center, tags, things like that. And under our hardware configuration, we see that this is currently connected to IDE. So what we have to do here is create a new SCSI adapter, which is going to be our boot volume. We go select our Windows Server. We'll go and move the channels, and then one of the final things we need to do is go configure it as a boot volume. And so that will be the end-to-end process. Now, I don't have the full VHD for that other version of Windows Server to go and inject that. As you may recall from the library, these sample VHDs that we have here, those are just small templates, not the actual full VHD. So I can't do that end-to-end conversion and go replace our OS on this. So that kind of summarizes how we do the conversion. I'm going to spend the next few minutes just kind of talking about some other third-party hypervisor management capabilities, going right from the top here. So kind of what can you do to VMware infrastructure and Citrix infrastructure? What can you not do? So going from the top here, we have a concept of clouds we'll be talking about actually in the next module, which is our collection of resources. We can manage Citrix and VMware using clouds. So you want to think of a cloud as a aggregated pool of resources containing all your storage, network, CPU, memory. Now, you want to break down clouds in a similar way that you can break down host groups, and so you may have a cloud just for your ESX servers. So we do support this concept of clouds here as well. With VM networks, we can go and create VM networks on our Citrix and our VMware infrastructure. Go connect those VMs to that, have them communicate across that ESXi infrastructure. We can provision storage to Citrix and VMware, so long as it supports that storage type and storage protocol. So, for example, VMware uses NFS, we use SMB. We wouldn't try to go and provision an SMB share over to VMware infrastructure. Wouldn't work correctly. And then as we look under our host management, we can go and add our different VMware infrastructure pieces to our various host groups. And that also includes our VMHA clusters as well as our Xen clusters. So being able to manage both at the individual host level and at the full cluster level. As we look under Fabric, within infrastructure, we can use our same library servers to manage VMware and Citrix objects. You already saw us import an offline virtual machine and import a VMDK file. With our Pixie servers, I do not know, can we Pixie boot VMware or Citrix systems? Do they support Pixie boot network protocol?
No clue.
No clue. Okay, I have stumped myself on this one, so hopefully our Q&A team, they can help me out. Follow up on this one.
I'm sure
can we go Pixie boot to a VMware environment?
I'm sure someone out here knows the answer to that.
Now, within our update management, this is one area that does not support Citrix, does not support VMware. Microsoft updates function only on our Microsoft systems, so we have to apply those to Hyper-V hosts, other infrastructure servers running Windows. vCenter servers, this is where we'll actually see our collection of VMware servers. Now, under networking, we can take advantage of all of these different profile and networking capabilities on Xen as well as VMware infrastructure. Storage, same concept. So long as the Citrix or the VMware infrastructure supports the various storage protocols, we can go add them. We can use providers. NFS file servers, again, not SMB.
So, by the way, there's a flood of yes, you can Pixie boot VMware coming in on
Awesome. Thank you, everybody. Yes, you can. Pixie boot VMware. Final thing we're going to browse through here is taking a look at our templates. These templates, both service templates, VMware templates, they can be applied to both Citrix and VMware infrastructures. We're going to look at services in our next module. Build our templates. They can be applied to VMware so long as they meet the hardware requirements. Again, VMDK is only going to run on VMware infrastructure, VHD, VHDX only on Hyper-V. Profiles can be used across all of these diverse clouds as well. And our library servers, again, can be used to manage these different clouds. Now, within our settings, this is an area where we haven't really explored much. Our settings here allow us to go and pre-configure some types of collection information. So how often do we refresh our library?
1 hour.
1 hour, there we go. Automatic library refresh. 5 points for Corey. How do we go and manage remote control? So what's the default port when we actually want to go and connect to one of the VMs in our infrastructure? What type of network settings are we going to use as we go and actually manage the VMM management server? Database connection to our SQL database. What is the name of our database? What's the name of the instance? We'll cover security shortly. Servicing windows basically allow you to predefine specific timings when you want to perform certain actions or avoid them. Configuration providers, these are essentially add-on modules that we can add, and we support VMware and Citrix configuration providers so long as they explicitly have a plugin for VMM. That's important as well. And so as an example, we have network load balancing built in. This is where, let's say you wanted to add an F5 load balancer, you could go add it as a configuration. And then console add-ins, again, if we want to go and actually add a component within the VMM console, we could go and add this component here. So you go import a console add-in. So this allows you to have features being built and developed by third parties. Well, that was a quick view of creating our VMs, managing VMs, as well as our third-party hypervisor management.
So our next module that we're going to move into here shortly deals with clouds with VMM. So now that we've done the fabric, we've done the storage, we've defined VMs, we now got to start taking an even higher look up and say, okay, how do we define logical groups of these resources that are limited to specific people, right? It's fine to add SANs, but who's allowed to manage them? It's fine to create different types of VMs, but who's allowed to use them? And that's where the cloud element actually comes in. It's a partitioning of the capacity and the resources and limiting of permission so that you can only access those things you're allowed to access. So we'll be diving into that right after the break. I'll be coming back in about 10 minutes, so we'll see you guys then.
Thanks.
And we're back. Microsoft Virtualization with Hyper-V and System Center. Corey Hines, Simon Perriman, bringing to you Module 11, Managing Clouds with Virtual Machine Manager. Now, before we jump straight into Module 11, we've got a couple of quick housekeeping items from the previous module. One of them being a question that came up rather frequently, which with regards to virtual machine migration. Okay. And so the question was essentially, hey, I want to do a VMware to Hyper-V migration. I don't have VMM yet, because we're kind of, we're in the evaluation phase. Okay. I want to take some of my VMs off VMware, throw them on Hyper-V, see how everything goes, see that I'm happy, and then if I am, start layering everything on top. Is there a way to do this without VMM? There
is actually. If we could switch over to my screen here, I'll actually show you what I'm going to pull up. This is the Microsoft Virtual Machine Converter, and you can find that one at aka.ms mvmc. So Microsoft Virtual Machine Converter. And basically this is a free download independent tool. I'll zoom in a little for you here. Giving you the ability to go and convert VMware VMs over to Hyper-V VMs. There are some limitations with this. It is not as fully functional as the VMM version. So if this actually doesn't kind of meet all your requirements that you need, here's the trick. Go download the evaluation version of Virtual Machine Manager. You have 180 days. Go use V2V from that. You of course have to install it, use it, but that's how you could kind of use the better temporary version. But again, if you don't have this, you can go ahead and use the MVMC. Okay. Good question.
Fantastic. So with that, we'll move into managing clouds. One of my favorite topics, right? Which is, how can you take all this capacity and logically partition it amongst multiple users, multiple customers, and the term that the industry uses is tenants. Mm-hmm. And a tenant doesn't necessarily mean, you're a hoster and you have companies using your stuff. It could be departments in your organization. It could be administrators within your organization. It's just a way of taking that physical capacity, making it fundamentally invisible, and then allocating and partitioning logical capacity to different users.
Absolutely. Now, clouds, first of all, I guess let's kind of define what we're talking about with a cloud. It's a term that's thrown around quite a lot, right?
Didn't it used to be the internet at one point?
Right, yep. So being the most popular term in the world, we better define what exactly we mean by a cloud here. Functionally, it's going to be your pool of resources. And that's really just the best way to think about it. So anything within Virtual Machine Manager that you've added under management, that goes to part of your main cloud. So under storage, that includes your storage providers, iSCSI, file shares, fiber channel, so basically all those storage components. Under networking, it includes all the network resources like your load balancers, your profiles, ports, virtual templates. And then under the servers, that includes all of your physical hosts and your clusters, crossing all three hypervisors, VMware, Citrix, and Hyper-V. So that is what VMM calls its cloud. But what we're actually going to do within VMM is carve it up, break it up. Now, first of all, let's just quickly talk about other types of clouds we see here. Public cloud, private cloud, hybrid cloud. Now, a public cloud is what we refer to, in our case, as Windows Azure. It's basically a collection of resources that the public can consume. So think of that same model in VM, right? It's your aggregation of storage, networking, and compute resources. Azure's the same thing. It's just a really, really big aggregation of all these different resources. You then have the concept of a private cloud, which is what we're using inside VMM. Our cloud in VMM is our private cloud. It's the aggregation of resources that are your resources. And then finally, we're going to have what we call a hybrid cloud. And a hybrid cloud is where you're essentially sharing resources across both a public and a private cloud. And a little later in this chapter, we're going to take a look at using some public cloud resources and some hybrid cloud resources, as well as third-party hosted cloud resources. So virtualization in the cloud, where does it fit in? Well, as we've really thought about virtualization, a cloud requires more than just being virtualized. You know, a couple of years ago, about 2 years ago, when we first started talking about the Microsoft cloud, people said, I have a virtualized environment. I have a cloud, right? Not quite. So we really want to kind of define where virtualization ends and where cloud begins. Because this is how we're trying to shift mindshare from just having a data center that's highly virtualized to having this fluid and dynamic data center. Now, virtualization absolutely is a critical part. It, of course, gives you our benefits of consolidation, easy deployment, elasticity and automation, having multiple tenants, and then high availability and mobility. But having a private cloud requires more. Pools of resources, automated management, self-service provisioning, and usage-based chargeback. This isn't Microsoft's definition. These four components actually come from the National Institutes of Standards and Technology, NIST, as their definition for what creates a cloud. And so you're going to see throughout this chapter that, throughout this module, that we're covering most of these key cloud tenants just with VMM. VMM is going to help us do automated management. It's going to allow us to pool all of our resources. It's going to allow us to do self-service through App Controller. The one thing that VMM will not offer is chargeback, but we could take advantage of chargeback by using System Center Service Manager. So it is included in the System Center suite, and it will actually, Service Manager will actually monitor the resources which VMM uses, but it's just exposed through Service Manager. So chargeback will be, should be out of scope for the exam. So here we go under VMM. You can see the management console here. You see clouds, which is the pool of resources. Below that are the subclouds. So how would we go about and actually break up a cloud? What are the different ways that you can take this pool of resources and carve it up? And in my opinion, we see people do this in a huge variety of ways, just like host groups. We see people build clouds based on VMware infrastructure, or based on Hyper-V infrastructure, based on what the actual physical servers are. We see people build clouds based on geography, based on project. But what the main difference is between a cloud and a host group is providing secure access for our end users. When we look at host groups, those only get managed by our actual infrastructure people, accessed by our infrastructure people. That shows that underlying physical hardware, the clusters, the networks, the storage. When we're building this level of cloud, we're abstracting it, and we're providing end users with access to the cloud. So again, functionally or organizationally, it can be managed the same way as a host group. Big difference is host group will relate to our infrastructure people and below. Clouds are generally going to relate it to our end users through self-service and above.
Now, one thing I'd like to inject in this conversation a little bit is when we talk about the idea of an end user, we're not talking about, Andy the accountant. We're talking about what oftentimes is an administrative user, right? A user who's responsible for creating objects within a virtualization infrastructure to serve business functions, not your everyday feet on the ground Salesforce and HR guys and all that kind of stuff. These are end users in the sense of users of the cloud that are defining objects and resources.
Yeah.
And those users are typically IT admin type folks in a company anyway.
A good example might be our SQL DBA, right? The SQL
Correct.
guy, he needs databases, he needs storage, he needs VMs, but he might not want to touch the clusters, the fabric, that underlying actual storage resource. He just needs, I need a VM which has SQL running in it so I can go create my new database.
Right, and he's an example of a user in the discussion around cloud.
Yep. Another one we commonly see are developers as well. One of the ways that we're trying to simplify agility in the data center is increasing the application lifecycle, meaning the handoff from developers with code down to the infrastructure guys that go and actually run that code. And so we have a lot of developers that are, using infrastructure time, saying, hey, I got my new version ready, I've compiled it, I want to go test it on one of our VMs. Well, what we want to do is provide them with self-service so they can go and request that VM. They can go request and provision their test environment, free up our time for this somewhat repetitive task. And so going back to those private cloud concepts, we have self-service, enabling an end user to make requests. And then we tie in automation, meaning we have a type of standard request. I need this VM based on this template. Push a button, it gets deployed automatically. So what you're kind of seeing now is we're really trying to move from just infrastructure management within this course to start talking about private cloud management and these key concepts of the pooled resources, self-service, and automation. Of course, chargeback's number 4, not on the exam. So as we look at our cloud resources, storage, network, memory, and compute. We also have the ability to use our library servers as well and include our databases, applications, other templates, physical hosts, and VMs. Now, an important concept of cloud when we start to think about self-service is defining capacity. So you have a particular user, let's say John the developer, and you have a group of users, which is the development team. What we can actually do is provide capacity maximums at both the individual level and his group level. So we could say John is limited to only deploying 10 VMs, but the entire developer group across the 10 of them can deploy up to 50 VMs. So we can put some control both on the individual and on the group level.
This is often called cloud shaping.
Cloud shaping, yep.
Is a term for it.
Now within that capacity as well, we could go and configure resources across 3 different hypervisors. We could deploy services to just one, to both, to multiple, assuming that those Hyper-V hosts will support that type of VM or application. Now as we look at managing the cloud, we have things such as chargeback of our resources. Now again, this is going to be exposed through Service Manager, but we go and collect the data in VMM. So if you go into Service Manager, take a look at that, go through the chargeback, you get to define a cost center, set up a price sheet for the price of a VM, price of a gigabyte of storage, a gigabyte of memory. And based on that pricing sheet, we'll then monitor VMM, figure out, hey, John the developer used 5 VMs, a VM costs $10 a day, John costs $50 a day, hence that's the amount of price that we would charge back. Now, chargeback in a private cloud, take a step back. Chargeback in general, when we think about chargeback in a public cloud, it's pretty logical how that works, right? I'm Windows Azure, you have your own company, you use resources, you pay for those resources. But chargeback in a private cloud is often treated differently because we're the same team, right? Now, there are large organizations where they will actually cross-charge different business units. But in many cases, it's not so much chargeback that's interesting. It is showback, which is interesting. And showback's the same concept. It's saying, this is what you've used, this is how much it's costing us, this is what we need to invest to keep supporting you. Basically, this is the cost to us for running your business. That's okay, you don't have to pay for it. But what we're trying to do is show you the resources you're using so that you can hopefully make better decisions in how you go and build things for us. So it's really driving incentives of best practices using showback.
So who cost you the most data center dollars is what you're trying to figure out.
Exactly.
And it's not necessarily measured in dollars per se, in terms of measuring to scale to an economy. It's just a measure of relative to everybody else that's important.
That's right.
Showback.
And so, maybe you have one particular development team that's using like 50% of your data center resources, every other team is using 5%. That's something where you can go to a business manager, think about how are you guys doing it, and hopefully drive some best practices, lower utilization, free up some data center resources. Now, some other enhancements as well using some of the other System Center products is application performance monitoring. Now, application performance monitoring is a feature of Operations Manager that basically allows us to not just monitor the availability of an app, is it on or not, but also measure the performance of an app, how well is it running. And this goes back to this tighter integration with our developer community, building better DevOps. Basically, what APM allows us to do is actually test code that's running on our infrastructure and actually test it line by line, figuring out how long each piece of code takes to execute. Now, the reason why we want to do this is to kind of get past that finger pointing we were talking about earlier, right? An application is performing slow. Whose fault is that? Is it the infrastructure guys because he put it on a bad network? Is it the developer because he wrote an inefficient SQL query? Well, the whole goal behind APM is to eliminate this finger pointing, is to identify exactly how long every line of code is taking so we can have a better understanding of where that delay lies. Now, Global Service Monitoring, also known as GSM here, you're not going to need to know much details of this, maybe just what the name of the feature is. But GSM allows us to go and monitor your own apps from different data centers that Microsoft provides. So it's actually an Azure-based cloud, actually it's not an Azure-based service, it's a cloud-based service that runs in our Microsoft data centers. Now, effectively, what GSM does is it allows people to upload their own test cases. Those test cases can get distributed across Microsoft data centers, and we will go and test your app in your location from these different locations around the world. So how will this be useful? Well, let's say I'm a developer and I'm selling coffee because I'm from Seattle. That's what we do here. And I'm selling coffee and I have a local website. My development team's based in Seattle, and so I know how well my website works from people in Seattle. But what about my people from Brazil, from Japan, all around the world that want to go and actually access my website? Well, if they have a bad experience the first time they go, it's slow or unresponsive, they may never come back. I may lose my customers. And so what GSM does is it allows us to basically go and upload our tests for our website running in Seattle to these 16 locations around the world and actually go and run custom web tests built in Visual Studio and send back performance data. So we could see, hey, things are working well in these locations, not so well in these locations. Oh, and here's the particular line of code that's being slow. So really trying to help you eliminate some of the problem-solving steps here as well.
I did get a chuckle that time. Seattle, right? It's three things: coffee, software, and airplanes.
There you go. So let's actually go through and jump over to our demo and take a look at building a cloud. All right, so back to our system here. Now, we build clouds under our VMs and services workspace. Now remember, even though a cloud is a collection of fabric resources, this is something that we're exposing to our end users. So we're going to put this up in kind of our end user view, VMs and services. Now under cloud, you get this default container. Well, we want to actually go and create our Contoso cloud here. Call this Contoso cloud. Within this cloud, we get to specify which physical hosts can be accessed in it. So let's go and select all of our hosts. And if you're adding a VMware collection of servers to the cloud, you can also add a VMware resource pool. What networks are going to be connected to this cloud? Which load balancers can be used with this cloud? Which VIP templates can be used with this cloud? Again, this is that virtual IP address that can be used with a load balancer. What port classifications can be used in this cloud? So do we want to make sure that all VMs deployed in this cloud have the iSCSI port classification? But we'll keep it flexible and not select any of these. Select the storage classifications available for this cloud. So we'll say that users of this cloud can access our bronze storage and our gold storage. But you know what? We're not going to give them access to local storage on any of our hosts. We don't want them affecting our parent partition. Then we get to go and specify actually what library resources are available for each cloud. And so let's say you do something based on geography. You create clouds based on different user locations. This is an example where you can help specify which users can access which libraries to make sure they are deploying from the one closest to their location. So I want my Seattle users to be using my Seattle library. So we can select the actual VM path, and we can even select individual shares that we want to access here.
So what you're doing here is picking all the objects in the infrastructure that you want this particular user to be able to see when they access this cloud. And it's only
That's
a
right.
subset. It's only the things you choose.
That is correct. And so next thing we're going to look at is our capacity. Now this goes back to these maximums we want to set. Now since we're going to make this our main cloud, we're going to use the maximum for everything except for memory. Now you can see across the different hosts I have a total of 16 gigs of memory. Kind of small, I know, just a demo environment.
Well, it's a really sunny day, so the clouds are small.
There you go. It's one of those rare ones we get in Redmond in November. Click next. Actually, let me just take a step back. Take a look at the other things here. We have virtual CPUs, memory, storage, number of virtual machines to deploy. And then there's also this option called custom quota, based on points. Quota is actually a setting which you can go and configure yourself, define it whatever it means to you. So maybe you have a special business need, and you have, let's say, widgets. I mean, very obscure example, but widgets is something which limits when you can deploy resources. Maybe it's number of free hours for a particular engineer. But essentially, you can go and create custom variables and still map those within the size of your cloud. So if you get asked a question on the exam, you're trying to set capacity for blah, and it's not a VM, storage, memory, or CPU, could be a question asking about quota points, and you'd say, hey, this has to be a custom resource. We're going to go and configure this as a quota point. And finally, which VM capability profiles are going to be used.
So by checking Hyper-V there, you're saying that this cloud's only going to deploy things on Hyper-V.
That's correct, yep. But we could select multiple, so you know what? Hey, let's just go select all three, if I had all three in my infrastructure. We could view our script, creating our clouds, click Finish, and now it's going to go build our cloud. Oh, I know what I did here. We need to go and edit our path. So what I actually did here, when I selected the path of our VMM library, it's not writable for this user role. So let me go back to my library here. Delete this, continue, continue, and we'll go create our cloud. And again, just to clarify what I did there, on that setting it asked me for a writable share location, and I only had read-only share locations available, so that's why it popped up the error, so that I didn't accidentally misconfigure it when I started.
Great thing about VMM, though, is it does tell you things to that level of detail.
And gives you actual guidance on how to fix it too. So, you can kind of figure out things on the fly without having to look up KB articles, search online, things like that. So now if I go expand my clouds, check that out. I have my new cloud. Can take a look at the properties of the cloud. Same different configuration options that I have down here. Okay, so let's go back to our presentation, and now we'll start to talk about the different user roles. So first of all...
No, go ahead, sorry.
So first of all, what user roles are available? Okay, so what is a user role here? Now, basically, a user role contains a collection of settings, and we apply that to a particular user, all built using Active Directory credentials here. So for a particular user role, you can say that they have access to particular profiles or templates, different members, what those users can do, access the network, other resources, other permissions.
So we had a question that actually came up in the chat window kind of regarding this, specifically asking, okay, if I want to go in and actually, I create the cloud, now I want to assign individual people access to the cloud, how's that done? And the user role is the way that that's done.
That's correct.
Now, important to clarify, the user role contains, as you mentioned, members, so it's not one account. It's not a shared account. It's a role that you can have multiple accounts to actually be a member of, and then within that, further constrain the cloud. So the cloud is a big set of, of parameters of RAM, CPU, disk, resources you're allowed to have access to. With the user roles, and you can have more than one user role in the same cloud, can constrain that a step further.
Yep.
So, for example, your developer cloud is allowed this much, and then within the developer cloud, the user roles are allowed a smaller slice of that as well.
Great point, great point. So what can somebody do within a cloud? Well, actions is a very important thing, limiting what people should or should not be doing in a cloud. Now, a good example of this is creating checkpoints. you know, you have an end user or developer who might not be really familiar with what a checkpoint is. They just think it's this magic thing to let them save work. They might be clicking checkpoint every 2 minutes as if they're clicking save on a Word document. That's going to quickly balloon your disk drive and flood it, and you're going to run out of space soon. And once you run out of space for a virtual machine, it's going to shut down when it needs to grow. So limiting things like checkpoints for people that should not really be touching them, that's really important. And that's one of the advantages of cloud, to really control what people can or cannot do. Now, within the actual user roles, there's several different types of user role profiles. So first user role profile comes by default. This is going to be our administrator role for the virtual machine manager admin. Second type of user role is what we call a fabric administrator. It used to be called a delegated administrator.
So this is the guy that runs the data center, that knows how to talk to the storage, knows about the switches, knows about the file servers.
They understand the stack.
Yeah, and they're configuring things at the physical level, and they basically, you know, they live in that fabric section of the VMM console.
Yep, that's correct. And they could have access to everything within
Absolutely.
VMM. The difference with the fabric administrator versus the main VMM administrator is that a fabric administrator can be scoped to the host group level. So if you're the fabric guy, remember fabric, host group, that's one thing. Clouds, end users, that's another group. So with our fabric and host group, we can say that this particular administrator from the Seattle data center only has access to the Seattle host. My administrator from the Munich data center only has access to the Munich host. So this way we still have some ability to make sure people aren't interfering with other data centers. The third user role we have here is the read-only administrator. This essentially gives them access to any host, any set of host groups you want to give them to, but they can only perform read actions on it. They can't actually change anything. So this could be helpful for people that are troubleshooting, first-tier support, basically the people that are kind of doing the initial analysis, initial investigation, so they can kind of see if the cluster's running, if it's crashed, but they can't actually perform any actions on it.
We call them firefighters.
Firefighters.
They're the ones that put out the fires. Something's gone wrong, they put out the fire.
All right, firefighters. Now, I'm going to quickly talk about the last one before the fourth one. The last one is our self-service user, or our application administrator. So application administrator is this end user role we were talking about, and this is the person that's scoped to a cloud. So again, fabric administrator, they touch hardware. They are scoped to host groups. Application administrators, they touch the VMs and the end services. They are scoped to clouds. So this is very likely to come up, figuring out, hey, which type of admin are you going to use based on whether they're touching infrastructure or just the VMs and services. So again, with our application admin, this is the person we're going to scope down and say, hey, John the developer, you only have access to this cloud. And John the developer doesn't understand those underlying hardware components within the cloud. Now going back a step to item number 4, the tenant administrator. This user role is new in 2012 SP1, and this administrator simply has control of creating other application administrators. So think of it as a manager of these cloud users only. So this tenant administrator, they can't change the infrastructure. All they can do is go and create new user roles for other end users. So you can maybe think of this as just your access or your security admin. So let's go and actually do this. Jump back to our demo system here. You see we have our Contoso Cloud, and we're now going to go into settings and take a look at our different user roles. So here is the default built-in user role for our administrator. Let's go and create a new one for our self-service user. So I'm going to call this my dev user. And we'll call this, well, this will be for John the developer. Here we get to specify whether they have access to host groups, access to clouds, read-only access, or account creation access. And in this case, we're going to go create the self-service application administrator. So they're just scoped to our clouds. Under members, we then go into Active Directory and get to list either individual members or even groups. So in this case, I'm going to go add my developer user, developer@contoso.com.
Now there was a question actually came up as should you use groups or users when you do this?
Either. Do you have any best practices or guidances on that?
The best practice for me is you always use groups. Whenever you assign permission, you always do it to group because users
can come
tend
and
to
go,
change, right? They tend to come and go. Groups do not. Users, you delete them, recreate them, the SIDs change, permissions go away, groups do not. So it's,
good point.
It's always a best practice, do things with groups when you're assigning individual permissions.
Yep, great point there. So we had our members, we then had the scope. So this will list all of the different clouds that are available. We only have the single cloud. Then here's where we get to define our quotas at both the role level, so all members of this user role. So this is basically, all the developers that have access to this cloud, and then the individual member. So going back to the previous example, this is my developer team, and this individual one is for John the developer. So within my team, let's go and say they can create up to 50 VMs across the whole team. And then for an individual user role, John can only create up to 10 VMs. VM networks have the ability to provide network access to these VMs. That's our virtual network. Then we get to provide access to which resources. So this is scoping down the individual templates. So in this case, let's just give them access to all of our templates. Actually, you know what? Let's not give them access to the individual profiles. Let's just go and give them access. Let me just cancel out, that'll be easier. Let me just actually give them access to the entire VMs themselves. And so when our end user looks at the library, they're only going to see these templates, but they're not going to see any of the profiles. And then this is where you actually get to specify permissions. So this is where you can do things such as checkpoints, preventing, or enabling. Now in this case, what we're going to do here is we're going to say they can have every permission, except they cannot deploy a brand new VM. But they can deploy a VM from a template. So this basically means that this individual user, so I'm going to not let them do checkpoints either. We'll follow that best practice here. But for our templates here, they could deploy a VM but only from a template. They can't deploy a VM from scratch. Add run as accounts. So basically, for this end user, when they go and perform a task, they'll have access to these particular run as accounts.
Now, when you say they have access to the account, they're allowed to use the account. They don't have access to the details of the account.
Correct. Yes. Good.
So they don't have access to the
clarification.
username and the password. They're just able to say, "Hey, I need to do a task, and this is the account to use," and they rely on the Fabric administrator to have pre-configured that account to be valid and have access.
Great point. Yep. And then we get to view the script. So we hit view script here. We see everything that's been assigned, everything that's been created. We'll click finish. And this will then go and configure this user role. Now, next thing we're going to do here is we're actually going to go and log in with this user role and make sure that this secure access actually worked.
So while you're getting that kind of started, one of the things to kind of help sort of glue this stuff together, and again, we still see occasional questions on the networking. When you define things like logical networks and you define physical networks, you connect them all together. At the end of the day, when a user goes to create a VM in a cloud, they're only going to see the objects that you expose. So the user that's creating this VM has utterly no knowledge of things like where the wires go and how their cards are connected and what the port profiles are. All they see is, I want to make a VM. I've got 3 profiles I can use to make a VM, and I can only connect it to Contoso network. So you might have 100 of these things, but they're only going to see the ones that you expose to the cloud. So they go new VM, big VM, Contoso network, go. And VMM figures the rest out based on the rules you've layered under the scene. So this is an example of what the user's actually going to see right here.
Great point. Yep. Now, what I'm going to do here now is open a new VMM connection. But notice here, I'm going to switch over to my developer role. We'll click connect, and then it's going to open a new instance. So look at the original instance in the upper left corner. You can see that I'm running this under the administrator context, giving me full access to anything within VMM. What we're going to see when this second instance opens is you're going to see that this is scoped to our dev user. And now if you take a look at our clouds, we see that things have changed a little here. Where is the fabric? You notice something different on the workspace?
It's irrelevant.
Entirely removed. We don't want them to care about the fabric.
You don't
That's
care.
the key thing.
You're administering the cloud. Why do you care about the fabric? So get rid of it.
So remember, as you're thinking about this conceptually, break apart our infrastructure guys, which are based on host group management, away from our end user guys, which are based on cloud management. And again, end user, the people like our DBA, our developer. So if we go down to our library as well, let's take a look at the profiles that we have access to. Look at that, only the default profiles exist. All of those other ones that we said they didn't have access to,
Not there.
can't see them. So let's go and try to deploy a new VM using this user role. So I go create a new virtual machine. And in this case, I'm not going to use a template. Now, if you remember, one of the settings we said was they can only deploy a VM from a template. So I'm going to go and try to deploy a brand new VM. Let's see what happens. Call this VM06. Make this a Generation 1 VM. Click Next. Go through this process. Where do I want to go place this? I want to go deploy this to a cloud. Uh-oh, there's a problem. We are having trouble here because guess what? You cannot go and deploy this to a cloud using a using a brand new virtual machine. This capacity profile will not let you deploy the new VM. So let's step back a little. Retest this and actually go and create one from a template. So I'll go deploy my web template.
If you just go back in there for a second, notice how few things are in that screen as compared to previously. All you see are the templates you have access to, which are, I see something about SQL and something VM because it's way over there. And I can't
That's
quite
right. That's our SQL backend and our web front end.
Your screen's
template.
12 feet from where I'm sitting, so I can't quite read it.
So you select our VM, could go through the process, and then it will go let us deploy it, assuming that all those other metrics match. Uh-oh, I've gone over our memory. So this is something where I just don't have enough free memory in the cloud. It was scoped down. My mistake on the configuration here. But what I'm trying to prove to you here is around the security and access, right? We said you only see these resources. That's all they saw. We said you can only deploy from a template. That's all we're going to let them do. Now we're going to run through module 12 here as well without taking a break. This is a slightly shorter module here.
Yeah, so what we've done now is essentially moved up through the process of building clouds. And clouds are the way that you carve up your overall capacity and allocate it out to users, groups, and give them access to specific resources in VMM. Now, as we get into, and we deploy VMs onto clouds. But you can deploy things that are more complex than just VMs, right? You can deploy groups of VMs that represent collections of functionality known as services. And the simplest example of this is an application that contains SQL database, some business logic, and a web front end. That's 3 VMs. All 3 VMs are configured slightly differently. All 3 VMs have different requirements. A service model allows you to define the relationships between them, and actually build it out. And you've heard me allude to the fact a number of times for this particular day, but dragging and dropping networks to create connections between networks. So you're going to see how to do that in here. That where as you build these VMs, you have logical network objects. You just drag and drop and associate, and it builds the VMs essentially graphically for you. So let's go ahead and take a look at using service models for VMM.
All right, so what we're going to do here throughout this module is we're first going to talk about our services, and we're actually going to look how we deploy one. We'll go take a break, and after the break, our final module, we'll look at integration with the other System Center components. So first of all, what is a service? What is a service template? Well, I've talked about this a few times. Our service is our logical unit to manage a collection of VMs. Manage it together, deploy it together. Basically, have this collection of VMs serve similar to a single instance. Now, this kind of trends with our models of virtualization. When we think about what is a virtual machine, it's an application which is abstracted from the underlying physical infrastructure. What is a service? Well, it's a service, it's a collection of VMs, again, abstracted from that underlying resource. So whether we're thinking of VM, thinking of service, key thing here is abstraction, no dependency on that underlying resource, free to move around. And so a service template is similar to a VM template. It's a predefined configuration for this multi-tier application. And we could deploy these templates either through Virtual Machine Manager, through App Controller, or through one of our other self-service portals. So let's take a look here at a sample service template, kind of the different things that could make this up. Now, in our examples, you're often going to see us use kind of this three-tier model, where we have a back-end database running SQL, we have a front-end web tier running IIS with a web server, and we have an application tier that might do some custom business processing, where your line of business application runs. What we're essentially trying to do here is, across these three tiers, connect them to our cloud, right? So you say, hey, I need a new VM within my web tier. Go pull those resources out of my Contoso cloud. Now, services also come with the benefit that we try to make them easy to update. So you could do updating either a component within a VM. So let's say you have an application package, you're updating from version 1 to version 2. You can just replace that application within the VM. Or you can actually replace the whole image itself. So let's say you have a master image for your web tier. You've patched the master image. You want to go replace the running image. You could go and do a replacement of the image at that running tier. So what we're now going to do here is take a look at creating a service template. Now, service templates have to be built by the administrator. And they will look, they're kind of like an extension of almost Visio, right? It's kind of that same layout you saw with Orchestrator, but rather than create individual actions that are connected, we're basically creating VMs that are connected. And we're defining these connections using a graphical interface. So instead of having to think about, does network 1 connect to VM 1, we just draw the connection, and it will make that connection for us. As we've gone and actually created these VMs, we can then create a deployment of them. So you say deploy the service, it then goes and figures out which VMs should run on which host. It's going to validate things such as availability, memory settings, and then give you the option to go deploy the service on Hyper-V, VMware, Citrix, based on whether those VMs can run on those platforms. So let's go over to our demo now and actually look at creating and deploying our services. So I'm going to close out my dev user role, switch back to my administrator role. We can see that from the top, and go back to my library. Now within the library, under our template settings, we have two templates that we've built already. Let's go and use these two templates with our front-end web tier, our back-end database tier, and go create a two-tiered service template. So first thing it's going to ask me is how many tiers, 1, 2, or 3.
And so what you've got here are basically some just initial templates or suggestions.
Yep.
You can go blank and do whatever you want, but
scale them out,
these are
absolutely.
some pretty common examples here.
So we'll call this Pet Shop Service. Release is going to be version 1.0. Click OK. And what you now see here is the Service Template Designer. I'm going to just adjust the zoom a little so we can see it better. And here you go. We see what we call our service, the name, who owns it, the release. Let's make this a high priority service. And then we see the different tiers. Within each tier, though, we don't really have anything configured or anything defined, but this is where we can go and use our templates. Now, we could go and manually build each of these tiers out by clicking on the properties, going and add in these different profiles, hardware profile, etc. But since we built these templates, let's go and actually take advantage of our templates. So with our second tier, we're going to go and make that drag and drop. That's going to be our SQL tier with our web front end.
And so what you've done there is drag the VM template onto the tier, so we know that this tier is, for example, Windows operating system running SQL or running a web server.
That is correct. Yep.
And so no configuration, just drag and drop, and it's got the deployment notes for the operating system, the hardware requirements for the VM, and all the networking requirements as well.
That's correct. So I'm actually going to expand this out a little, minimize the properties so we get a better view of the designer. And then we can take a look here. Our VM template had 2 virtual NICs. Our SQL template had 4 virtual NICs. We can see the CPU, memory, the SQL packages, the name, and then we see that none of these networks are connected. So building this service through the designer gives us the ability to actually add different networks, add load balancers, and even build up our network topology here. So I could take a look at this this virtual network here that we've created. and add that to an existing network. So we've now gone and said, hey, there's this virtual network that's going to be part of this service template. Let's go and connect it.
So what you've done there is drawn a switch.
That's correct.
And you're just dragging lines to say, hey, this NIC's on this switch.
That is correct.
And if you guys are looking real close, as he's drawing it, under NIC 1, NIC 2, NIC 3, as the lines connect, you can see the actual NIC association switch to that network. So you see not connected for NIC 2, and you see Contoso VMnet for NIC well, anyway, yeah, 2 and 3. Look at 2 and 3. Look at the difference.
So there we go. So this has gone and built our network connections. Now we also could add load balancers, things like that. Since we haven't configured the virtual IP address, we won't be able to add it in this example, but this really allows you to go build this topology. Now, as you're thinking about this as well, this can be used to design things like guest clusters. You can really run any application that you're going to go deploy within the VM from this. Now remember, this is still built from a template. So we may still want to go and do some custom configuration here. So we could go and say view all of the properties of this template, and it will then go and let us change the hardware, the OS, all of these other settings again. Now if we go and actually expand this, we then get some service template settings as well. So this is going to be our Pet Shop SQL second tier. What is the order that we want to deploy this in? What is the order that we want to service this in? How many instances do we want? What's the maximum instance count? What is the minimum instance count?
So what do the instance counts actually do?
Bad zoom here. So the instance count is basically how many versions of this VM exist in that tier.
So you essentially say, hey, this definition of the service contains a web server, but I want 3 of them.
That's right.
And it'll actually make 3 web server VMs.
That is right. And what I'm actually going to do for my SQL tier, since I'm going to make that into a cluster, is I'm going to say the default instance is 2. I'm always going to have at least 2 VMs on that tier. We'll go cluster them later. So that's the default instance count. Minimum is 2. And we can even create an availability set for this tier as well, so that those 2 VMs, which are part of my SQL tier, that are going to be a guest cluster, automatically separate themselves across different hosts, using that anti-affinity class name property. So that's gone and set up. That's gone and set up our SQL tier. Back to our web tier. We're going to make our backend our first deployment, and then we're going to go and deploy our web tier second. And generally, you're going to have your databases up and running before you go and get your websites up and running. So that's why we're changing the deployment order. So a lot of stuff I just went through here, kind of doing all this pre-configured stuff. Then we're going to go and save it. Now as you save it, it's going to do some basic validation, make sure that you didn't mistakenly connect something that you shouldn't have connected. We'll close this service designer. And then we're going to go back into Virtual Machine Manager, and you'll notice we now have this service we've created. So final step of this service here is to go and deploy it. Now remember, this is still based on a template, so we still need to provide it with unique identifying information. So we'll call this Pet Shop Service 1. We figure out what cloud or what host it's going to run on. We'll deploy it to our cloud, abstract the underlying infrastructure. Now if we made this service available to our end user, our developer role, they could go deploy that to the cloud as well. And then we see the deploy service wizard. We'll maximize that. Fit this within the window, and it kind of simplifies what we're looking at here. So if you remember, our front-end web tier had 1 instance, we see 1 VM. Our back-end SQL tier had 2 instances, so we make a cluster from it. You can see that there's 2 VMs. And here's where you get to go and actually define additional names. So if you want to go and make these VM names even more unique, adjust additional settings, you go and have this option here. Now once you've gone and made these changes, you can refresh the preview. It's just going to validate everything, make sure everything's still going to be supported. We'll then go and click Deploy Service. And we get to see some errors here. The reason why is we're trying to go and deploy this application that requires, I think, about 70 gigabytes of RAM on a host that has 16 gigabytes of RAM. So for the sake of the demo, this is where we have to stop due to our lab limitations. But this is when you would actually say, go deploy the service, go place it. But again, we have this error simply based on the fact that in this lab I don't have enough resources.
Okay. Can I make an observation?
Yeah.
I have a migraine and I'm bleeding from the ears after listening to all that.
Yeah.
That seems complicated, right? There's a lot in there. And I think what I want to do is take a step back for a second for all the folks that are kind of listening and looking at this and going, holy smokes, that, first of all, you probably didn't even know that was in VMM. A lot of people don't. It's a massive set of capabilities. And, you start thinking about all the things we've gone through today, profiles and templates and virtual networks, and all, it after a while it just kind of gets kind of fuzzy and mashy and blurry. Here's a bit of a reality check, I guess, to a degree. 90% of you will never do this, right? You simply won't. You'll use VMM to manage the fabric, and you'll deploy VMs. You may get into using clouds. A lot of people don't. There's still an evolution that has to happen in the industry before these notions of clouds become really, really, the day-to-day thing that every admin does. There's a learning curve you've got to go through to get to that point. So you kind of work your way up through the fabric, through VM management, then into clouds, and then eventually getting into things like services. So, don't look at this and kind of be deterred from VMM in any way or be intimidated by it. 90% of you will never ever touch this. And for those of you that do, it's going to be a collaboration between not only the VMM folks, but the end users, the developers, the infrastructure people, because to go, hit a button and deploy a multi-tiered application containing databases, application logic, web front ends, this is not a small thing. Now, once it's up and running, yeah, it's great because you can just go, hey, let's go back to our example yesterday. We inadvertently flooded a website. Had they been running that web solution on VMM using a service model, they could have gone, oh no, they're flooding our website, give me another web server, and it would have gone deployed another web server in a VM, and all of a sudden their capacity's increased. So to get to that level of flexibility, though, it's a bit of work, it's a bit of planning, there's a lot of things to understand. So I just kind of wanted to inject it, I don't know if I want to say a dose of reality, but just kind of some context around it for, the everyday admins that they're doing things.
Absolutely, that's a great point. And as part of this deployment model, you saw we had the option to use a load balancer. Doing those kind of scale out scenarios is a great example where you just have that load balancer sitting in the front end. When you say scale out, it'll actually reconnect to the load balancer and start using that as an available node as part of that configuration tier. So a nice advantage of putting that load balancer there if you do want to have this kind of dynamic scale as well.
Absolutely. So someone asked, will it be on the test? Probably.
Probably. Yep. Probably.
I don't. I don't know that they're going to say, hey, when you.
We don't write the tests. So.
Yeah. Understand the purpose of service templates. Understand, what is possible. I don't know that you need to necessarily know how to do it all, but understand what's possible.
Yeah, conceptually at least.
And then someone asked a very specific question about the service templates relating to the switches. Like, is the switch that you drew, does that have to be deployed somewhere? And the answer is no. That's what you drew is the logical switch, and as long as all the network cards are associated with the right logical networks, that's how it connects the dots.
Correct. So. Yep. Good clarification. Well, with that, we're going to go and wrap up this module. We're going to be taking a 10-minute break before we then return to look at all these other System Center components. So we're going to go very fast through App Controller with VMM, DPM with VMM, Ops Manager with VMM, and then we might even tease you with some Orchestrator and VMM at the very end. So stay tuned. We'll be back in 10 minutes.
And welcome back. Final session.
That's right.
Day 2 of Microsoft Virtualization with System Center and Hyper-V. Corey Hines, Simon Perryman, your crew of 2 for the last 2 days. Going to look at our last section of the day, which is...
It's really extension with all the other System Center components.
I think you're on the wrong slide.
Actually, we're going to start by App Controller. Then we're going to hit the final module. I had to cut this last one a little early.
I didn't catch that. I was answering questions. Way to throw a guy for a loop there, Simon.
So we're basically going to start with looking at App Controller, how that uses our cloud management. We're then going to go take a look at Data Protection Manager, Operations Manager, and then if we have time, we'll go and spend a few minutes looking at Orchestrator and possibly wrap it up with an hour section on Quorum. No, I'm joking. We won't do any more Quorum.
If you do that, I'm going to say anti-infinity 10 times really fast.
I'll get too drunk then with all those shots. Well, let's wrap this up here by going through our App Controller here. What is App Controller? Oh, we kind of covered the basics a few times here. It is the self-service portal built on top of VMM if you're managing anything in the private cloud, works with Azure if you're managing anything in the public cloud, and then it also works with our third-party service providers. So when we go and connect App Controller to our different clouds, again, it's dependent on VMM or Azure or both. Basically, you could install App Controller by itself, but it's not going to do anything. It's not connected to anything. So essentially, it's an IIS website, and by itself, not going to do anything. But once we go integrate VMM, Azure, we could go get its full functionality. So let's now go over to our Azure demo. Our App Controller demo.
Right.
Man, it's been a long 2 days here, a little sleep between. So here we go, taking a look at App Controller. We went through the navigation at the start of the day, so we're going to skip that here and just actually show you what it looks like to deploy something. Now, taking a look at our existing App Controller view here, what you actually see is 3 different types of clouds: our private cloud, our public cloud with Windows Azure, and then there's this other cloud in the middle here, this other third-party cloud, and this is what we call our service provider cloud. And again, this means that you can really connect to any Windows Server data center that's running System Center and go and manage your resources, your VMs in that other data center. So for example, if I'm running out of capacity in my lab, I could essentially go and deploy more VMs over in Whole Systems Core's lab, and I can start them, stop them, understand the performance, deploy them, scale them up, deploy a service over there. Essentially have the same management functions through App Controller, but we're just deploying it on someone else's infrastructure. And as we really try to think about, what are the advantages of virtual machines? It's allowing you to run that service anywhere. Our end users, who are the people that are caring about that, they don't really care where it's running, right? When you go and sign on to a website, do you care if it's running in a private cloud, a public cloud, a hosted cloud?
Absolutely not. It makes the expression, "you only love me for my hardware," completely valid.
So what we're essentially doing here with this third-party hoster is accessing their resources, deploying there. Now, the way this works with our third-party hoster is it goes through this technology called Service Provider Foundation, or SPF. Now, Service Provider Foundation is built on top of 2 industry-standard web protocols, the REST protocol, and then OData protocol, which is used for authentication. And between these 2 protocols, this is basically the communication that gets sent back and forth from App Controller in my data center over to Core's service over in his data center. I say start a new VM. We write that out, those commands in our REST protocol, encrypt it, send it over, gets decrypted on the other side, figures out the actions, and then goes and performs those tasks. When it's complete, it'll send back a response, acknowledgement, and kind of give us a live status of this process.
Absolutely.
Handoff back and forth. So we're actually going to go and deploy it over into one of these data centers. I'm not actually connected over to Chorus. This is going to be one of our sample ones here, our Fabric Cam. But you can see that I've already got a lot of things running over in my private cloud. So some VMs running private cloud, 2 VMs running in our hoster, and 4 VMs running up in Azure. Now we can also deploy services as well. So, let's just take a look at what a service looks like as well. Does this look familiar? This is the exact same type of service diagram that we deployed inside Virtual Machine Manager with 2 instances on the database tier, 1 instance on our web tier. But it's simplified. It's exposed to our end user. Basically, we've cleaned it up, we've remapped it, and this is what our end user now has the ability to go and deploy, go and visualize. So that's the service that's already running. But let's actually go ahead and deploy a brand new one. Again, all of this is done through a website, right? We do not need to actually go and show anyone our underlying fabric. I click cancel. If you look at the navigation window, we can have access to our clouds, our services, our VMs, our library, but no underlying fabric resources. All right, go back through the deployment again. So question number 1, what cloud? Do I want to go deploy it to any of these private clouds? Deployment production staging. To my hoster's cloud or to one of my Azure clouds, my Azure subscriptions. We'll take our hoster cloud. Then we get to go figure out which templates are going to be used within that cloud. So we'll pick our Virtual Machine Manager template. And this could be any template, right? A pre-configured one. This could be a template running Linux. We're flexible here. Then we provide unique information for this specific deployment. So we're going to go and paste our names in here. Confirm our other settings, so this provides unique information for this particular instance. We see it's connected to Contoso network. Click deploy, and now our VM deployment has started. So this is that end user experience that we've built for, let's say, the database administrators to go deploy their new SQL instance, for our developers to go and deploy their new app in a private cloud. And that is our app controller end user self-service experience. Now we're going to go kick off our final module here.
Right, which, jump back one slide for a second for me. So, sorry, module 13, final module, protecting and monitoring. So essentially what we're looking at in here is two things, right? We're looking at data protection manager, and we're looking at operations manager and some of the framework around that. So we look at the kind of the outline of the module. First thing is protecting with data protection manager. Second thing is ops manager, and then how we integrate VMM with Ops Manager together. So let's stop just to kind of take a look at Data Protection Manager as a tool, as a product, see some of the benefits, some of the components, how we deploy the protection agents, how we configure something called a protection group, and then performing basic recovery options. So we'll begin with kind of an architectural overview of what is included in Data Protection Manager. So DPM, which is included in System Center, as we mentioned earlier on in the day, it's a fairly robust backup solution. It's not maybe as full-featured as some of the third-party solutions that are out there, and that's fine. But as a product that comes with System Center, it gives you almost everything you would need for just about any scenario that you want. And I would argue that it's probably one of the best things out there at backing up file servers, SharePoint servers, email servers, and VMs. So some of the features you've got in there, multiple Hyper-V hosts and virtual machines from a single application. So no matter where the VMs are actually deployed, hosts or clusters, you can all back them up from the one console. It can replicate protected data to off-site locations, to secondary locations. It can even push up to Azure into storage accounts in Azure to satisfy that off-site requirements. It's designed around Microsoft application workloads, so things like SharePoint, things like Active Directory, things like SQL Server and Exchange Server, and gives you very, very granular control over how you back up and specifically how you restore. I can't tell you how many times we've had, we use SharePoint for collaboration, and someone overwrites a file or a file gets corrupted or something, and you can go right into DPM, right down through the site collection to the folder to the file and just say restore it. And it'll pull it right out of DPM and restore it again.
Now we call that item level recovery,
Item level recovery.
ILM. So if you see those acronyms on the test about ILM, think about that's really decomposing a backup and pulling out a specific component.
And you can even, if you back up a VM, you can go into the VM and get a file that you want. You can back up to Windows Azure. It has very detailed reporting and supports all the newer storage technologies like CSV and also SMB3 file shares with System Center 2012 R2.
Now, I think one other thing to mention as well as far as the new feature support is backup during live migration.
Absolutely.
Fully supported, including guest clusters, so you can actually have a connected guest cluster connected to shared storage, a shared VHDX file, something like that. Do all the types of live migration, no problem. And of course, Linux support as well, which was something else we introduced with DPM 2012 R2, so you can do full backup of Linux as well.
Absolutely. So if you look at it just from a component standpoint, you'll see that there are virtual machines with DPM agents and also Hyper-V hosts with DPM agents. Now what we're saying here is that, first of all, DPM uses an agent-based model much like most System Center products. So you deploy the DPM agent to a machine that allows DPM to conduct the backup. Now the important thing to understand is that DPM integrates with the volume shadow copy, the VSS service,
right,
to ensure that when you do a backup, the backup is consistent.
Now, what exactly does that mean? Let's just clarify what a consistent versus inconsistent backup is.
So, as a specific example, if you take a SQL database with transaction logs, you want to make sure that when you do a backup, you commit those transaction logs.
You flush everything out,
flush
so
all the
it's
pending
not
changes.
incomplete, right?
Exactly. Flush all the pending changes, roll forward transaction logs, so that when the backup runs, you have an accurate copy of the data in a state where there's no risk for corruption. And so VSS will take a volume shadow copy, which is a point in time of the volume, back it up from there. If you can imagine, it might take, a half an hour to back up an entire host. Well, if that host's in production, the changes happen on those hosts while it's being backed up. So what you started backing up and what you finish backing up are potentially different things.
But guarantees consistency.
Right, so by taking the snapshot first and basing the backup on the snapshot, and by the way, we're talking about a volume shadow copy snapshot, not a Hyper-V checkpoint or Hyper-V snapshot.
Good clarification, yep.
then you ensure that you're at a consistent state, and the configuration or the state of the machine at the beginning of the backup is exactly what it is at the end of the backup. Okay.
Now, another good clarification around the VSS is each of these different System Center components, Windows Server components, applications like SQL, Exchange, SharePoint, they each have their own VSS writer. And that specific VSS writer is unique for that product, and that writer will know exactly what needs to be done to make the backup consistent.
Exactly right.
So, like for example, with other examples, right? With SharePoint, right, it might make sure that any SQL, you said, make sure the transactions are committed.
Exactly
with the file
right.
server, it's going to flush out the file system buffer.
And so, just to point out the difference between a virtual machine DPM agent and a Hyper-V host DPM agent in this particular slide, what they're referring to is that you can, let's say you've got a VM that's running SharePoint. You kind of get two choices, right? You can say, put the agent on the Hyper-V host, back up the VM as a whole. Or you can install the agent in the VM and do a SharePoint level backup, which has benefits in and of itself. For example, if you back up the VM as a whole, you couldn't do SharePoint item level recovery, where you go in and pull a file out of a backed up SharePoint site. So you're typically going to do a combination of both, where you'll have the agents within the VMs, and you can also back up the VM itself. Now, DPM does support backing up of Linux through volume shadow copy by using the VM level backup.
Backing up the full VM.
Okay. So as an example, just some quick architectural views of things. DPM uses a central console. That one console can manage multiple DPM servers. It does secondary sites. So when you do a backup to a DPM server, you can configure it to replicate to another DPM server, possibly in another site. So you run your backups in Site A, replicate to Site B. Should you need to do a restore, you can restore in Site B from the backup in Site B, which is a copy of the backup that happened in Site A.
So what would be a difference between using this secondary backup site for DPM as opposed to using a Hyper-V replica, sending that to a second site? What's kind of the trade-offs with backup and restore using those options?
Hyper-V replica isn't a backup and restore solution for starters. So let's begin with that. This is not a backup solution. This is a create a replica so I can quickly bring something back online. You're typically going to use that in combination with DPM restore. And really it's all about choice. So you can with DPM, and we do this with our VMs currently, where we run backup through DPM, but then DPM automatically restores the VMs to an offline state on an alternate host. So the net result is we have the copy of the backup ready to start if we need it. We don't use replica for it at the moment. So we back up through DPM and restore, and we get all the versioning and multiple snapshot and points and times of DPM, but at the same time keeps them essentially ready to go. So replica is not a backup solution, it's a replica solution.
Yep.
The two are fundamentally different. So you can, with DPM, back up to Windows Azure. So when you finish a backup, you can actually take that backup, move it directly into Windows Azure so that you satisfy an offsite requirement. And we do this today with SQL databases. When we take backups of critical SQL data, we'll take a copy of that backup and we'll push it straight to our Azure storage blob. So should the entire data center explode, we still have a copy of our data so that we can begin to recover from. So in terms of DPM protection agents, deploying the agent is a very simple process. You go into the console, you configure an account, you go find servers, and you say install the agent. Now what it's going to do is configure a couple of firewall rules so the agent can communicate over the network. It'll show you the status and the health of the agent in the DPM console, but you can also, should you want to, install the agent manually and then tell the agent what its DPM server is. And it's that agent that governs all the backup process on the server. Once that's done, you're going to create what are called protection groups. Now, protection group is a scheduled backup activity with certain parameters like how long you keep the data for, how many backups you do, whether it's a full backup or an incremental backup, and then you can add to that, multiple sources of backup. Things like, this protection group contains some databases, some SharePoint sites, some file servers, and some VMs. And they all share a common set of backup parameters, such as, again, how long you keep it for, how often you do it, and things of that nature. And then for virtualization, as we mentioned before, you can do host-level backups, which is backing up the VM itself. If you do that, it does give you the ability to go into the backup of the VM and pull files out of it. So essentially an offline mount of the VHD to get certain files out of a backed up VM, and then it can be online or offline. Now they mentioned it's subject to in-guest operating system versions. If you don't have a version of the operating system that supports the integration components, and particularly that volume shadow copy provider, The only way that you can guarantee a consistent backup is to actually save state it.
Okay.
So
that way we make sure all that memory is captured and it's not in flux, it's not changing.
So it's something to consider when you're thinking about DPM, that if you're, for example, backing up an MS-DOS virtual machine, just for, you could.
Someone might have a solitaire, need.
You couldn't play solitaire in DOS. Solitaire is graphical.
Oh man, see, that's before my day.
My God, man. There was a conversation over lunch about like machines that were really, really old, and I could relate to it. I'm old, folks. I'm old and decrepit, and I'm falling apart. You're young in my terms. So you could, for those things that are not aware, you can still use DPM to back them up if you've got no other, in-guest backup option. But it would do an offline backup to make sure that what it gets is actually consistent. And then as you go to recover virtual machines, there's some very basic best practices. Obviously, recover to a space, where you have adequate space to do it. Backing up does, impact performance. And a lot of people, when they schedule backups, you need to take into consideration the fact that to do a backup, you're generating I/O. And so you don't want to do a backup so often as to hinder performance. And if you're backing up a lot of data, there are folks that will, for example, do, isolated networks strictly for backup. So. All right, so I believe you've got a DPM server there you're going to bring up.
Yeah,
and
that's
quickly show us
right.
some
Let's
of this
actually
stuff.
go take a look at our demo here. So what we're looking at here is DPM 2012 R2. We kind of looked through everything before, and this is just a clean instance of DPM. It's brand new. And first thing we're going to do is go and add a disk to DPM, which is basically going to be our backup location. So I go and select, we can scan, and what it's basically going to do when we scan is go look for available shared storage. And so this is going to go and list various iSCSI targets I have access to. Now in this case, it's gone and picked 3, showing me what capacity is, and then what the free space is. Now for these 2 disks that show free space, these are actually already clustered and managed by Failover Cluster Manager, which is why they're not shown as free capacity, meaning you should not go back up to those CSV disks because CSV is not used for file storage. Remember, it's used for our VMs. So we're going to go and add this 1 disk. See, I have all my capacity. Disk is online, disk is healthy. So let's go and start to back some things up. So we'll back up our VMs, we'll back up our host configuration, and we'll go back up some System Center components as well. So I'm going to say I want to create a new protection group here. And again, our protection group is kind of this logical management unit for how and what we want to back up. So this is the create new protection group agent. We're going to select protect servers. There are some client operating systems we can back up as well. Then it's going to say within Active Directory, which of these different components do you want to go and back up? So what I'm going to do here is I'm going to go and select VMM01, as this contains a few virtual machines, and it also contains some of our System Center databases. I could go, actually no, let's go and expand Operations Manager as well. And the reason why I'm changing this is on SCVMM, we've deployed a VMware virtual machine. Actually, no, that's now a Hyper-V virtual machine. That will work as well. Okay. In any case, we'll just go and back up Operations Manager here. So I'm going to go select my Hyper-V nodes. Here we go. I'm sorry. I am going to back up VMM. That's where my VM is stored. Try that again. Okay. Back to VMM. Let's go back up this VMM. Now, within Virtual Machine Manager, within DPM, I can drill down to see all these different components running on SCVMM. So I can see on SCVMM I have access to different shares. So this is that default library. We have access to different volumes we can back up. We are really interested in our Hyper-V components here. So we're going to go and back up our SCVMM Hyper-V host, and then we're also going to go and back up this virtual machine that we want to use. Now this virtual machine is currently offline, so we'll do an offline backup here. We'll select next. We'll name a protection group, so we'll call this PG for Virtualization Resources.
So one person asked in the chat window, can you back up to tape? And yeah, you can. There's a tape option right there. We don't have a tape drive installed, but if we did have a tape drive installed, you could actually back it up that way.
That's right, and if we connected this to an Azure account, we'd have the option of the Azure online backup.
And before everyone chuckles, tape backup is still as far as density goes, the best way to get massive density for backups. And it's not slow. Now you might think it is. Their modern tape backup systems are quite powerful.
So next thing I was going to ask is how long do you want to maintain old data? And so you can vary this, maybe you need to keep it for a month. Maybe you have certain legal or compliance issues that change that. And so what we're going to do is basically do incremental backups and then every now and then do a full backup. Then we get to go specify where we want to go and store this data. Now, we have the option of co-locating data as well, which basically means it's going to create a large shared volume that you can install multiple components in. But that usually requires quite a lot of storage to kind of pre-allocate that fixed size. So we're going to select the defaults. Let's do a backup right now. We can also have the option of running a consistency check, making sure our backups are consistent. Definitely a best practice to do that. Confirm the settings. Click Create Group. And what it's now doing is first creating the protection group. It's then going and pre-creating space on our shared disk for the host component and for the VM. Then it's actually, in a minute, going to go and actually take the backup of the VM. So what we're doing right here is not actually doing the initial backup, it's creating the group. Once we close this, we can then see that the backup is in progress. And this will just take a minute or two to complete.
And the cool thing about this view with your protection groups is that if for any reason one of your backups fails, you come right in here, it goes, hey, I failed, right-click and fix it.
That's right, yep. So you get to see all different types of alerts that get bubbled up to our health source monitoring. So we got our first protection group, backups in progress. Let's go and back up our System Center components as well. Now, since DPM is included in the System Center suite, we wanted to make sure it had full support for all of our System Center components. So in this case, we're going to go and back up our app controller database. So this is a SQL Server database, app controller. And then we're also going to go back up our file share. So there's the default file share. And so now this will back up our templates, anything that we're keeping in that library running on that host. Click Next. We'll call this our protection group for System Center. Keep the other default settings. We'll back it up now. And to turn off consistency check. This just enhances the performance in the demo here, makes it go a little faster. Click Create Group, and again, it's going to do those same steps. Create the group, allocate space on the disk, and then we should be good to go for a backup. So this is now going to go through the process of backing it up. Now we're going to show you a quick restore as well. Now, fortunately, the VMs that we've backed up, they're very small. Remember, we kind of spoofed the VHD, made it very small. And so as we kind of go through this, and these errors will resolve themselves temporarily. Sometimes this happens when you do the initial creation. It'll refresh itself and it'll be backed up shortly. So we go through that. We're then going to go into recovery. And recovery is where we'll actually go and restore everything. So if I go take a look at the recovery data, I can see that I can recover Hyper-V, and I can either recover the host component or I can recover our virtual machine. Now, recovery is pretty standard, whether I'm recovering a Hyper-V host, recovering a VM, recovering a SQL database. Really doesn't matter, so we're just going to go and demo this and recover this VM from backup. So I select the VM I want to recover, click Recover, and it's going to give me the different options. So now, I only just created this, so I only have a single recovery point. But if I have multiple recovery points, I would actually have multiple options of which version I want to recover. Now, as I go through the recovery wizard, I'm also given several options here. I can recover to the original instance, and that effectively replaces it. I can recover as a VM to another host, and this is basically going to go and clone the VM. We can recover it to a network folder, so it will store that VM and its configuration information in an offline state. But let's go and recover the original instance.
Now, while you're just kind of clicking through that, someone asked a question, will DPM back up physical servers? And absolutely, yes. You put an agent in the operating system, it'll back it up. Physical, virtual, it's irrelevant.
That's right, yep. And there is, of course, a VSS provider for Windows
Absolutely.
Server, for clustering, Hyper-V,
When we talk
pieces.
about, in-guest backup, that's the same thing as physical server backup, right? It's just you're putting the agent in the operating system, VM, physical machine, it's irrelevant. The only thing that's different is the VM level backup goes on the Hyper-V host. So that's kind of the different thing.
That's correct. All right, so now what it's going to tell me is it's going to go and restore these two pieces. It's going to restore the VHD file, and then it's going to also restore the configuration information. Click Recover. Those two pieces are going back to the original host, restoring it there. And, now recovery time can vary based on how much data you're copying back.
Obviously, yeah.
This particular VM, a small amount of data, this restore will take about 30 seconds to a minute.
The chat's blowing up about DPM here, quite honestly. A lot of people are kind of haven't even considered it or looked at it or seen it, and what they're seeing.
It's free. Hey, you get System Center 2012. You're getting it for free
Which
now.
is one of the questions that's in here is, hey, what's the licensing? You have System Center, you have DPM. In terms of does it support tapes? Yes, it supports tapes. Are tapes going away? No. You can buy very modern tape systems. Per dollar per gigabit, tape systems are much cheaper than disk. So for massive backup archiving, tapes are much better than disk in terms of cost per gigabyte per storage. Does DPM support Exchange? Yes, DPM supports Exchange. Can you use USB as a backup location? I don't think so, though. I've never tried. I don't think you can.
Ooh, probably not directly. You could probably kind of do a double hop backup.
It would recognize it as a removable drive, I think, and I don't think removable drives are valid backup options for within DPM. Can it back up a physical server running Linux? No, there's no agent natively that goes in Linux for DPM.
So we should clarify. We mentioned it can back up Linux before. That's a Linux virtual machine because it's backing up that whole VM.
And I think those were the big ones that we saw come in here real quick. So USB tape drive. Yes, if it's registered as a tape drive and DPM can detect it as a tape drive, the way it's connected to the machine is not going to matter. So USB tape drive, yes.
Alrighty, well, we will now move on and talk a little more about Operations Manager integration. So we gave a brief overview of Ops Manager before. Remember, it's monitoring throughout the stack. Highly extensible. You can really monitor anything that has any type of counter, any type of alert, any type of events that are generated from it. Essentially, you can monitor anything that we can programmatically read data from, meaning an event log, an alert, something like that. And the way we go and organize these collections of activities that we are looking for is through this concept of a management pack. So basically, a management pack can include, different monitors, rules, views, and what it's really doing is providing a connection between the specific service and Operations Manager. So let's say, for example, we have a management pack that will go and monitor a failover cluster. It's going to take a look at things such as how much disk space is on the CSV volume, are the nodes healthy, how much free memory are on each host. So kind of going through the basics, things that it should be detecting if there's any real-time issue with a cluster host. But now what the management pack really does is it goes and aggregates that information and pushes it out in a presentable format. So if I'm looking at the health of my clusters, I don't want to see 5,000 events in an event log. I want it to figure out what's important to me, highlight those, prioritize them as critical, and that allows me to more quickly analyze what I care about, what I don't care about. Now, Operations Manager is also able to integrate within Virtual Machine Manager. Now, the way they do this is through creating a connector between the two different components. Now, a few different ways that they interact here. First of all, Operations Manager can actually go and monitor the VMM server. So it can monitor VMM for host, reliability, making sure that VMM server is alive and active. Additionally, it can monitor the SQL databases that support that VMM server and every other System Center component. So that's step one, Operations Manager monitoring VMM. The other part of monitoring is through what we call Pro Tips. And Pro stands for Performance and Resource Optimization. Essentially what Pro does is it will take alerts created by Operations Manager, and if they meet certain requirements, tell Virtual Machine Manager to perform a task. And generally, you know, the most common way pro tips are used is very similar to dynamic optimization. It's kind of monitoring the resource utilization on a host. If it gets past a certain threshold, it will send an alert, cause a live migration from one host over to another host. Now, what is the difference between dynamic optimization and pro? Very possible you'll get these on the exam. So let me go through this in a few steps. First of all, dynamic optimization is new to 2012. If you're using an earlier version of System Center, Pro was actually the only thing you could use. And essentially what Pro does is, you know, go send those alerts, take actions based on the alerts. Now, in our older versions, you know, Pro was used for this most common scenario. Look at host memory. When it passes a threshold, go trigger a live migration. And that's really what dynamic optimization can do today. It looks at those 4 thresholds on the host. And you might get asked these thresholds again, so we'll quickly review. Memory, disk I/O, storage I/O, and disk I/O, network I/O, and CPU. Now, the difference between Pro is that Pro allows you to customize the triggers. Pro gives you other values that it can cause triggers on. So maybe instead of just looking at disk network storage, you're looking at the number of users that are logged onto a particular host. Based on the number of users that are logged onto a host, maybe you then want to go and migrate a virtual machine around. So think of it as even more extensible.
Can I give a specific example of that? One of the things dynamic optimization cannot do is trigger a live migration if the ambient temperature in your server is getting too high because it's experienced a failure of one of the cooling fans.
Oh, interesting. Interesting scenario.
Not that I've ever seen that really happen. I have, but that's one of the things that Pro can do, because Pro uses the management packs of Operations Manager. Now, when you look at, you know, some of the hardware providers that are out there, a lot of these vendors provide hardware-specific management packs. For example, we use a lot of Dell servers. They have management packs for Operations Manager that connect over their BMC ports to gather hardware-level information to feed into Ops Manager that we can then use to make decisions on things. So, for example, if we have a fan that fails, that can bubble up in Ops Manager. And if that's a Pro-enabled management pack, that can trigger a cluster migration to get the VMs off of that node, because that node temperature is slowly building and it's soon going to explode.
Great example. So again, to summarize the key differences, Pro gives you more flexibility, but big trade-off, you're required to have Operations Manager. So if you only have VMM in your environment, you can use dynamic optimization. If you have VMM and Ops Manager, you could get even more capabilities by doing this integration between them. So let's actually, one final thing to mention here, some other monitoring components. We mentioned that you can monitor throughout the stack. I mean, this really does mean throughout the stack. You know, hardware, software, virtual machines, hypervisors, guest OS. And there's also what we call a Fabric Health dashboard that's now pre-configured with an Operations Manager that kind of shows a view of all your Fabric resources that VMM is consuming and using. So let's go over to our demo. Here's our Operations Manager server. And here's our monitoring dashboard. So as we kind of take a look at some of the things here, it's finding some problems that we probably would have never known about unless you really are using this. You know, a particular component failed within a database. The login failed. You might notice that one.
Your network's not looking so happy there, Simon.
It is not. We got a few issues. Now, in fairness, just going to say there's one particular component here that's triggering a lot of alerts. I won't say which one, but just saying there's a lot of alerts that aren't coming from our Microsoft systems here. Now, this is kind of the monitoring overview, and you can kind of see, hey, we've got Windows computers. It'll give you an all-up summary of them. Looks like I definitely got some issues in here to investigate. We can monitor our SQL servers. So taking a look at our SQL databases, any alerts for them. So we can see I have some alerts based on misconfigured run as accounts. And as I drill down to the database, it's going to give me, some additional information about what is causing that problem. We then have our Virtual Machine Manager monitoring. So we can monitor the health of agents, the health of your resources, performance monitoring. Virtual Machine Manager with Pro. And it comes with some pre-configured Virtual Machine Manager views. So building up different topologies of these different virtual machine manager components, managed resources, VMM infrastructure. Zoom out a little here. And the nice thing about this view is you can really kind of break this down into the different components. You know, what is my data center, what is my cloud, what is my database, and kind of drill down through the health of each of these.
Folks, you can make a career out of being an expert in ops manager.
Absolutely. We, of course, have a Hyper-V management, so we can see the view of our virtual machines. Probably not going to see any. Yep, here we go. Okay. So our VM is healthy. It's functional, just not online. We can see views of our virtual networks. We then have default Windows Server management packs, looking at the overall health of our Windows Server infrastructure. So here's an example telling me that I have high disk defragmentation. And you know what? I can then even go and assign these different alerts to particular people. So if I wanted to go and assign this to a developer to say, hey, one of the pieces of code you're writing is causing fragmentation in our database, we have this option to say assign to engineering. We can click apply, and what this can actually do is if you have Team Foundation Server configured, which is basically a project management solution, it will actually go and open up a new bug inside Team Foundation Server. It will figure out which developer owns the particular binary or component that was affected. It will include any repro information, bug tracking information, and so, you know, when your developer comes to work the next day, they open up TFS, look at their task list, hey, we sent them this alert directly to them, opens up a new bug, and includes all of that repro information as well. So again, another example of how we're trying to add more agility to the infrastructure around DevOps. We could, of course, monitor our networks, monitor the Operations Manager server, Data Protection Manager, System Center Advisor, Unix, Linux, VMware, pretty much everything through our stack, and of course Windows Azure. And you know, we can even monitor third-party websites like Amazon AWS has a management pack.
How many management packs are downloadable in the catalog?
Hundreds.
Hundreds.
I looked a couple of weeks ago, and including all the different System Center versions, 425, something like that.
And so, and for those that are kind of playing along at home, what is a management pack exactly?
The management pack is that collection of unique objects that we pull from a source, we analyze, and then present.
So it's basically it's a list of things to look for under certain conditions and the rules.
Much easier way to say it. It's the stuff we're interested in for that particular service, that particular application.
And so someone said, can those Opsman alerts go right into Service Manager? Absolutely, they can.
Very easy connection, yeah. You know, one of the things we do try to do within Ops Manager, you know, is tie things together. So you can have an alert that comes up in Ops Manager that can create a ticket in Service Manager. You can have an alert in Ops Manager that can trigger an action inside Orchestrator. In fact, let's take a quick look at that. What we're going to do here, we are going to go into Orchestrator. And you can see here that we can go and initialize tasks. We can initialize checkpoints. We could take a look at, actually, let's go and find our Operations Manager scenario here. We can go and update alerts in Operations Manager. So we can get an alert. We can understand what is the name of that alert. What category is it in? Who is the owner? What's the NetBIOS name of the computer? Go do some text editing. So we'll add it as parameters. Go update that original alert. And then we can write that into the system event. So you really do have a pretty broad range of capabilities here. Now, Corey, I think we are kind of getting close to wrapping up here. Are there any questions that we see coming in here?
Not a whole lot at the moment that are popping in that we want to address immediately. A lot of questions around DPM came in. A lot of questions around the integration between Ops Manager and Service Manager. And the reality is, one of the coolest things is that the integration is actually really simple to do between Service Manager and Operations Manager. And the cool thing is that when you get an alert in with Operations Manager, it immediately raises an incident inside a Service Manager. You can then take that incident, resolve it in Service Manager, type in a bunch of historical information, and then that'll resolve the incident as well in Operations Manager. So it becomes just another layer on top of the stack. Now, you have a demo here you want to show of, I think, this?
I do. So what I'm actually going to show you here is, this is my final demo of the day. I am going to integrate IIS and alerts with Operations Manager, with Service Manager, and with Orchestrator. So hopefully this is kind of going to give you an all-up view of how powerful these integrated solutions
My fingers
can
are crossed on this one for you, my friend.
Fingers crossed on this one. All right, so let's take a look at the different components that we're going to work with here. So we have Service Manager for our tickets. We have Orchestrator for our runbook designer. Operations Manager for our alerts. And then we're going to go load our website, our Dinner Now website. Okay, now in this scenario, I'm an IT department, right? The problem that my IT department has is this website is always crashing. We don't really know the root cause, but it happens every day, every couple of days. And we can always go through the same steps of fixing it. Our internal knowledge base article says, try this, then try this, then try this. And usually one of these things work. But since this is a repetitive, standardized series of operations, we're going to go automated. And this is where we're really trying to take advantage of this private cloud. Repetitive task, build automation around it. So let me go and just minimize this and actually simulate the error itself. So I have a script that's going to go and crash my website. We'll go take this up and refresh it. And sure enough, my website is down. Website is unavailable. Now what's going to happen is through Operations Manager, we've actually gone and we're monitoring this website, monitoring the IIS server. And so what should happen now is if I open up Operations Manager, take a look at my active alerts, I can now see under Active Alert, Dinner Now, Web Application, website is unavailable. Now what this is going to do is this alert will then go and create a ticket inside Service Manager. Now, as an IT department admin, even if I'm going to automatically fix this problem, it's important for us to go and add a ticket for this, for us to go and inventory this, simply for the fact that we want to keep track how many times is this problem happening, what's the impact, how much time should our IT department invest in finding the root cause of this problem. So let's go into our work items, take a look at all of our open incidents. And if I go and filter this by Dinner Now Web Application, here we go. We can see that this ticket has now been created. So again, crash the website, create an Ops Manager alert. Ops Manager alert creates a ticket. Now this is where we're going to go and connect this to our automation. Now let me just take a step back. Operations Manager could call Orchestrator directly to fix this, or it can go create a ticket, and then that can in turn invoke Orchestrator. But again, we're trying to follow some best practices for once today and actually go through the process of including Service Manager here. So what we see here is I go under Edit, I take a look at this particular problem, and so every time we see this problem, we have what we call an associated activity with it. So we hit this problem, it's going to go and trigger this activity. And this activity here is a website remediation activity. So we'll close out Service Manager, take it over to Orchestrator. So Orchestrator, what is your web remediation activity? Well, as we kind of walk through this workflow here, step one, get the incident. And so this is basically having Service Manager in this case, but we could also have Operations Manager go and raise this problem. Now, the good thing about Orchestrator is its ability to pass parameters around these different systems. So we talked about this as a way to do graphical scripting. Now, when you think about scripting with PowerShell, you pass these different parameters around. We're going to kind of do the same thing, but do it through this graphical user interface. So we're going to get this incident. First thing we're going to do as part of our attempt to fix this is actually test the website. Maybe we had a network hiccup and we accidentally created a false alert and the website is fully operational, it's running. So we're going to go and actually test whether the website's really running. And if it is online, we'll just say this is resolved and this will close the ticket inside Service Manager. IT department doesn't have to look. Now let's say this doesn't fix it. Well, then we're going to go and try troubleshooting step number one, according to our knowledge base article, which is restarting IIS. That usually fixes it for us. So we're going to go test again. If it's fixed, we close it. If it's still not fixed, then we're going to go and make it a little more complicated. We're going to actually go into IIS and restart our application pools. Now, this sometimes works, so we're going to kind of do this in a procedural order. Try the most common way to resolve it, then less most common. Test the website again. If it's up and running, we mark it as resolved. If it's still not running, then we're going to go escalate. Only then should we get a person involved and actually, pull in man hours and try to figure out this problem, because it's not standard, it's not unique. But 90% of the time, we can fix this without even having to think about it. So hopefully now this has gone and fixed everything. What I'm going to do here is go and refresh Service Manager, and if this workflow worked, one of those two attempts worked, the alert should be closed. So there's the alert. We'll click refresh. Alert has been closed. So this is good news. This indicates that the workflow worked. We'll then go back into Operations Manager, refresh our active alerts, and we see that that alert has also disappeared. So it's also been closed in Operations Manager. All right, here comes the big test now. Hit refresh. Will our website be back up and running?
I'm going to bet a bottle of bourbon it will.
Well, I do not accept that bet, because I know this is going to be consistent and always work, right? So what you saw here is really our ability to tie these integration products together. There was a problem, we raised an alert, we inventoried it, and we automatically fixed it, closed everything, our infrastructure is back up and running. And so this is really where we see the power of System Center coming together, tying together all of these products for physical, virtual, and all of your diverse infrastructure.
Well, I don't know about you, but that's one heck of a 2 days. Take a deep breath, man. You did fantastic today. It was a lot to cover. As you guys, obviously kind of noticed, yesterday was Corey Day, and today was Simon Day, and it's not easy to present that much information in that window of time. So fantastic work. So again, just kind of an overview of the course and where we kind of ended up today. Today we did System Center. Yesterday was all about Hyper-V, so things like how we install, manage Hyper-V, how we work with VMs, how we do the networking, how we do the storage, how we do the clustering, how we do virtual machine migration, how we do replication of virtual machines, everything about the core hypervisor in the product. Once you start having lots and lots of Hyper-V servers, then it becomes a management question. That's where we moved into System Center on day 2.
And with System Center, we kind of reviewed everything from the ground up and really kind of built that infrastructure up as we went along. We first looked at planning our hosts and our physical infrastructure. So remember, VMM, a lot of planning there. We planned our networks and built them. We planned our storage, built that. Added our clusters, connected all the pieces. We then put together our library so that we can build and reuse resources. Create some VMs from scratch, VMs from library, take some Hyper-V VMware virtual machines, make them Hyper-V, and then go and add some of our cloud management capabilities on top. So this concept of clouds, different user roles, different security, and then services. Finally, we looked at all of our other integration points with System Center. So managing through self-service with App Controller, backing up with Data Protection Manager, monitoring with Operations Manager, and then, of course, automating, tying everything together at the end with Orchestrator.
So that's it. I think we're about done.
We are. As we wrap up, we want to point to a few resources here. Other broadcasts like this are going to be available and announced on the Microsoft Virtual Academy. This recording will be available on the MVA by late November 2013. If you want other training, of course, back to the MVA and check out the other courses from Microsoft Learning, part of their official curriculum. We also want to really thank everyone that helped us out here. Our production team, our project management team, and especially our Q&A team who have donated their time to help answer questions, help make you guys more interested within that. So please, thank everyone that's been involved. Thank your Q&A team if they've been particularly helpful. And now, big question of the day. Where do I get my free exam voucher from, right?
Everyone's been waiting for this one.
Man, we've been teasing you. You will get your free exam voucher in an email sent out on November 27th. 2013 if this is recorded. So one of the benefits of viewing this live, get your voucher, go get tested, worth $150, take this exam, pass it, go tweet to us, go tweet to Microsoft Learning if you pass.
So I'm going to leave you with one final thought just to clue up the latest sort of conversation here in the chat forum. And just set the record straight, cricket, like American baseball, is not actually a sport. There is only one sport, and that's hockey, eh?
Well, I think there was one final question that's come out as well. Where is my accent from?
It's generic.
I was born in England, raised in America. So for all of you guessing over the last 2 days, there you go. That's the answer for your final question, and that one will not be on the exam. Thank you, everybody, for attending. We hope you loved it. And please stay on the line, answer our final survey. Tell us if you liked it. Give us feedback. Tell us what other courses you want. We want to see you back. We want to see you using Microsoft technologies. Thanks, Corey.
Thanks, Simon. Good job, man.
You too. It's been a good time. Thanks, guys.